All good? No, I'll be another minute. To introduce and then we can switch. That's all right. Okay, all right. Okay, good morning, everyone. Let's settle down and get proceedings underway. We did build in a 5-minute buffer in the beginning so that people have a few minutes to settle down. This is the second of our 2 days of presentations. Yesterday, we heard from the audio generative modeling team, and after that, we heard from the team that was looking at evaluating LLMs in research astronomy. Today, we have two equally, if not more exciting presentations. One from the team that's working on sign LLMs, large language models for sign language translation, and from the team working on AI-curated democratic discourse. The agenda is kind of like yesterday. We'll start with a 3-hour block dedicated to the sign language team, and there'll be a break in the middle to refresh your coffee, go to the bathrooms, and then we'll break for lunch. Today we break for lunch a little bit early. We break at 12, and then we go 12:15, and we go till about 1:30. We come back here at 1:30, try to finish the technical parts by 3:30, and then in the end we'll have a set of closing presentations. There are a couple of exciting things we want to tell you about. One of them is there's a plan to try and do some follow-up in the winter for the work that you started now. Maybe not 6-8 weeks, just maybe a couple of weeks or 10 days or something to try and keep the momentum of the teams going. The other one is we've started making plans already, like I told you yesterday, for next year's workshop. You'll hear a little bit about that. And last but not the least, there are many, many people who make the workshop possible, and we'll take the opportunity to thank them before we close for the day. And those who are here for the workshop itself, rather than just visiting for the day, remember there's a party after that. So you have a little bit of a break after the last presentation, then we get together again, and those instructions, as I said, are on the website. So without further ado, let me ask Marek to come up. Marek, please get going. We'll have to switch laptops, so I will ask the CLDT folks to do what it takes, and then go from there. All right? Okay, settle down.
It takes a while. Okay. Nice. It's mirroring. Maybe check. Good. Just as another. Here, Richard.
Hello. So let me introduce to you our project and this workshop of JSALT 2024. We are the SignLM team, and we named our model Sign Lava. And first of all, let me just remind everyone what are we trying to accomplish here. We are working on sign language translation, and in particular American Sign Language translation, but the methods can be generalized to any other sign language. And it's actually a process when you try to, from a video, try to understand what the person is signing and translate it to English text. And this wall of text tells you what is sign language. You do not need to read it. It's there for you if you want to read it in future. And basically what I want to tell you about is that sign language is composed mainly out of two components, which is the manual component and non-manual component. And both are equally important in sign language. Manual component tells you about how you move your hands, what hand shapes you have, and gives a little bit of form to the sign. And non-manual components are like a flavoring to the signing, but are very important. They include facial expression and body language. You express some kind of semantics or emotions, and they can even change the meaning. And sign language, in this sense, must use both of the components. If you do your signing without the facial expression, really are understood much worse, and you do not convey the meaning of the signs pretty well. And also people think that sometimes think there is only one sign language in the whole world, but that is absolutely not the case. There are approximately 300 sign languages in all around the world, and in USA, around 3% of people report actually using ASL daily. So that would account for approximately 9 million people in using ASL. And of course, when you check the numbers, for example, in Czech Republic, the percentage of people using sign language is approximately the same. In this image, you can also see the different families of sign languages. Some of them have developed, like American Sign Language is now considered its own family, but has been developed from the French sign language as many of the other sign languages. And there are several schools, because the sign language actually is a natural language that is developed by the people who are using it and who that need it for their daily communications. So it's nothing that is synthetic, and it's an ongoing process of creating the signs. And actually, what is sign language translation? I heard Jason say a good name for it. It's a black sheep of machine translation, and maybe, of course, of NLP. But NLP is a big part of it. Natural language processing brings to it the models, the architectures that were developed, let's say 10 years ago, like transformers and generative transformers. Also, a big part of it is linguistics. You need to be able to describe the rules of the sign language and to draw from them and to create your technologies based on them. Of course, you need technologies from speech, because the signal is a sequence of frames, and you need to somehow approach it in a similar way as speech, because everyone can sign differently, different speeds, and everybody has a little bit of different body, so the sign language seems different from every person. And there are methods like WAV2VEC, which we adopted in our systems that handle such cases. And of course, you need vision, because the input is visual. So you need some kind of vision processing to understand what is happening in the video. And for that, we use mostly self-supervised methods like Dino or maxed autoencoders. And we will speak about these individual techniques in the upcoming slides. So I am Marek Hrus, and I am the team leader of our project. When I was here in winter proposing the project, as Sanjeev said yesterday, there were, of course, many changes, brainstormings, and making the project better. And I have to thank Florian Metze, who actually brought this idea in one of the meetings, that we should try to adapt large language models, such as Llama, to be able to understand the sign language and give it sign language capabilities. And this is what we did. And of course, I needed to compose the team. So I would like to thank all the seniors in our team, Kevin Du, Ivan Gruber, Murat Sarachlar, and Lala Akarun, who actually brought the expertise to the team, brought the students, and brought all the colleagues. And they were very good at their job and made it all possible to happen. But of course, seniors, they are one thing. You need someone who actually does the work, right? So for this case, we have some grads, and we actually, just before the workshop or during the workshop, 3 PhDs were produced. So I would like to also thank them for their hard work, because it's not easy to do your PhD and also to concentrate on the workshop. So thanks to Dr. Xuan Chang, Dr. Dominik Macháček, and Dr. Balázs Yusuf. So of course, other grads were present who are on their way for their, either PhDs or masters. So that is Jiří Majer, Chester G, Jakub Straka, Tomáš Železný, and Karahan Shahin. So thank you guys for the hard work you did. And without you, it wouldn't be possible. And of course, as Sanjeev mentioned yesterday, you need someone who doesn't know much, so they can try out the things the seniors refuse to try. And those are the undergrads. So Václav Javorek, Ondřej Valach, Richard Funk, and Alessa Carbo. So thank you all, guys, and good job. Now I have some kind of summary, what we actually achieved. So there are a few, let's say, outcomes. There is the research part of it, where we have the code base that enables us to produce modular framework for the sign language to language processing. And we believe this framework can be utilized in many ways, and its modularity allows it to be able to configure it and play with it and try it out, experiment with it. And also we utilize the language models to do multitasking based on language prompts, which might be extended. Of course, we have some communal outcomes. I will talk about them in the end. We have some good data for the community to share, and also some features and stuff that can be used in data. And we produced a demo that is actually not useful only to demonstrate what we do, but also helps the researchers to understand what their models are doing, how are they behaving, and it's very engaging, and everyone who saw it was really into it. So those are the major outcomes. And now to the architecture of our model. I will explain it a bit so that you can better understand it during the presentations. So this slide shows the large language model. In this particular case, it was Llama, which uses system prompt in a sense that we made the system prompt that the system is a instructor of sign language capable of translating sign language into English. And then you have the instruction when we actually ask the model to translate the video of ASL into English. And since I have been talking about the components of sign language, we try to address this in a sense that we use several visual cues to help us describe the sign language as best as we imagined it can be. And for this, we use a newly developed method Sign2Vec, which uses poses to quantize them and produce representation. Then we use mask autoencoders to capture the global view of the person, so that the model has an idea about the proportions of the person. and then Dino that analyzes individual parts of the human body, in specifically hands and face, without the global information. It focuses on the individual shapes. So this is the main idea, and then we, during our stay here, and thanks to Richard, who was able to give us some insights into how the sign language actually works, we realized that the standard method of recognizing sign language and translating sign language is clip-based. And clip is just imagine a few seconds of video when the signer signs something and there is a translation for it. But when we were observing the clips individually, we quickly realized that it's not possible to translate it like this because it's very context dependent. And for example, in sign language, at the beginning of your utterance or you actually can define some new signs that represent concepts. You can utilize space and refer to the space without signing the sign again, and so on. So therefore, you need the context. So we actually developed a system that is able to train with or without context. And also, we saw that many times the context from the beginning is very important. So we actually also implemented a system that can keep the first few clips in a context and then moving as the clips go. And then you just add the context into your language prompt to help the model better recognize the following clips and translate them. And on the multitasking part, we played with keywords. The model was estimating whether a keyword is present or not, and also we tried to add another multitask or whether the clip is reversed or not. And this is something that can be added easily to the model because the interface is just the language prompt and the translation. Okay, and this is the outline, and we will be talking about sign language translation, how it is different from machine translation. Then we will describe the data that we used in our project. We will speak about how we actually process the data, because it's not as easy as it might seem. Then we will describe the individual sign representations, meaning sign-to-vec, mask autoencoders, and Dino. And of course, text augmentation. We realized that the translations are very specific, and the signing can be translated in many other ways. So we played with this. Then the major architectures of Sign Lava will be presented and how it works. Then we will show some results that we have, and in the end we have reserved time for showing of the demo and so that you can see what it's capable of, and then we will conclude it. So I would like to ask Dominic to come on stage and present his part.
Good morning, I'm Dominik Macháček. I'm from Charles University, and I will continue with introducing our project from the machine translation perspective. So at the very beginning, I will tell you what are the biggest problems of sign language translation that we face. So first, it's the sparse representation, and then the data acquisition. And I illustrate the sparse representation here on this slide. So how much data space do we need for one word in text? So average English word has around 5 characters. In UTF-8 encoding, it's around 5 bytes. It's fine for NLP for processing and so on. In speech audio, if one word has on average 330 milliseconds, and we encode it in a 16 kilohertz WAV, then we need 10 kilobyte space for it. And for sign language video, if it has the same duration as in speech, then the size of file that is stored on disk is around 110 kilobytes per second, but then we apply codecs and then the codecs decoded into 30 frames per second, each having some height and width and 3 bytes per pixels, and therefore the final size is 27 megabytes. And the problem is that this representation captures some information that is not in meaning, but still it is still represented. For example, the speed or the transitions between signs. There may be some noise, the recording conditions matter, the background. For example, on the left, you can see some shade behind the man, so this information is still covered in the video, but not meaningful. Every person has their own ideolect. It's the way that they are speaking or signing. The social linguistic characteristics, they depend, and the evolution of language. So these two pictures are from one teacher of American Sign Language, and he created one demonstration how to sign a rabbit, and then some years after, as we can see from his bird, that on your right, his bird is more gray, so a few years apart were between these, so he signs differently. And there is analogy in speech translation and speech processing that there is also this sparse representation, so we can inspire ourselves from the audio transformer team and from speech translation. And the difficulties of data acquisition are very specific for sign language because there are not as many users of sign language as users of English, so they don't generate so much data, and also anonymization of data, of sign language data is impossible because we always need face because it captures meaning, and therefore we cannot anonymize sign language data and then use them, and therefore we assume that only professionals donate their data for research or for parallel corpora are very limited. The open data are also very limited. The hard part is to identify what is the sign language that we want to use. And linguistic resources are very small and limited. So now our architecture is end-to-end from video into text or sometimes through poses. So I will now tell us why. So there exist these 5 sign language representations. First is video. Then there are poses. The poses are like extraction of the body poses that we suppose are important for meaning. Then there exists notation. It is some analogy of writing system for sign languages, but they were proposed by linguists and they are not adopted by sign language users, and therefore the data are for notation or with notation are very small and limited, not very useful for sign language processing. And there exist glosses. Glosses are like labels that English users give to individual signs. And this representation of glosses, it captures or it includes the morphology and syntax and the grammar of sign languages. And it looks like English, but it's not English. It's just writing what a ASL user would use. And then there exists text, which it is like translation of the video into English. And so in past, the most used approach for sign language translation was first into glosses and then from glosses into text, either through poses or directly. And that was because there weren't much data. There were around 11 hours of Phoenix dataset that could allow gloss transcription. And also the compute resources were not available and people thought that direct translation was impossible in past times, but today it is possible. There are computer resources, there are more data, and our system is like this. We use two representation directly from video to text, and the media pipe model that extracts the poses, and then sign to vec from poses to text. And now I will speak about our contribution, first our plan and our contribution about evaluation of sign language translation. So in our project proposal, there was idea to use how to sign dataset for testing our system, but how to sign, what is how to sign? First, there were spoken English videos. Then some researchers collected them into how-to dataset. Actually, it was a project or part of a project in JSALT 2018 right here. And they did it primarily for multimodal translation. Then another group selected a subset of how-to videos. And they hired professional interpreters, and they interpreted it into American Sign Language. So the source site, or the original source site of how to sign is English, the target is ASL, but our system is for the opposite direction. And therefore, using how to sign for evaluating English to ASL to English model is okay for measuring progress of research and for comparing to others, but it's not good for assessing machine translation quality in real-world use case. The problem is that the source site is translated language, and there are evidences or some references from machine translation that this translation language, called sometimes translationese, is usually simpler, shorter, and less variable than original language. And also how to sign is like optimally segmented to English-like sentences. And there is a small variety of signers. There are 11 professionals who sign there.
Dominic, I wanted to ask a bit more about this translationese to original. For some of us who don't follow this literature, what's the difference? Like, for example, are there numbers, for example, to say that if the original was Chinese text and somebody translated to English and you're translating the Chinese to English, it's this difficult. However, if you take the same material and treat it as English to Chinese translation, what you're implying is that the English is simpler because it was translated from Chinese. So it'll look like an easier translation task. Correct? So what's the difference? Is it like 5%, 10%? How much will I fool myself by?
I don't know. We should look into the paper or ask Philip. He's one of co-authors.
Ah, okay.
And I suppose that the source site is simpler, but the target site, the original language, is more difficult than natural occurring translations. And we also suppose that right now we are in early stage of development of the technology, and using not good test set will be okay because it would show us the right way, as well as a good test set. But there is a risk that we could shift too long. So I propose we should create a good test set now, although there is hypothesis that we don't really need it right now. And for that, how to create a good test set. So first, also a slide from Flipken from the summer school. How is a typical machine translation used for communication, for assimilation and dissemination? And in our context, for our machine translation from American Sign Language into English, the communication would be between English and ASL users. Assimilation means that when an English user is interested in ASL content, he can use the technology. So he initiates the translation. And then dissemination is when American Sign Language user wants to spread some message into English users, then he could choose this system. And we are just starting with creating our system, and we don't know yet for what our system will be used, but we can presume all these options, and we can start exploring for which how it will be used. So for communication, we assume we would need user partner, or that will give us real world data, or that will tell us, please generate this data from this script or from this description, and we don't have them yet, so we're not there yet. And for assimilation and dissemination, we can make one assumption to focus primarily on data that are, or for content that is only in American Sign Language yet, and that could be a primary use case of machine translation. And we assume that it could be used on someone who has a nice personal story and would like to share it, or people who would be interested in it, or the opinions of signing people, or fiction that originates in American Sign Language. And we assume it won't be used much on weather forecasts or sport or spoken word news, because anybody who would like to receive information from these topics and is able to use machine translation system, and at the same time could use just Google or get the information easier than from signing person. So we don't primarily focus on it. And our contribution is that we create a plan how to acquire a new good test set. So, and our plan is not optimal because we don't have much resources to ask signing people to donate our data and to collect their permissions, archive them, and so on. But what is possible during JSALT is that we focus on the priority categories, because ideal test set should match the authentic use case. It should be large, so we aim to select videos that are already translated. We don't translate them on our own because it could take much longer, and we would not be able to find lots of data. The test set should not be overlapping with train set, so we select videos that are newer than existing train set. It should be permitted to release. And this is the biggest weak point of our approach. We don't release the data, we point to YouTube videos, because this is the state of the art in computer vision data. It should be persistent, and the most that we can do is to select the videos from renowned YouTube channels that we suppose that will be not deleted from the internet. But it's not ideal, but still better than nothing. It should be document level, reusable, correct timeline. So we ask some ASL expert to check the translations and to correct the time alignments. And we aim at channels with many guests. So the progress with our test set.
Dominic, can I interrupt you with a question? If you go back one slide. Can you say a bit more about what it means to have time alignments between sign language and its English translation?
Yeah.
Is it monotone? Is it?
It's not word-to-word alignment is not monotone. It's like in translation, there is reordering, but we aim at alignment on the level of phrases. So or on the levels of translation units, and we don't know yet what the translation units will be, but we can do kind of several seconds, just as the captions in videos, but the captions in videos are not time aligned. There is one word there or back. They are made for reading. Yeah, so right now we selected the candidate videos. One very good example is Daily Moth. It's a news interview with a couple that tells about their big misfortune that semi-trailer truck crashes into their house. So we assume they represent the signing community, and they speak, they have a story that is worth sharing. Right now we have some preliminary work, our estimates that if we would translate the videos from scratch, it would take us 18 times more time than the video duration, and correcting time alignments took 40 times longer. But this is only one annotator and only one video. We aim to make it faster and process more data. And what is also not done yet is evaluate our test set on real-world data. So I will stop here and I give, oh no. So we wanted to explain what metrics do we use. If we have a test set, then we use machine translation metric. And our primary use metric is BLAIRD20 because it's reliable in WMT metrics share task, where they compared the quality of machine translation metrics, or how they assess human judgments. It was scored higher, and the higher scored metrics are not available for our case. Secondarily, we use character F. Someone may pronounce it HERF3 or HERF, and blast score for back dependency. And now I will give word to Chester, who will speak about data.
Right, yeah. My name is Chester. I'm Chester Glew. I mostly work at TTI Chicago. I do research. So you have a problem of data, like in sign language. It's really like, as Jason said, the black sheep of NLP, because like this lack of data and lack of good data. So I just like this table by De Costa, and who he made like last year, 2023, just to show like the different data sets in sign language processing and the number of papers who have published on this data set. And you see like you have like Phoenix 2014T, which is really dominant. And at the same time, we didn't use this data set for the reasons I'm going to speak of. So why not Phoenix? Meanwhile, it has been very dominant for like a decade in sign language processing. The good part of Phoenix is just that it really opened like a new era in sign language translation methods. And it's very well formatted for machine learning methods, so you can just download it and just feed it into your machine learning models without caring about data pre-processing and all these type of things. But the bad is in Phoenix is interpreted signing. So in sign language, we have a difference between interpreted signing and native signing. Just like if a native deaf person or someone who grew up like learning sign language, the way he signs is very different from an interpreter you see on a TV show, for instance, like Sign. So and yet they had interpreted signers and not native signers. And it's a very limited domain. It was collected for weather forecast, and it's just extremely small in size. It's just 7 hours data set, and it's very few signers, around 11 signers in total. And it has an unnatural background, means the background is always green or a solid color, not like in real life or real open conditions in the wild, basically. So we had to look at other data sets, and there's this table from UTUS, and basically like you see like you have a lot of different data sets which came out after. You have Bobesel from British Sign Language. It's exactly like the same like Phoenix, just it's for British Sign Language, and they took it from the BBC news, still about interpreted signing, and it has like a lot of hours. But we decided to use the last one, which is basically like YouTube ASL, because first YouTube ASL is basically a dataset which came from YouTube videos, and most of the signers in YouTube ASL, they are native signers and not interpreted signing, so it's really native signing. The second thing in YouTube ASL is that it's very natural, even in the background. Like you have diverse backgrounds. Just imagine people like doing random TikToks and things like that. That's YouTube ASL. So as I said, YouTube ASL is an open domain data set and in the wide data set. By open domain means it speaks about everything and anything, and by in the wild, basically like you have all type of backgrounds, all type of camera angles, and you just have this diversity which can make the models also to be somehow robust. But the major cons of YouTube ASL is that it requires huge work to put this in a disable machine learning format. Basically, like we spend like weeks just to process YouTube ESL because it's really, really like, I can't pronounce the word. So the first thing is, what is YouTube ESL dataset? It's basically just like a .txt file with just some IDs, as you see like this. And so in the txt file, you have some IDs, which are basically like YouTube video IDs. So you have to take every ID you paste on YouTube and you download the video, and there are like 11,093 video IDs in the .txt file. And so we first downloaded the videos and the subtitles. That is if they were still available. Of course, many times we had to see the videos is no more available online because people maybe might have removed the video from YouTube, or they have made it private or things like that. So we ended up with just like 10,150 videos instead of 1,093 videos, which the authors had. And after now downloading YouTube videos, so a YouTube video you can imagine like a video of like 5 minutes, but you can fit all this whole 5 minutes into a machine learning model or a machine translation system. So you basically have to clip or trim the videos into some clip phrase level alignment. So imagine like someone is signing a whole video, meanwhile the person is just saying like, I was going for a cool summer camp, but then I found myself at JSALT instead, which is also good. So we need to know now how to trim it into like different components, the video, and we rely on the caption file of the video, which is also like in the metadata of the video. So you have a metadata, as you see down, a web VTT file, where you can see like some timings and what was signed there. And you have to take also into account that whatever text you see there is what the user uploaded into like the YouTube captions. Basically, these are not auto-generated on YouTube, but these are user-generated. So just to recap, we have YouTube ESL, what they have, that is what the authors of the YouTube ESL dataset they have, and what we had at the end of the day. So they have 11,093 video IDs. We also had 11,093 video IDs, but they have 11,093 videos, but we had a little bit less, as I said, for reasons like people deleted their videos, and some were made private in the meantime and stuff like that. And at the end of the day, like number of actual training samples we have now to fit into the model after converting these videos into like some different clips is 610,000 for the YouTube ESL folks, and for us, it's basically like 506,000 videos. Yeah. So we use YouTube ESL basically for training, but as Dominic was speaking, or Dr. Dominic, we now have like how to sign for evaluation. How to sign is a more standard benchmark dataset. Disclaimer, it's not very also reliable. We discovered it during a workshop. Thanks again to Richard for pointing out a lot of abnormalities about the dataset. So we downloaded the videos and the captions, and we did again the same process. We trimmed the video to form clip phrase alignments. And on the text part, for how to sign, which is our evaluation dataset, there's no need of normalization because everything is already very clean. But for YouTube ESL, which is because every user generated its own caption, is a bit noisy, so we have to do a lot of normalization and pre-processing on the text there. So we did like on escaping, we remove non-printing characters, we pass all the captions to like language IDs, and we remove the captions and corresponding clips which had less than 25% detected caption in English. So at the end of the day, we remove 5% again of the videos, and we also apply true casing in case if you have more than 50 seconds and 74% of the whole caption is uppercase characters. So to resume about the data we use YouTube ESL for training, and we have written on how to sign. YouTube ESL basically is like 600,000 samples and about 1,000 hours of signing videos, and it has like 2,500 signers, and you can see it's very like open in the wild, so you have people in different conditions and things like that. On the other side, we evaluate on how to sign, which is just like 35,000 samples, about 8 hours of videos, and just has like 11 unique signers, and also like the background is mostly fixed here. So thank you. I'll pass to Andrzej. Thanks.
All right. Hello everyone, my name is Sondre and I will be talking about the video processing part of the test set. So, first of all, as Chester already said, we use U2PSL and how to sign. The usage of U2PSL is mainly for the pre-training. You can see some video samples here on the left. And how to sign dataset was supposed to be used mainly for the fine-tuning and evaluation. You already saw this picture. I'm gonna talk about the trimming of the videos. You can see the VTT file subtitle example here. That's actually what did we trim the videos according to. So you can really tell that if you have time stamps like this and you don't have the time frames, it is sometimes kind of hard to estimate the frame itself. You are shifting frame before, frame after. So this is what you really need to care about. So some tasks for the video preprocessing. The first one was the trimming that I already talked about, which was followed by cropping. That's what Jakub is going to talk about after me. The following task was to kind of get rid of the embedded texts in the videos. Because if the meaning correlates with the signing of the signer, it could really confuse our input visual feature extractors. So that's important. And the next task is to care about multiple people in the image, because after the cropping of the video, we really need to make sure that it is a signer that is being cropped, not like you can see the posture on the left, on the right, and on all that. Okay, so as Chester already said, we got over 500,000 clips from the videos after the trimming. His number was a little bit lower because it was already after some preprocessing, and there was a lot of accessibility problems. So I'm just gonna skip that because Chester already talked about that, but I'm gonna focus mainly on the OCR and in-paint of the detected bounding boxes of the texts. You can see the example of the videos on the right, and you can really tell that you are not sure about the subtitles and their form, so you cannot just get some rule that you can tell that if there is blue background and the subtitles, you just remove it. So you have to have some method that does it kind of robustly, and that is what we used ECOCR for. A lot of you already know this architecture, I'm pretty sure, but I'm just gonna introduce it quickly. So this architecture is basically trained for detecting the bounding boxes of texts in the video, do the text recognition. And you can see the example of the output on the right. And the architecture utilizes basic ResNet and LSTM to avoid grading vanishing. And the really interesting part of it is that it used artificial training data. So they took a lot of images and they inputted text all over. So they made a lot more hard training samples to detect the text from, because you can really tell that if I would just take a picture of you here and right now and put the text over it, you would never have this type of text over the image in real life. So the final pipeline got really robust. So some methods for in-painting the final bounding box. We thought about stable diffusion or image in-painting for irregular holes using partial convolutions that was introduced in a paper from NVIDIA in 2018. These two approaches were really heavy for our use case because we need to process the videos frame by frame. So we, in the end, chose some heuristic methods using the OpenCV library. I'm sure all of you know it. And these two were Navier-Stokes in-painting and Stella algorithm in-painting. These two are the ones that had the best results for the in-painting, and the Stella algorithm works on the principle of basically in-painting the nearest color for the pixel. So that is really kind of basic, you can tell. And if I tell you that Navier-Stokes uses the fluid dynamics for in-painting the color into the bounding box, it is kind of you would expect that we would have a little bit better results. And the computation speed is not really different between those two, so that's Navier-Stokes method, what we used in the end. I can tell you some examples right here. So on the left, you can see really small and not, and just the background from the video is behind the subtitles, and there is nothing really going on. It's just text over the image, and you can really tell that you cannot almost see the difference if there wouldn't be the subtitle or if there would. On the other side, on the right, you can see that there is a blue background behind the subtitle, and you can see that the color kind of goes out of the box, and that's where you can see the fluid dynamics showing up. And also there is the tag. If you can see the user tag here, it is really small, and I wouldn't expect the OCR to actually recognize that one, but apparently it did, so we are almost sure that it will be kind of robust, and even when downsampling the training videos, it will be performing almost 100 times, almost 100%. Now I'm going to talk about something that we tried. Right before I talked about inpainting the whole bounding boxes, but afterwards I thought, like, what about inpainting the masks of the text, not the whole bounding box? That's what we tried. You can see the example on the right. We used some K-edge detection and then closing with morphological operations with dynamic kernel size according to the detected bounding box size. Unfortunately, this resulted in the smaller texts not being really robustly inpainted, and the mask wasn't really including the whole text. So in the end, we used the whole bounding box in paint. All right, and this is the last example that I have for you. That's kind of obvious, right? Sometimes, as Chester already talked about, the training data are really variable. So sometimes people have like signs on their T-shirt or on their shirt. And if you inpaint every text that was detected, he sometimes have the fingers in front of the text, and you inpaint and blur the fingers, and that's the essential information for us. So we had to implement the rule. I thought about like the threshold of sureness of the bounding box, but in the end we just implemented the rule of upper 30% and lower 30% of the image, because that's where the subtitles usually are. This was I think this was the least robust choice that we have did, but it was a needed one. Otherwise, we would have really messed up our signers' fingers. Okay, I sent hearts to the Czech Republic because we have a lot of people watching us from there, and I get the microphone to Jakub.
Okay, thank you. My name is Jakub Straka, and I will talk about post-estimation and spatial cropping of the clips. We are using MediaPipe for post-estimation. MediaPipe is a machine learning library that was developed by Google. We are using model for post-estimation of the whole body, hand post-estimation model, and face detection landmark model. All these three models use lightweight and very fast MobileNet version 2. It is a fully convolution network. Unfortunately, it is not as easy as using the models on individual frames in the clips. There are some challenges. One of them is that clips can contain multiple people. And then the issue is that we get multiple detections in each frame. We have to track them and detect the right person that signs. And this also increased time of the post-estimation, and with almost 500,000 clips, it would take much more time than we have. So here's outline of our pipeline we used. We first used Yellow version 8, which is also convolution network and is also very fast, but have one advantage over the MediaPipe, and that is that it predicts all poses in constant time, and it doesn't matter how many people is in the frame, and we use it only for selection of the clips with one person. The advantage is that it's much worse than MediaPipe, so continue then with MediaPipe. We then use dispose form YOLO to create signing space. Signing space is concept from sign language translation and linguistics, and is basically space around the signer where the signing is happening. We are defining this as a square box around the signer with center between the shoulders, and size of this box is 4 times width and 4 times width of the shoulders. We use this box to crop the signer and remove excessive background, and then we can use MediaPipe to predict in this reduced image. And we find out that when we don't do this, the face and hand models don't work very well, so it is very beneficial. We then use MediaPipe predictions to adjust the signing space because the key points are more precise. The next step is to assign right and left hands. MediaPipe is able to do it, but we found it quite unreliable as it sometimes predicts to right hands or to left hands. So instead we used pose estimation of the body and basically wrists, and tried to find closest hand pose prediction to the individual wrist, and this was much more robust. And if we don't have prediction from MediaPipe, we can always use YOLO prediction. And in the last step, we only add padding to create square from the sign space and save the clip. Here is demonstration how that the key points are very useful. We selected 2 clips, one from training set, second from validation set. Both represent similar sentences, and we take the key points, normalize them based on the signing space, and then we calculate cosine distance between all the frames in these 2 clips, and we can use linear sum assignment to find pairs of the frames that minimize some of the distances. And you can see that we were able to select clips with very similar poses. Here's another example, but we, instead of taking two clips with similar sentences, we go through the part of the training set and validation set and try to find any frames that are very close to each other. And again, you can see that poses are very similar. Okay, finally, here are some numbers. We processed almost for a little bit over 500,000 clips. From that, we have 400,000 clips with one person. We process only those, and we left the clips with multiple people to process after the workshop. It is a little bit more challenging, and we didn't need that much data for now. And the result of this process is that we have cropped clips with only the signer in the center, and poses for all of these clips, which we make available for everyone online, so everyone can use them. Okay. Yes.
So Jakub, you said that, this is great. So basically you get the original YouTube clip, video, you extract the clip, and at the end of it, you have just the signer and the signing space,
Yes.
right? How do you evaluate if this worked well? Is there any metric? Is there any ground truth? Or
well, the only metric is that we don't want hands outside the box, so
yeah.
we check for this. But other than that,
no, meaning did anyone manually mark the output to say, yes, this was good, no, you missed something?
well, we check a lot of them, and we
Okay.
like manually, not with some specific metric. So it's just
Okay.
manual.
Right. And then the follow-up question, which you probably cannot answer, is that metric needs to correlate with our ability to subsequently recognize and translate the sign. So some errors might be forgiven, others may not be. So is there, like, for example, between the various methods, from what you described, it looks like you just inspected the output and said, yes, this is working
Yeah,
well.
exactly.
Is there a way to evaluate its impact on the
Well,
eventual output?
we could maybe try like random crops and train the model.
Yeah, random would
very-
definitely be one good baseline. But the question is, do you have to work this hard? Is it important? Do you have to work even harder because it's very important?
I think the only important thing is to have hands in the box.
Yeah.
That we have, because there is like a condition that if the hand is outside of the box we detected, we will increase it.
Yeah.
So everything is inside. And the second thing is that we want to decrease the background, remove the background as much as possible.
Right.
So it's balance between these two.
Yeah.
And we try to do manually and on many clips, but we would have to try different sizes of the signing space and train the model.
Okay,
It
no,
needs
that's
that.
fair enough. Okay, thanks. Thanks.
Just a brief question about the poses. So it looks like a video gives rise to multiple poses. Is that right? A pose sequence of poses, right?
Yes.
Yeah. What's the frame rate then in that case?
Well, it varies. It was from 6 to 60 frames per second across the dataset.
Oh, okay. Thanks.
Hello. Sorry. Hello, I'm Karan, and I'm going to present to you our second model for representing sign language, which we call Vavtuvek with Murat Savaşlar. So, so in this approach, our goal is to produce a set of contextual representations from given pose sequence extracted from sign language video. And the motivation for this architecture comes from the speech literature, where we see quantized targets for contextual prediction of mask sequences, so for continuous input streams, such as speech. And we see in literature the quantized targets in self-supervised training, such as in Hubert we see iterative k-means, targets in latent representations, while in Data-to-Vec architecture we see the implementation of these quantized targets in different modalities such as vision or language and of course the speech. So before we delve into how we implement this to sign language, we need to first understand how Vavtuvek implements the self-supervision. Where the Vavtuvek 2.0 architecture utilizes two loss metrics to optimize. The first one is the diversity loss, where the model is trying to learn a good optimized codebooks for representing the latent sequences. And to do so, the model tries to maximize the entropy between each codebook item, overall codebook. So each codebook is diverse enough to represent the latent sequences. So with these latent codebooks, the model actually tries to predict or to maximize the similarity between the quantized input coming from mask sequence to output of the contextual representation, while minimizing the similarity between the negatively sampled sequences. So to sum it up, diversity loss provides a good codebooks, while contrastive loss is providing a good sequence representation. And masking is for learning the context. And to iterate this intuition over sign language, what we should see is that for a given quantized representation, such as candidate C, in a given timestamp, we actually try to maximize the similarity between the masked output and the given quantized targets, while we also expect our codebooks to provide is candidate and the negatively sampled targets as in separate codebooks. So, sorry. With this intuition over, we provide a different set of experimentations for our scientific approach in this workshop. So, for the baseline approach, where we utilize the base Vavtuvek architecture, We call this a single queue, where we feed our pose information from a given single channel. And we see that in our experimentation, this approach is prone to codebook collapse, where we see high diversity loss in overall training of the model. So we propose a multi-queue approach, which we see in sign language translation literature. And what we do is that, stemming from the product quantization method in Valve2Vec2 approach, we do our product quantization according to the queue information for sign language. So these, for a given different cues, such as face, left, hands, and the pose, we quantize or learn a separate feature extractors and separate codebooks to represent our latent targets. And with these latent targets, we need to also show how we calculate our losses, since we have multiple quantized representations. So we provide two experimental setups, where in the first one, we actually concatenate the latent quantized representations as a single vector to measure our contrastive loss. See, so our model will only provide a single loss. While in our other approach, we call multi-contrast, we actually calculate individually contrast level individually with the given codebook from a queue and the contextual output. So our loss is the mean of this contrast from overall queues. So with these in mind, our experimental setup, we first see the diversity loss between the single queue and multi-queue approach. Where, as you can see, we have high numbers of diversity loss, which is not decreasing in overall pre-training setup, while in multi-queue approach, we see a 0.5 difference in diversity loss, which is a big number for our experimental setup. So although you may see a high, lower diversity, contrastive loss in the training of single queue, since we have high diversity, we don't have enough representative codebooks to actually model the contextual output. So in multi-queue, we see this codebooks have lower diversity, and also we see lower contrastive loss in validation set as well. And also within this training setup, we see an interesting phenomenon in terms of the diversity loss. So we measure diversity loss for each queue separately. We can calculate that. So in most of our experiments with multi-queue, we see that first the left hand and the right hand converges to a global minimum, while pose is converging in the later stages of the pre-training setup. And also in most of our experiments, we don't see a convergence in the facial codebooks. So this is actually aligns with the queue importance for sign language in sign language literature. So although each component of sign language has important, we see that left and right hand is most descriptive or more informative in the sense coming from the pose sequences. So we see this pattern overall our training setups for multi-contrast. And final, to give a final contrast, in our single contrast and multi-contrastive approaches, we see lower numbers of loss in most of our trainings for single contrast rather than multi-contrast. To sum it up, we adopted Valve2Vec 2.0 architecture for sign language approach, sign language translation, which we provide open source models and code integrated to Hugging Face models. And we also investigate the multi-queue versus single queue approach in the self-supervised pre-training setup for sign language recognition. And I'll give it to Chester.
So it's nice that you're able to sort of, adapt these self-supervised methods, which makes someone think that, oh, so this is easy. I can just dump a lot of data and train a model. But I'm afraid that's not the real case. How much preparation does it take to get the corpus to the point where you can do SSL?
A whole workshop, I might say. But we don't have a lot of open source large corpus with pose estimation in them. But we can also apply this not only pose but other modalities. So if you have embeddings for videos or different modalities, you can also apply this for sign language as well. This might be some outcome.
Yeah, maybe a follow-up question regarding the cleaning of the data, because, in audio, you have people always saying, and something, and I could imagine that in the science space, maybe you have people touching their ear or their nose or whatever. Did you look into something like that, or was that something that...
Yeah, we have two different normalizations before we feed our pose information to our models. The first one is we do global optimization for poses, which we have discussed in the signing space, but we also added the local normalization to hands, since we have like a diverging signing space for the hands. So we did that for left and right hand. We also did local normalization to face. And also we added zero mean unit normalization, as we see in WAV2VEC normalization as well, to these normalized pose landmarks. So I don't know if this helps, but we can say that our normalization includes the normalization of the signing space and the variation of the depth or the duration of the sign.
All right, thank you.
Yeah.
So since this is unsupervised pre-training, do you have a sense of what's the minimum size of how many hours or how much corpus do you need to get meaningful representations?
In our sorry? We have first experimented with our pre-trainings with how to sign dataset, which is 80 hours, and we see that there is no convergence over in both contrastive and diversity loss. We see a better result on YouTube ASL. So I might say, with the previous experience, 900 hours is the minimum that we see.
So one more question, and this may not be a question for you, might be for the whole team or Murat. This was triggered by Marcus's question. When you're looking at videos that contain sign language, is it worth thinking about the equivalent of the speech activity detection problem in speech, right? If you have an uncut audio recording, not all of it is speech. And not many people say this, but WAV2VEC and Hubert, none of them will work if you don't do good segmentation and give it speech. If you just give it raw, uncut audio, I think it'll just collapse. So my question is it a legitimate problem to think about sign activity detection? And because I think that the ASL videos that you have are nicely clipped. Most of it, there is signing going on. There's nothing idle. People aren't just looking at what's around them, scratching their head or doing whatever else they do. So do you have a sense?
Yeah, not from this workshop, but for other experimentations, for example, for isolated sign language recognition, what we do is that isolated videos have starting from the lower hands. So what they do in most isolated recognition is to crop the frames before it starts moving at some certain sense. So this is one normalization that can be done, and also I
guess the question is, how automatic is that, or do you have to do it manually? If I gave you a 1-hour video in which there was 30 minutes of signing and 30 minutes of no signing, how easy is it to figure out where there is signing going on?
Well, it might be a bit hard, but we can maybe hypothesize that we have limited set of hand shapes for a given video. So even the recognition of the specific hand shapes is enough to segment most segments between signing and as non-signing, I might say. So this is the one approach that we have. Marek, do you have anything to add? If not, okay, so I'll get Chester.
Anyways, yeah. Okay, so we first saw key points, but key points have, conceptually they make a lot of, they make sense, but in reality they are most often inaccurate and they hallucinate sometimes. So imagine you have this image, but that's the key point that's detected. So you can see like the whole hand is like the tip, how the person is tipping on the hand is missing and that information is lost. Also the same thing there and same thing here. And basically like this
Chester,
program,
did you define what key points are? Maybe you should just tell us.
I thought Jakub did, but yeah. So yeah, so key points basically are the models, is a media pipe library which was used by Jakub. Basically like you have an image and you have key points. So yeah, you pass it through that library called media pipe and it returns to you like the most relevant points in the image, basically, which is like the wrist, the fingers, the body pose. Basically, it's just like to give you an abstract representation of this image. So it's just an automatic library, like you feed this image and it returns that output. You feed that image, it returns that output. And yeah, Jakub spoke about it, I think, some slides back. So, and this problem is, the problem of key points mostly occurs when there is a hand-to-hand interaction or a hand-to-face interaction. That's where it's mostly severe, as you can see. Like when there's a hand-to-hand interaction or a face-to-hand interaction, that's where this problem is most severe. Yeah, these are the references. And also, like, there was a recent paper which came out just before the workshop where some folks did some work to investigate whether the key points which are related to the face, can they really like model like the facial expression of sign language? And was shown that it's not true, especially like the eyebrows and stuff like that. Usually they are very inaccurate in the key points. So we thought of how can we now take what can we do not to lose this type of information, basically, yeah, because this can really become a bottleneck that we are passing into our models. So we thought of the InnoV2 architecture to just learn like latent representations, semantic representations of images, basically. And basically, in a nutshell, the INO is basically we have an input X and you give you have two augmentations, X1 and X2 of the image, and different augmentations goes through different networks which are initialized at the same point. And the goal is that the probability distribution of the student network should be similar to the second network, but the second network, which is the teacher network, which doesn't get updated through backpropagation, but instead through exponential moving average. That's just like, just in a nutshell. So we said, okay, let's do the InnoV2 for the hands and for the face, so that we can have like vectors representing the hand shapes and vectors representing like the facial expressions. So basically, we took the original InnoV2 and we continuous pre-train on using unsupervised learning on hands in this case. So we take like 1 million random hands from the whole data set, and basically like the teacher network receives the global views. Basically, the global views is like a big portion of the data set of the image, which is like maybe like 80% crop of the image or 50% to 90% crop of the whole image, random crops from the image. And the local views are basically like smaller crops, which are like maybe like 10%, 20% of the image. And the goal is that the student network sees both the global views and the local views. Meanwhile, the teacher network only sees the global views. And at the end of the day, we expect that the distributions from the two should be to be similar. And as I also said, the teacher network is only updated by exponential moving average. So we did this process for the hands so that we can have like some type of hands representations, basically. And we did the same thing for the face, where we can also have like face representations of sign language, because in sign language, the face and the hands plays a very key. Yeah. So at the end of the day, we realized that if you take our Dino V2 hand model and we pass it like this as a reference image, it can basically, you can see the cosine similarity between this image and the 4 images at the top are very high, and the cosine similarity between this image and the ones down are very low. Because Dino V2 is really good at clustering, like really, really good at this type of clustering. So, and because we're continuously pushing again on these hands, at the end of the day, it sort of has some clusters for different hand shapes and things like that. And some preliminary results on H2S using this approach is we found that to understand what's the importance of all this is that first we have like a system where you have an uncropped video, basically like imagine like you have the whole frame without cropping particularly the hand or the face, just pass like the whole frame to an original Dino V2, which isn't fine-tuned or continuously pre-trained it, and you see that the blue score is 4.9. But the moment you just crop the video that is into different components like face, head, 2 hands, and the body, you realize that the blue score shoots up directly to 11.3. And now, when you now pre-train these Dino V2s, when you pre-train on this Dino V2, like specialize it now on hands and face, it now goes to 14.3. And once you add back the original frame, that we call the global frame, it goes down again to 12.2. We just had these results just to get a sense of whether we were in the right direction and things like that. But more experiments have to be done on YouTube PSL and things like that. And for, sorry, for frame alignment, we realized that if you have this sentence and you want to see like the closest sentence to it in the validation set, and from just the feature level, we realize that this video, the features of the video up and the features of the video down, they are very close to each other. And when you look at the video itself, it also shows that they are actually like close to each other. So it shows that there's a certain level of good alignment happening with this type of strategies we are involving. Yeah, this is again like more examples. So in a nutshell, the goal of Dino V2 basically is that the information that we can potentially lose from key points, we don't lose it anymore, and we now deal now with latent representations, which we can continuously fine tune. Meanwhile, if when you use like key points, it's just a library, like we can't like update it or change something, but Dino you have much more control on it. Even after the workshop, we can still continue fine tuning and things like that. Yeah, so I will pass now to Tomasz. Thank you.
Hi, I'm Thomas, and I will be presenting the mass autoencoder method, which is our last but not least feature extractor which we used. So we don't have much time, so I will just quickly explain how it works. So first, we have an input image, and we split the image into the separate patches, which is the same approach as in the normal vision transformer. Then we mask 75% of those patches, and we discard them. We won't use them anymore. We take the remaining 25% of the patches, and we apply the positional embedding to them, and pass these patches through the transformer encoder, and then we get the latent representation of those patches. Then what MAI does is to reorder the patches back to their original position, and to the missing positions of the mask tokens, there is just the mask token. Again, there is positional embedding added to those mask tokens. And then all of these patches are passed through the transformer decoder. And then after the transformer decoder, there is a simple linear layer which tries to reconstruct the original patches. For reconstruction is used mean square error loss. The main goal is to build the representation, not the actual reconstruction, I mean, you can see the images on the right. They are the reconstruct ones. You can see they are kind of blurred, but this doesn't bother us because the goal wasn't to reconstruct them well. The goal was to build strong representation, the strong transformer encoder, which will make strong representations of the input image. So yeah, here's just a note that we use only 25% of the input patches, 25% of the input image, so we can afford to use larger architecture for the transformer encoder, while for the decoder, we use all of the patches, so we use a smaller architecture. The representation is, we get the representation by using class token, so when we make an inference, we pass all of the patches through the transformer encoder, but there is a class token like in regular vision transformer, and we use this output of this class token as a representation for our purposes. So here are some results for our datasets for sign language. Well, why we use mask autoencoder? What's its pros? The differences of other methods. So this is our only method which has information about the whole scene, the whole pose of the person, whole texture, and whole scene, which may struggle in some points, but if we have enough data, this is actually like the best option, but we don't know if we have enough data. Here you can see the examples. I would point out the last row. There's a lady in the blue, and you can see she has masked the whole arm here, and the mask autoencoder correctly hallucinates the position of the arm. So this is the correct behavior. You can see the upper rows, there's hallucination of the face, whole face, or just half of the face. Then frame alignment. It is the same case as the previous examples with Dino or key points. You can see it doesn't align as well as the Dino does or the key points, but it doesn't mean that it's wrong. It means just that this feature extractor takes into account the whole image. It may focus on different things and not just the pose. Here's another example. It looks a little bit better. Yeah, but it's from more data. And I think there's a pause right there.
So from what I understood, you're doing this masked autoencoder training with still images.
Yes.
Right? And so your notion of position is just XY position in the image.
Yeah.
Was there any discussion of doing it in 3D with time, since you have videos?
Yeah. We discussed it, but there were many challenges we need to face. So we ended up just when training, we just randomly sample one frame from the video, and in the next epoch we choose different frame.
It's not so much about missing frames. It's more about there is really good information across time, and therefore, if you took let's say you took a few keyframes or something and treated them jointly as one unit, you could probably get even better representations.
Yeah, I think this is on our to-do list.
Okay, all right.
But thank you for the question.
I have another question. So is it possible to recover from, let's say that you made a mistake in one frame and then the other one is correct and you have like multiple mistakes across the video? Is it possible to recover from that or not?
I'm sorry, I don't know what you mean by mistake. Like,
So that there is like that you're not recognizing the correct pose, for example, or the correct sign.
correct sign. Well, it's
Is it possible to recover from that so that the message is like completely wrong?
I mean, yeah, because we use all of this representation. The Maya just serves just the representation extractor, so there isn't any pose like itself.
Okay, okay.
Do you want?
I just wanted to announce that this is our time for the break. So let's break it up for now, and we'll continue after a short stretch break.
10 minutes. Every done. Okay. Hey guys, let's get back in. Check, check. Guys, let's settle down back. Ivan, Shankar, Ahmed, Honzo. Right, folks, let's settle down. We're about to start again. All right. Okay, so let me hand the floor back to Murat. Please continue.
Thank you, Sanjeev. All right, I'm Murat Saraçlar from Boğaziçi University, Istanbul, Turkey. And this is, of course, done by the fresh PhD, in this case, Balaji Yusuf, who just got his PhD before the workshop, end of May. So I'm going to talk about evaluation of the sign representations that you heard about. Oh, sorry, I don't know how this works. Let's try. Nope. Okay. All right. So you also heard about the full system, full translation pipeline, and you can imagine this is going to be expensive, especially since there is a large language model involved. So we wanted to have an inexpensive way of evaluating the sign representations that we just talked about. So inexpensive probe. We also mentioned that the annotations, the translations themselves are actually at the sentence level. So this has to be a sentence level probe. And the assumption, the main assumption we have is that the semantically similar sentences should be closer in the feature space, in the representation space, than semantically dissimilar ones. And the probe has to work at the sentence level. Okay. All right, so Bolaji named this probing by spotting, and it's stuck. It's actually sentence level, but anyways. So what we first do is, actually Dominic did this part, generate embeddings for annotations using BERT, and find the closest and farthest clips to each clip based on the embedding distances, okay? So these are the BERT embedding distances, so text level, okay? And we're going to do this for all the embeddings that we have, all the representations that we have. We get the positive and negative labels from the textual representations, so the English representations in this case, okay? And the main assumption, I'm repeating this, but it's important, two semantically similar sentences may contain the same signs. Remember, we're talking about the English translation and the semantic representation that we obtain from there. This may or may not always correspond to the same sign, depending on the context. What we do is train a small, about 100K parameters model to classify the pairs of clips. So as you can see, or this side, we have the anchor features and the target features coming in. So the target might be a positive or a negative example. They go to pre-processing layers. These are very simple convolutional layers. One duty of the convolution layers is also adjust the sequence length and dealing with sequences. Then we concatenate the representations that we have, put a separator in between, use a self-attention layer, and then add a for purposes of classification, a class label, and then the binary classifier should tell us whether the target feature is similar to the anchor or dissimilar to the anchor, yielding 1 or 0 over there. Okay, and this is fast enough. It trains in about 20 minutes, so we can have a quick evaluation. We don't have to wait 1 day to train a model or fine-tune a model. Actually, you cannot even train the whole thing, but this is much faster than the translation after all. Okay, and at the test time, we're going to test the same way. For each test clip, we will get the BERT-based positive and negative clips and compute the score from the classifier for each pair. So we again continue to pass over here, basically with the positive and negative clips, and we compare the scores of the positive to the score of the negative that we get at the output of the binary classifier. If the score of the positive is larger than the score of the negative, we label this as 1, otherwise 0, and then we measure the accuracy. Okay, so this originally we used it for sign to vec. We had different approaches, as Karahan mentioned. We have single Q, multi-Q, single contrast, multi-contrast experiments, and we compared the results with our baseline, which is pause. We see that the single Q does not work as well. These are sign-to-vec features from the output layers. I'll mention the importance of this in the next slide. We observed that the best performance is obtained by multi-Q and single contrast setting. So this is on the validation set, and I mentioned that these are from the previous results were from the output layer of the sign-to-vec. It has been observed, actually, Hubert paper is basically starting from this observation that the intermediate layers expose information more readily, and we observe the same phenomenon here. This would be the output layer, this would be the input, which is basically the pause information, and instead of using this, maybe using a intermediate layer is better, and that's what we see also through our process. But we also observed one more interesting phenomenon, that the earlier layers also show faster convergence. So when we train the model, so the blue one is pause actually, and these are different layers starting from 4, 7, 10, and 12. The earlier layers give you a much faster convergence. And if you continue training, you basically arrive at a closer point, but you can stop early, obviously, in this case. Okay? So this is from the training. Okay. And finally, I have a slide that gives us the test set accuracies on various representations that or features that we have observed, both validation and test sets. So for sign-to-vec, we chose this to choose the approach, multi-Q single contrast, and also the fourth layer in this case, and this is slightly better than the number that I have presented before. But anyway, we also see the dyno and masked autoencoder features here. Well, surprisingly, somewhat surprising, the dyno is not performing as well. It's at the same level of pause, and Maya is performing quite good, actually, in this measure. But we should take this with a grain of salt. We already know that dyno actually helps, so it's better than pauses in the full translation system. But this was a quick evaluation, which is useful for model selection, hyperparameter tuning, and we see that we can get improvement over pause sequences using the representations that we have proposed. Of course, we do not know how well this correlates with downstream performance. We have evidence that, for example, in dyno case, downstream performance is actually good. So this is not testing the potential of the representation to be used, but instead, basically a very simple probe that can be tested, that can give us an answer in half an hour or so, so that we can choose among the possible models and tune our hyperparameters accordingly. And that is it, so we'll continue. Okay.
Question. So looks like from one of the results, if you go back to the the earlier layers seem to perform better than later one, correct? But so
well, this is
could this be an artifact of the classification task you're fine tuning for?
No, this is an artifact, but it's not an artifact of the classifier. It's an artifact of the learning process, actually. Remember, there's a contrastive loss So it's actually trying to make the output similar to the input in a way. Of course, one of them is masked, so it's not exactly the same thing. But in between, the information is actually turned into a latent representation, which we would like to get at.
Yes.
Okay, so that's what we want to get at. And actually, Hubert uses that phenomenon as well. It extracts the information from intermediate layers. So this is also the case for speech. So intuitively, you can understand this as obtaining a latent representation and regenerating the input, right? It's similar to an autoencoder in that sense. So we would like to get at the compressed information.
Thanks.
Okay, if there are no other questions, I'll take Vaclav.
Hello there. My name is Vaclav, and I am a master's student at the University of West Bohemia in Pilsen. And I'm here to talk to you about the text data augmentation methods that we used. So this task is based on the simple fact about translation. That is that a given sentence in language A can be translated in various ways into language B that results with various different versions of the sentences which in between themselves are semantically identical. And we can use this logic to create augmented data targets and use them to battle overfitting and make our system more robust. So to give you an example from our YouTube ASL dataset, this sentence, his London critics have accused him of being thin-skinned and childish, can be paraphrased in 2 different ways, as you can see here, and all of these 3 versions of the sentence are correct translations from ASL. And that gives us more target to work with and feed them to the language model and to the projectors during training as different annotations. And how do we do this? Of course, we can use LLMs because they have been pre-trained with a lot of knowledge about the world, about context, about mostly English, but also different languages. So they have inherent knowledge, and that makes them state-of-the-art models for paraphrasing. We can use them as such. And there is always a lot of interest from general public and scientific public to see how they compare between each other, which is also interesting from the research point of view. So we have tried to use different models from OpenAI or Meta, and we are planning to try also other models. And also the text needs to be pre- and post-processed, of course, and there are several limitations. I'm pretty sure that all of you have worked with LLMs before, so you know that they can hallucinate, but we have methods to work with that, and thanks for the assistance for the NLP seniors in our team. We have the prompt engineered this, and we also can try different approaches. For example, we can do iterative or sequential feeding, which means that when I ask for 5 paraphrases of a sentence, I can either ask the model, give me 5 paraphrases, or I can ask 5 times to give me 1 paraphrase. So there's a lot of things to try. And also, after some discussions, we tried to give the model context from the previous clips. As you've seen before with the videos, we can do the same with the captions. So we can give the model, okay, in the 5 previous clips, you know this from the story, so you can give me a higher quality paraphrase. But you will see soon that it might not always be the best approach. So now I can pass the mic to Alessa to give you an example of how we evaluated this.
Okay, so we're going to talk about how we evaluate paraphrases. This is a task that's very related to machine translation. So what makes a good paraphrase? Well, what we want is both a mixture of semantic similarity and lexical divergence. Semantic similarity meaning, you know, that the actual meaning of the words remains fairly the same, and lexical divergence, well, we just don't want the exact same phrasing. So this is, this is a different enough sentence. So here we have some examples of the original sentence. About 3 years ago, I moved from Texas to Canada. The bad example, this like retains some of the meaning, but it's not precise enough. So that's why we classify it as fifth percentile. We will go into a validation scheme in a little bit. And then the good example is a bit more precise because it actually like retains the word like made the move instead of just went, which is more vague. We will talk about the exact evaluation scheme now. So we use this adapted metric, parascore. So we have two components. We have two components to this. First, we have the semantic similarity. This is computed using BERT score. So BERT score, for those who don't know, it basically takes the contextual embeddings for two candidate sentences. Then it computes the cosine similarity between them, and then it uses like precise matching for the like recall, precision, and the F1 score. And then we also have the lexical divergence. For this, we use Levestein distance. So Levestein distance, what it does is basically just measure on a scale from 0 to 1 how many single character edits. So like if you remove one character, add one, how many of those it takes to create like a new word like from another. And this is again scored from 0 to 1. I think the interesting thing here is the hyperparameters. So we've got two of them. We got first omega. So omega basically what it does is it caps how much like the lexical divergence can affect the score. Here we use a default value of 0.5, which means that we're weighing the like lexical divergence and semantic similarity the same. And then we also have gamma. This one is interesting. We set it to 0.35. This basically caps the like max score for like Levestein distance. So with this scheme, basically the like lexical divergence can contribute like 0.175 because this is 0.5 times 0.35 to the score. So this basically caps how much like penalizing we do for a very creative paraphrase. Because if it, like the lexical divergence turns something up higher than 0.35, we will simply return 0.35. So this also introduces some nonlinearity into the scoring. Then here we have a graph that like resumes our results across methods. So you will see here, what we do is take like the 5 paraphrases we did per caption, and then we plot their distribution. So we take the average parascore for those, and that's what you're seeing right now. From this graph, we can see that like llama 3 sequential and llama 3 iterative, very close, but we get something slightly higher for just pure llama 3 sequential. Then we also see that context did not help, usually for machine translation. And as we'll see like in the overall model results, sometimes we expect context to help, but in this case, it was interesting for paraphrasing, it did not make a difference. And then finally, we just want to highlight how for this workshop, we found GPT to be the best model, specifically GPT-4o. The first results, it was GPT 3.5, but then we did more experiments with the GPT-4o mini version that came out recently. So I'll pass the word to Vaclav.
Thank you, Alessa. So to conclude this task, we settled to use GPT as a workshop checkpoint, thanks to OpenAI for releasing the mini model, which made it better for us in the last weeks. And by plugging the paraphrases into the system and pre-training, it's proved to be a great augmentation, and it improves overfitting, as Ivan will show you later in the overall results. And we also promised to release the whole paraphrased YouTube SL and how to sign dataset to the research community, so there can be more done with this, and also the future paraphrases done with alternative models. And we want to use this as a base for future research, and we are planning to work on a paper to make a comparison of paraphrasing approaches and models, especially in usage for this task. And if we get more funding, time, and bigger models, we are certain that we can also get better paraphrases and probably be able to do something with the context, because this is still a big open question that we think that context should help, but in the way that we used it for now, it was actually worse. And we plan to try other models. And the good thing about this is that the annotations generated are pretty much plug and play. So if we get a new version of YouTube SL paraphrased, we can plug it into SignLava and get a new model the next day. So this is it for our part, and now I hand the mic to Kevin. if there's no questions.
So, Václav, when you started talking about text augmentation, I was thinking about what people typically do, right? Data augmentation, when you train these neural models, is mostly to create variability in the input so that the system becomes more robust to not seeing only what it has seen in training, but some variations of it. But that's not what you're doing. You're producing variations on the output.
Yes.
Right? And so first question was, what is the point of that? And then I thought maybe this is helpful in the translation context because very often your system might produce something which is not the same as the reference translation, but it's semantically equivalent. But then I would use it in evaluation. I wouldn't use it in system training. Or I would use it in generating backpropagation. So in other words, I would say, okay, you didn't generate the target, but you generated one of the paraphrases, so I can adjust my gradient accordingly. So to make a long story short, I have no idea why you're doing this. Can you tell me why you're doing this?
Mostly what you said in the beginning, it helps to battle overfitting and make it more robust because we get more variations. I think this is a...
No, I disagree. I think if you do variations on the output, you're just confusing the model.
But if the variations are semantically consistent, then I don't think it's confusing.
I'm not sure. Yeah.
So basically, this is property of sign language mostly.
Yeah.
Because the concepts in sign language are expressed in many ways, and you cannot find a one-to-one mapping that would correspond to the translation. So we just tested this out, whether it will help. Of course, you are also, the truth is that you are confusing the model and you are making it more hard for it, and it needs more data to be able to process. So, but also the property of sign language is that there is simply not an easy concept of words in a sign language. So this was our idea how to fight this property of sign language. If you still not okay.
Oh, sure. So for sign language, there's usually glosses that are used. And so when you use sign language, there's like different structures and for words that can be used for similar meanings. Like I could say like cow, for example, which would mean beef or cow in itself. Like there's different meanings for one gloss or like sign. So I think it's not easy to translate on a gloss by gloss basis, just because it's, which is like more typical for like English to do, especially because in sign language glosses are not, first of all, in the correct order because it's a different sentence structure, and second of all, because of the fact that these glosses can often vary in meaning depending on the situation and context, which I think is why it's important to do this.
Okay, what I'm hearing is actually strengthening my intuition that you need data augmentation on the input, not the output. So again, I will push back and say, why do you expect this to help? You should think a bit more about it because I'm not persuaded by your arguments. There's a lot of variability in the input. That's what you said, Richard. So we need to have different versions of the input. Having different versions of the output, I don't know what that does for the model.
Well, you're correct that it makes it harder and it confuses it, but that is not necessarily a bad thing. Because if it's harder, then this is a long discussion, I think.
No, this is meant to be a friendly discussion. I'm not being adversarial. I'm trying to make you think about the main reasons. But okay, yeah, cool.
Yeah, actually, like a variant of these ideas actually has been published by Google like 2 weeks ago on sign language translation, and basically so they augment the output so into different languages. So imagine you have ASL to English, and now they take the English sentence and machine translate it to Spanish to other languages, and the model now has to learn now how to live from this same input into different languages into. So I think, and they show it helps, although it's not like, so what we are doing here is you're having paraphrases in English, but they're having like variations of the output, but in different spoken languages, but they show that it helps. Although not a lot, but a bit, yeah. Thank you.
Great. All right. So I'm Kevin, and together with Shen, we're going to talk about how we're going to integrate all these sign representations and text augmentation that you've heard of so far into a single intimate model that we use for sign language translation. Okay. So just to recap sort of what Marek said in the earlier part of the talk in the summary. So we want to build a large language model-based translator for sign language. Now, how do we do that? So we have two things. We have a text-based LM, in this case Llama, that knows English very well, but it knows nothing about vision. On the other hand, we also have several visual encoders like Dino, Maya, and all these sign-to-vec that extracts sign representations from video, right? So the question is, how do we combine these two things? Now, the approach we choose is we're going to insert a small connector between the visual encoder and the large language model. And this connector is a projector that will map from the video feature space into the text embedding space. Now, I understand there are many ways to do this. For example, yesterday you heard from the audio team, they use a Q-former approach. So all these are possible, but I think this approach is good for us because we don't have a lot of training data, and this approach only needs us to train a very, very thin projector layer. Okay. So this is based on previous work called Lava. So I'm just going to briefly explain this previous work. So in this work, it's an image multimodal model. So they have a large language model, and then they have image features, and these features are then projected using a linear layer or a two-layer MLP into the text space. And they train this using examples like this over here. So, so for example, this image, you give it the image, and then you ask the question, what type of vehicles is in the image? And you have some answers given to it. It's the features, a black SUV. So then you basically fine-tune this projector layer based on this kind of example, okay? So that's a basic approach, and we're gonna extend this to sign language. Okay, so what are the differences when we try to extend this? First of all, our input is different, so rather than an image, now we have a whole video, and that gives a lot of extra challenges because now you have time involved as well and very long input sequences. The task is, of course, different. We focus on translation of sign language. We also look at many different encoders, if you heard of before. And then finally, as you'll hear later, context we think is very important for sign language because sometimes things are underspecified. So we also put in the model a way to include the preceding sentences or the beginning sentences of the discourse. Okay, so just to wrap it all up in a single picture, so this explains the model in detail. So hopefully it will be clear to you guys. So first of all, you have a video clip, a single video clip that comes in, and it's being encoded by these various different sign representation methods that we talked about before. And then output of them are feature vectors. Okay, so imagine different numbers of feature vectors coming out of here, representing a single video clip. Now for each of these vectors coming out, there's going to be a small linear layer or n-layer NLP that will convert it into basically the embedding space that's the same as the text. So it's basically a word embedding space. And then we're going to train using sign language data, these projector layers so that we can map from each of these sign representation spaces into a word embedding space that the large language model can take. Okay, so that's a basic architecture, and now I'll pass it on to Shen, who will talk in more detail about how we train this.
Thank you, Kevin. Hello, I'm Xuan Zhang, and I'm from Johns Hopkins University. I defended my PhD thesis during the workshop. And Kevin has talked about the architecture of our framework, SignLava. And next, I'll talk about how the model has been trained and what our model is capable of. This is a way that we construct our training data. Basically, first, we have this system instruction. This is fixed during training. you are a specialized assistant for American Sign Language. Your capabilities include understanding and interpreting ASL content from videos provided by users. You can translate ASL into English accurately and respond to specific inquiries about the presence of particular signs within the video, demonstrating comprehension. And your role is to assist users effectively by leveraging sign language for communication and tasks. The video is represented by a single or several streams of visual features delimited by this and that. Okay, and then the user will give a prompt. For example, translate the given American Sign Language video into English, and we expect the model to answer, llama is not an alpaca in this case. And we're using Llama 3 for our large language model, and this is how we put our data into the input template of Llama 3. Okay. And we adopt 2 stages of training as in Lava. We have very powerful visual encoders created by our amazing team members. And we also have a very powerful large language model here, which is Llama 3 created by Meta. And at first stage, our goal is to align the visual features from our visual encoders to the textual embedding space of large language model. So we freeze both the visual encoders and also the large language model. And in this stage, we're only training the projectors. Okay, and at the second stage, we want to adapt our model to our target domain. So in this stage, we also freeze the visual encoders. We train both the projectors, and we do QLoRa fine-tuning on large language models. Okay, and we do pre-training on a larger data set, and do fine-tuning on a smaller data set. Okay. We adopted several training strategies to hopefully improve the performance of our system. First, as Václav and Alisa introduced, we use paraphrases for the target translation. During training, for each sample, we'll randomly sample one version from the ground truth translation or the paraphrases as a target. Since as we mentioned before, our training data is very limited. So this way, we could do data augmentation. So basically, we're creating multiple samples from one original sample. And we teach the language model that you can translate the same video this way or that way. It's all okay. And another strategy is to add context into prompt. And this basically gives an example how context is important for understanding sign language. And this is a video of a lady signing a story to kids. It's about dragons love tacos. So if you focus on the second clip, the lady is actually signing love what to beef chicken. But actually it should be translated as they love beef tacos and chicken tacos. And tacos and they are missing in the signs. You can only refer this important information from the context, which is from the previous clip. So in this clip, the lady signed, hey, did you know that dragons love tacos? And from here, we know, oh, she's talking about tacos. And then we can infer there are tacos here. Okay, and then there's another example. So here, the lady is signing, maybe this is just index, could be they or you, and eat. But it's actually mean it's very rich meaning of this eat. Maybe it's a crunch of the crispy tortillas, right? So she's basically saying something like, you can translate from this gloss to this translation, right? Yeah, but with the context with previous sentence, it might help with the translation. Okay. The way we added the context is very simple. Basically, when we have context, we just add these previous sentences into the prompt like this. So here are some preceding sentences as context, blah, 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 and translate the next sentence given by the American Sign Language Radio into English. Okay. Another training strategy we have adopted, which has also been shown very useful for sign language translation, is multitasking. So during training, besides doing translation, we also did one-word detection and multiple keywords detection. I'll explain in detail for those tasks. For one keyword detection, we first extract the keywords from the video, and then just prompt it like, given the ASL video input, answer the following question with yes or no. Is the sign vicuna present? Okay, and we expect to answer yes or no. And another more complex version over this one keyword detection is multiple keywords detection. Here we basically ask for several keywords, whether they are present or not. So it's a more complicated task. Another task I think is very interesting is that we sometimes we randomly flip the video input and ask model whether the video input is flipped or not. So given the video input, answer the following question with yes or no. Is the video presented in reversed temporal order? Yes or no? So basically, the motivation here is that we want to ground the large language model's prediction on the video content, and we want to make sure the model actually understands the video. And then we can move on to the most difficult task, which is translation. Okay. So this results in this picture. If you have a very good memory, Marek has showed this before. So in the end, on the Taki side, we have 3 different tasks during training. One important contribution of this from this workshop is that we built this software, SignLava. We made it modularly flexible, so you can plug in and plug out different modules by easy configuration. For example, we show here this configuration file. You can specify the base model you want to use for the large language model, and you can specify some hyperparameters here. And also you can specify how you want to add context, and also some visual features you want to add, and the projector architecture, and also turn on and turn off, and the sample weights for the multitask. Okay, so we have accomplished, so during this summer, we have integrated all the features we think that are promising during the workshop. And next step is just to use this software and run full-scale experiments. So during this summer, we have trained our SignLava using the smaller version of Llama 3, and we also tested it out for 70 billion Llama 3, and we showed that we could do it, but we probably didn't have enough time to do it. After this workshop, we'll continue our work, and we'll move our model to a larger version of Llama 3, and so to be specific, DeepSpeed allows us to do that, which allows data parallelism, pipeline, and model parallelism at the same time. Okay, so basically we built this software, SignLava, and it allows researchers interested in sign language research to do experiments with large language model enabled system, and also it allows many flexible features and experiments. We have open sourced our software. Okay, thank you. Do we have any questions here? Otherwise, I'll pass my mic to Ivan.
Thank you very much. Hello, ladies and gentlemen. My name is Ivan Gruber, and I will be talking about our experiments and results. So, before I start, it should be noted that most of the experiments are reported on how to sign dataset. Due to time constraints of our workshop, it wasn't basically possible to train some model on YouTube ASL. And we can start with this simple test. Basically, we started with a very simple overfitting sanity check because our system is very complicated and we just wanted to be sure that everything is connected as it should be. Then we created one data sample training set from all our 3 input modalities, and we just overfitted this on this sample. So, encouraged by these nice results, we started some preliminary experiments. And in our first experiment, which is our baseline experiment, we trained only on one modality, to be specific on my modality. And as you can see, we get a really nice overfitting. The blue line is validation loss, and the red or orange, I don't know, orange line is our training loss. Yes, so basically next step was to utilize our augmentations, to be more specific, our paraphrases. We used GPT-4o mini paraphrases, and as you can see, overfit is much lower. Right now, blue line is the original baseline run, and the red line is the run with paraphrases. We also noticed small problems with the paraphrases, and that's maybe all of you know that basically large language models have some favorite words, and they are overusing them during the rephrasing. So that can cause some problems in a prediction itself, because in this experiment we used 5 different paraphrases, and during the training the target for the model was chosen basically uniformly. So the original had only 1/6 probability to be chosen. So it caused some basically predictions which overused some words like, I don't know, Delph is probably the most popular word of our language, large language models. In next ablation study, we compared some modalities. Here you have all the runs from modalities and their combination. Okay, closer, perfect. And their combination, and as you can see, when we combine 2 modalities, one with like global view on the image and one with local view on the image, we improve our loss. For example, here we have only Maya in red, and if we combine Maya with Sign2Vec, it's not a very good example, I guess, but it will improve it a little. The best combination was Dino with Sign2Vec, because Sign2Vec has some global view on the image itself, and Dino contains local features from hands and from the face. In the next ablation study, we tried our multitask approach. As you can see once again, multitask approach helps us with the overfitting, and yes, the original Maya run is in red. And then we have here other runs with auxiliary tasks, like with one word prediction and words reversed and also all together.
Ivan, quick question. Are these training losses or is this validation? What loss am I looking at?
Right now, we are looking at validation losses. These are are all validation losses.
Got it, okay.
Oh, the training losses were only at start, these two and this one. But the rest of the losses, are validation losses. Yes. And I think the last of our ablation studies is about projector architecture. We compared different number of layers in the projector, and as it can be expected with the increasing number of layers, the overfitting problem is more severe. In this ablation, we reached the best results with 2 layers, right? 2 layers here. It's 2. I probably should use different colors. Sorry. 3 layers is here. 4, 2, 1. Yeah. And yeah. In the future research, we probably want to improve the architecture of the projectors themselves, because right now they are very simple, just linear layers with Galo activation function in between. So we think about some dropout addition or maybe some form of normalization, like batch normalization or something like that. Okay, then we also try ablation about context. Here we have the original train without any context, and then we have two trains with prelude. I'm not sure, Sean, did you talk about it? Probably not. There are two form of context. First form is prelude, which means that we are using the context from the start of the video. Yeah? Video contains many clips, and in prelude we are using always the first two captions from the video. The reasoning behind this is that usually at the start of the video there is a topic of the whole video, so the important information should be probably stored somewhere at the start. The second approach is basically preceding context, which means that we have something like moving window, and we always use as a context two previous contexts. Yeah. And as you can see, the context really improved our results. Of course, the best results were reached with context of the length 2. We did not test longer term context.
Ivan, one more quick question.
Yes, of course.
So the prelude only has the prelude. Does the context have the context as well as the prelude?
No,
just
it is only context.
So did you try both?
Not yet. But we will try it in the future, definitely. Okay. We also tried some manipulation with other hyperparameters. We manipulate with learning rate, obviously. We had to really lower the learning rate because Llama is a very powerful model, and basically the overfitting was our major problem because of the lack of data and with comparison of the size of the model. Then we also try, all the runs were run or with Adam W optimizer. We want also try some other optimizers in the future. Then we tried different learning schedulers with warm-up, without warm-up, basically this stuff. And we didn't have much time to try the second phase of the training, which means the training with LoRa or QLoRa. So, but we ran one run and we know it's working. So everything is like programmed well. Yes, and this is run which is currently running on YouTube ASL because as Sean and others mentioned, we definitely want to pre-train on some bigger data set, for example, on YouTube ASL, and then to fine-tune on how to sign. This is current run. This is evaluation. This is train loss. As you can see, the both curves are going slowly down, and we hope this will give us some nice pre-trained weights, so we can utilize them for the fine-tuning on how to sign in the future. And now for the numbers themselves. These are the numbers from multitask. Probably the most important line is accuracy. We are reporting here the results on train and on validation. This is the run with all of the auxiliary tasks. And as you can see, so far, reversed auxiliary task wasn't much helpful. The network is just ignoring it, so it provides us some like random outputs. But for single word detection and multiple words detection, we have already some nice results. Of course, we are a little bit overfitting on the train, so the results on the train tests are right now better. And for the results of the translation itself, we have these results without any context. So we have blue 0.18. It's not much, but it's a start. And with context, it really helped us. So right now we have 3.43 and 4.29 on test. We don't have results on a test without any context yet. This run with context is actually with the context of length equal to 2, and it's the same run I show you its curve before. Yes, and we have some work in progress. We are working on visual augmentations. There are basically two approaches for visual augmentations. We can use standard visual augmentations, but that means that we need to augment our data even before the encoders, which can be a little bit complicated because we pre-train encoders, then we freeze them, and that means that we will have to generate our data in advance. But we are also looking for the possibility of the direct data augmentations of the visual representations themselves. That means that we are looking at the outputs of the visual encoders. If these augmentations would be possible, then we can always augment our data on the fly, which is a good thing. And another experiment which is right now running is the experiment with frozen textual embedding, because we added to the original textual embedding of the llama some new tokens. So right now this textual embedding is also trained. It's unfrozen. But we believe that we also can get some nice results with basically randomly initialized vectors for the new tokens and the rest of the tokens frozen. And then, of course, we have E2PL pre-training running. And the last thing is also we are all the runs was performed with Llama Instruct, and we also wanna test the original model. And the run is running right now. And then we have some plans for the future experiments. Of course, we want to perform some hyperparameter sweep. It's obvious choice right now because the space of hyperparameters can be kind of complex, and find the best ones is not easy task. Then we of course want to try other large language models. Because during the workshop, I'm not sure if everyone noticed, they basically released new Llama model 3.1, then some pre-training, possibility of pre-training, maybe with some word level data set, and also large sentence level data sets. We have some ideas for additional multitasking, like translation to Japanese, or next sentence predictions, or asking the model itself if there are some dropped clips in the context. Then we have some ideas for the context itself, like instead of the real captions, using keywords or the summary of the previous captions, and of course also some better prompt engineering for instruction of the fine-tuning of the model. Yes. Questions?
Could you go back to the slide that had the accuracies?
Of course.
Yeah, I didn't understand something. So reverse, I understand it's a binary decision, it's yes or no. For single word detection.
It's also binary decision.
No, the question is, did you only ask about words that were actually present and yes would be the correct answer, or did you have detractors? Yeah.
No.
So for the words for which the answer was no, what kind of words were they? Were they just random words, or were they close synonyms but not appropriate?
I don't know. Maybe that's a question for Sean. Yeah. Sean, please.
So basically, we build a keyword dictionary with all the keywords we have in the training data.
Right.
And if you want to get an answer no, you just random sample one keyword. That's that keyword, which is not within the translation of current sample. So yeah.
But so it was basically it was within the set of keywords, it was a random choice. It wasn't chosen to be, for example, a particularly hard one. In other words, something that's semantically close, or in the language model sense, it's something that can occur in that context, but wasn't actually said. There was no consideration of that sort.
No, we also discussed about your way, but I think it's a little bit computationally expensive.
Right.
Yes.
Okay.
So
one suggestion to you is to present this instead of just a number. If you could present something like a debt curve, it might be more interesting to sort of figure out what's
Okay, thank you for the recommendation.
Yeah, and the other question actually was for Sean. I remembered what I wanted to ask you after. So for that, go back to the slide where you had the tacos example, right? What I was thinking is, you're going the wrong way. You go backwards, the lady is talking about dragons and tacos. That's it. Yeah, there you go. So I was looking at this and thinking that we may want to think a bit more about how we train these models. So let's take that second sentence, right? They love beef tacos and chicken tacos, right? I would claim that this is not the right way to train, and I'll just tell you what I mean by that. First, I remember my former student, Paola Virga. She was Italian, and she had a habit of dropping pronouns. And she would say, hey, did you know that dragons love tacos, love beef tacos and chicken tacos? She wouldn't say the they, because in Italian, you don't have to. So I think it's a perfectly good translation without the they. And then I can tell you also how without the two tacos, it's fine. Hey, did you know that dragons love tacos? They love beef and chicken. So it's perfectly good translation. There's no reason to say tacos. So what I'm wondering is whether all the paraphrase work that you're doing it shouldn't be used just for data augmentation, but to figure out what targets to set. And that might be the way, well, like, of course, this is not, I'm not pointing out anything new. This is a common problem in translation, period. Nothing to do with sign language. So I'm wondering whether there's some space to think there carefully, because to me, if this is a prevalent phenomenon, that things are being dropped, then you should treat it like a language which drops nouns and pronouns and other things, and just train it with that knowledge in mind.
That's a very, very good suggestion. I think for now we're developing a system. We need to also develop the matrix that aligns with the system. So I think what you said, we might need to modify our evaluation matrix to allow that to happen. But I think that's a very, very good observation suggestion. Thank you.
I have one comment about the evaluation. This goes back to Sanjeev's question about data augmentation on the target side.
Okay.
So you mentioned that, I guess, the intuition was to address data sparsity, right?
Yes.
And to prevent overfitting. So, and presumably you accomplished that by doing this, but one other way to measure this would be some metric that measures the diversity. For example, number of unique unigrams and bigrams that were produced in the outputs, right?
Mm-hmm.
The hope would be that by doing this, you would see that go up.
Yeah, I understand. That's not something we did, but it's a good suggestion, and we definitely can try that. Thank you.
I want to go back to Xuan. Sorry. This microphone should be lower, right? So you were dealing with multiple feature extractors, right? So did you observe which one was the best? Do you have like some ablation study on that?
Future work.
Oh, okay. Okay.
Thank you.
Fair enough. Thank you.
Okay, other questions? Okay, here you go.
Thank you. Okay, so we are a little bit running late, but there are a lot of questions, and it's good to see that people are curious about the system. So I'm Jiri, and my responsibility here is to build the demonstration application. So the question is, why even build a demonstration application? Well, one of the reasons is we can visualize stuff because we are doing visual. We are doing a visual task, and seeing just an array of numbers, that's hard to judge. Whereas when you see a pose, you can see how well it aligns with the video, and you can debug much more easily. And it also allows us to really learn what the features that go into the encoders look like, and what the features that go out of the encoders look like, because the system is a complicated pipeline made up of little pieces, and we would like to probe in between those pieces to see that everything's doing what we expect it to do. Because otherwise we end up in integration hell and nothing works, right? So how does the demo work? Well, you start with a pre-recorded video of a American Sign Language signer signing some message. You go to the website where the web application runs, and you upload the video, and then you wait, because uploading is fast, but the processing takes forever. Because, for example, we need to normalize the frame rate. The frame rate spans 8 to 60. We need to normalize it to like 23 to 30. And there's a lot of processing going on, detecting the poses and feeding it through all the encoders. So in the end, a 1-minute video takes about 5 to 10 minutes to translate. It's like half the time is the pre-processing and encoders, and the other half of the time is just the language model, because it's just such a big monster. And then when all the processing finishes, you see the video with all the metadata that has been generated during the processing process. And now it's time for me to try the live demo. So let's hope that everything works. The moment of truth. So this is the already uploaded video. I can like just quickly show you. This is when you open the application for the first time, you see the uploaded videos. You can upload the video in here. You can even try to record it, but it's like, it works, but it's a little ugly. And when you have the video uploaded, you open it. I have it already opened here. I'll play it and just talk a little bit about what you see. So The video itself is positioned based on the signing space that's detected. There's the green rectangle. And within that, you can see that every second the video slightly moves because the signing space is redetected every second based on the post information. I can show you, like, this is the post that the signing space is detected off of. This is the work of Jakub. And then we detect the features, the poses of hands and face, and we can check that everything works. Like and just the fact that we can see the crops, that, for example, these 3 crops, they go into Dino, so we can see how jittery the hand is, how blurry it is when it's moving, so we can get a better idea of what the Dino is actually looking at. And the thing about probing into the system is very helpful, because one of the things we debugged in the early stages is that the frames for the Dino were dropping quite a lot. And we traced it down to the fact that we swapped RGB and BGR channels due to OpenCV doing it the other way than Pillow. So it helps with debugging. And here you can see the translation, which currently doesn't work because I'm using a model that's mostly trained on keyword detection, because we have a lot of experiments in progress, and the keyword detection model that I'm currently using was sort of interesting to show some features on. We will get to that. The clip translation changes. It's translated clip by clip. We sort of talked about this before. So I'll just jump back into the presentation to quickly, yeah, what is a clip? Well, it has been said, we have issues. There are also technical issues and reasons why we slice up the video into clips. And one of them is the fact that the language model has just a finite context window, and we cannot give it a 15-minute video because it will lose track of, it wouldn't fit into the context. And the second issue, well, even if we were able to give it a 15-minute video, we would just get a wall of text. And how do we, like, we don't know where in the video person says a certain sentence. So to get at least some text to video alignment, we slice it up into clips, and we translate each clip independently. And we do it with context, which Johan already mentioned, so that the translation is better. And just to show you that this is actually what's happening, I can pull up a different video, a shorter one. Here, this video is from YouTube ASL. Like, the YouTube ASL videos have this green screen background. And you can see that here we have actually 2 clips, because the clips currently are 5 seconds long. So here's the boundary between clips. Because we didn't have time to develop a proper clip detector, so we just say 5 seconds and slice it up in constant sized chunks to see if the model does anything. You can see now the translation is actually a proper sentence. I can keep it like running in a loop. This is because the video is from the training dataset, whereas the previous one is from YouTube ASL, and the model currently struggles with the background, and it throws it up so much that the output is pretty much nonsensical. One of the features I didn't mention is the fact that you can slow down the playback to a half or a fourth, because when we were asking Richard to translate for us the video, he said sometimes they are signing so fast and it's so out of context that he has to really look at the signs in slow motion to see what's happening. Because when you are, in real life, you have the context, so you sort of assume when the person is signing, sort of you don't do speech recognition word by word. That's what I'm trying to say. You do it in context. So slowing down is better. And so for example, let me take, right now I'm in the first clip, and the translation is, you know what I'm talking about. How does this come to be? If you scroll down, here's a section called prompting playground. And we can see we are looking at the 0th clip because we index from 0. If I click on translation, this is the prompt that goes into the language model, and it gets all the visual embeddings. Well, not true. That's not true, because this current model is actually trained only on Maya, so these two don't do anything. But for other models, we have other modalities as well. So I give it the visual embeddings, I give it the prompt, and I just send it to the language model. And it says, you know what I'm talking about. If I don't give it the visual features, and I give it the same prompt, it says that it doesn't see any video. That's interesting. Like this model actually says that I don't give it the visual features, which is an improvement. And I actually integrated this model yesterday at like 10 p.m. because the model that was before that was like I was choosing from like 5 models, and the very first model was so broken that it wasn't very interesting. And the latest model for the context translation was sort of good, but it was so good that you could see that it's wrong. But this one is so bad that it does something interesting, but it's sometimes funny. So it's like, at least it's not uncanny, if you know what I mean. And the thing is that you can now play with the prompt, and you can ask it the keyword detection questions. So I can ask like, is there a turtle in the video? Yeah, if you want to see the video, I can break it out. Because I have the slider down below, and this is the. Oh yeah, we're talking about the features. True. Okay. So this is just the plain language model, and it's formatting the response properly. If I give it the visual features, it says yes because the model is not ideal, but yeah. And we've got prompts for other things, and you can actually I can ask it, which is a prompt. What is your purpose? Is a prompt the model has not seen during training. So the question is like, what happens? I'm here to help you. Well, that's interesting. And one other interesting thing is that if I turn off the visual features, the response is actually more elaborate, hopefully. Okay, and it sort of recites the system prompt. So like the visual features, what I've observed is that for prompts that are out of domain, if you give it the visual features, the response becomes more succinct, more shorter, less elaborate. It's also, I had a plan. I wanted to ask you, who are you? This was my original idea, because if you do this, it's actually, yeah, without the visual features, it says I'm me. Yeah, and with the visual features, it's interesting that it says no, because it's actually a response to the keyword prompting task that it has been trained on. You can see in the other video that is not from the training data set. If I ask it a keyword question, let's ask about the turtle again. Okay, the response is no longer formatted correctly. For some reason, if the input video is not from the training domain, the visual features become so messed up that it throws off the language model altogether. And if I disable the visual features here, I get a response from just the plain LLM, and it's going to be this. It's going to make up. Okay, just the whatever. So that's what I wanted to show you with regards to the demo and playing with the prompt. And this is just fallback in case the live demo doesn't work. Yeah, the very first model sort of liked send for some reason, I don't know why. And when I came into this project, I was wondering, I saw the architecture, and Kevin talked about the fact that the encoders produce the visual features, and the visual features then are projected into the textual embedding space. So I was like, what is the visual features projected into textual embedding space, right? They should be text-like. So my question is, if the visual embeddings were words, which words would they be? So the idea is simple. Take the visual embeddings, and for each embedding, find the closest token via its embedding, let's say by doing just a simple dot product. And if I do this, and I give it a video, we can quickly observe an interesting fact. For example, the masked autoencoder and sign2vec probably collapsed because they are just producing a single token, quote unquote token. Whereas Dino stays, it stays diverse. So there's a chance that maybe the Dino projector is actually doing something, whereas the other ones failed during training. And the other, so I had this visualization idea of like taking the clip and just counting how many tokens appear in the clip. And if the clip talks about, let's say, I have a turtle, I would see like 3 large blobs saying turtle, me, and having. So that was my idea. And I do have this implemented, but unfortunately, due to the like not optimal model, it's not doing anything interesting. Like it very often, it likes, if I can just make it play and see some other clips, you can see some collapse into multiple clusters, but there isn't yet anything interesting. And I think that this is the place we should investigate. Like, why is it that the visual features are not ideal? And this is why we built the demo to actually see into the internals to be able to debug these issues. And this is all from me, and I will pass the mic on to Richard.
So hello, my name is Richard, and I'm an undergraduate at UC California, and I'm a CODA, which is a child of deaf adults, and I use sign language on a day-to-day basis. And as someone who knows sign language, I was tasked with timelining and correcting video subtitles to make translation more precise. I went ahead and timelined these signs used per sentence and phrase, finding out that 6 out of 15 captions in a specific video weren't correctly timelined. And this specific video length was about 40 seconds long. It took about 30 to 40 minutes to timeline the caption sentences and phrases to the signs. And one important thing to mention, especially with this whole project, I think, is the inclusion of the deaf community. And the potential benefit of having more perspectives from the deaf community and more involvement for the deaf in technologies for the deaf. I believe it would be beneficial to include deaf universities, such as Gallaudet University, which isn't too far from us, luckily. And then working with Gallaudet University would benefit both of our universities, as well as the deaf and hard of hearing with this project, especially when working with technologies and innovations for the deaf and hard of hearing. And that concludes the presentation.
Thank you. I want to conclude this presentation. And also I have to stress out that what I've seen in my career is many times people work on sign language recognition and translation without actually knowing anything about the sign language. And for me, it was a really first opportunity to work with a person who is a CODA on this project very closely for a very long time. And it has shown me the real importance of it. And I think that Richard also saw some kind of aspects from the other side, and we need to work on this interface, I think, between the scientists and deaf community and include them into this research. Then can really help us tremendously, because we may have some intuition about sign language which might not be true, and we miss a lot of things. So this might actually help to develop better technologies. And also I think that it has been shown, and as Richard mentioned, it is very important to have a person who understands the language to do our data for us. And this is something that I think should be improved upon, to include this community also into the work process of creating better data, so that we can create better technologies, so that we can write many beautiful papers and create a virtuous circle that would help each other. And for the time's sake, I prepared some slides about the outcomes, which I already talked about. So I will skip over them. And of course, Ivan has mentioned the future work we want to do. And there is big interest of my team to continue on working on this, and I myself want to continue on this very very hugely, let's say. So I have the support of my team, and the future is bright. So thank you for your attention, and that's it from us. Thank you.
So we've been asking questions throughout, but if there are still a few burning questions, we can take them. I know we're a little bit over time, but I never want to stop questions. Pedro, come on up.
Of the 4 features or sources that go into the model, left-hand, right-hand pose, have you do some analysis of which one matters the most?
Well, we have been doing few analyses on this, but unfortunately we do not have the final conclusion on the translation because the translation is not yet there. What we have observed on the demo aspect is actually a strange behavior of mask autoencoders and the sign-to-vec, which produce just single tokens all the time, and we cannot make them produce anything else, whereas the Dino produces some reasonable mapping to the language prompts. But the Dino needs another modality to help it to translate better, on the other hand. This is because Dino loses the global aspect of the pose and just see the local views. So this is the analysis we did.
Okay. The reason I ask is because things would be much easier if you just get the video. That's it. And let the model figure out the rest. No need to do all this analysis, pose extraction. Of course, it has to work. The other question I have in mind is augmentation. You know, like in speech recognition, we have been using TTS in the last few years. Now that TTS engines are fantastic, you can generate thousands of voices, any language. You can introduce noise. So people have been using this to augment speech recognition, especially in situations where you don't have a lot of data. So I wonder if you have considered augmentation with image synthesis. I believe there are systems out there that, given a text, will produce an avatar, very realistic signing.
You have tapped excellently to the things we have discussed in the workshop. So first of all, the end-to-end training with the video is of course a possibility when you have good enough hardware, which is a bit of a problem. So that's why we skipped it. For the poses, we actually do augmentations because the poses representations are easily augmented. We played actually because we had produced the features for the training beforehand, and we just used it as a data set for the Llama model. And we actually tried to figure out whether it's possible to augment the features themselves. We see it's not an easy task, but there are some interesting results we have, and it might be designed to actually augment the features rather than the inputs. Yeah, because the augmentation of the inputs will definitely produce different outputs. This has been studied in many studies, but we think if we precisely go for each modality, we can design. And for the last point you made for the synthesis, so we didn't try it, and we think that there is a possibility of just to, if I say it like this, to wait for better models that produce videos. So in that case, it will come for free for us. But I'm wondering, for now, what we see in image synthesis is it's not able to produce sign language videos, right? It's able to produce generic videos, let's say, about some actions and activities and domains. So we actually wanted to explore this option also, but I think that we are not there yet, technologically wise. But definitely this can be a possibility. We could try to use avatars for the augmentation, but because we have, for example, motion capture system and we recorded many signs in Pilsen, so we could use actually to render some avatars, change appearances, change background, and so on. So this is a good point, but we are considering it. It's the work of future.
The other suggestion I have is maybe instead of starting from a text LLM that you adapt with LoRa and with adapters, if you can get your hands on a pre-existing multimedia LLM, an LLM that is native already for audio, video, and text, you might get, the model is kind of aware of video itself, so that might help you a little bit.
Yes, actually, yesterday we sat in a lab and read the new Video Lava 2 paper. So this is something totally that is going to be in our scope. Yeah, thank you.
Any other questions? Okay, so let's thank the whole team again, Marek and everybody else. Thank you. These are good presentations. Yeah. And again, we will take a lunch break now. I would like everybody to come back here a few minutes before 1:30 so that we can start right on time at 1:30. So see you all in about an hour and 20 minutes.
Only weak point was when I feared that Václav is going to start arguing with something. I was like, no, please just shut up. Well, thank you, Václav, for. I saw that you would like argue more and stop.
Not in this setting. I also consider that I will come.
And Ivan, I have to tell you, your 8 minutes were like 20 minutes. So it's just,
Oh, sorry.
just next time try to focus more on the estimation.
I noticed that.
Everybody, thank you. You took it really fast and it's great actually because we were out of time and everybody's timing was almost perfect for you.
Sorry, I finished my slides this morning. I missed the whole slide. So.
I was just, when I was just giving you this signal for the
Yeah,
fifth time,
I
and you
tried.
did
I
seems to me it's like the same. Okay, let's go. Did you ask someone to take a picture?
I tried. What about pasta?
Oh. Mic check 1 2 3. Mic check 1 2 3.
Hey Pete, how's the battery levels look now on that one? Everyone. Okay, cool. Yeah, I took it off. We're not gonna use it anymore.
Hi everyone, my name is Tom. I'm a rising sophomore here at Hopkins studying computer science. So thank you so much, Kat, for introducing the overall architecture. I think the main problem that we need to solve now is the relationship between ranking and the scores. So here's our proposal. We model human ranking as a noisy sorting problem. We sort the posts by their latent score. So when a human annotator annotates a task, for example, here you can see that he receives a focus post, several candidate posts, and 2 tier separation markers. What's actually happening? Hi everyone, my name is Tom. I'm a rising sophomore here at Cat for introducing the overall architecture. I think the main problem that we need to solve now is the relationship between ranking and the scores. So here's our proposal. We model human ranking as a noisy sorting problem. We sort the posts by their latent score. So when a human annotator annotates a task, hi everyone, my name is Tom. I'm a rising sophomore here at Hopkins studying computer science. So is that is that the human inside his mind has a score for each of the posts and the markers. Ideally, the rank that he gave should be based on those scores, like this.
801 Baltimore Street.
right. Right, folks, it's almost 1:30. We'll get started in a minute. Everybody please come in and settle down. And while we're getting set up very briefly, this is the main program, and these are instructions for people online. But if you go one slide forward, which I hope I can, there we go. So after we finish here today at 5, we have a short break to unwind, put away stuff, clear the auditorium. Everybody in the workshop, please come over to Gilman Hall. We'll do some team photos. We'll have some cocktails. We have live music, I believe, and then we'll do dinner. So please don't delay too much, because we do want everybody here in the photos. I mean, we did Photoshop people in the past, but it doesn't look very pretty. All right, so let me go back to the main program. Again, if there are people joining us online, which is very likely given the timeliness and the interest in this topic, do note that we have a fairly long delay, because while we capture the video here, we send it over YouTube. Takes about 25 seconds before you see it. And if you instantly ask a question and we instantly get it, which you can do on chat, and we answer it right away, it takes another 25 seconds for our answer to reach you. So even if everybody reacts like with lightning speed, it's a minute, and usually it takes a little bit longer than that. But still, we do want questions. As you've seen, there are a lot of interruptions. We'll deal with it. So please ask questions via chat. Paula is watching the chat here, so we will take up your questions and we'll interrupt the speaker. So with that note for the remote audience, let me now ask Jason Eisner to come over and start the afternoon's proceedings. Let me kill this PowerPoint and give you yours. The other one? Yep, I will bring yours back. Get out of full screen and simply, okay, I have another PowerPoint open with yours.
Yeah, that's the one
you want. Is that the one you want?
That's the one.
All yours.
Unless it's the evil twin.
More fun.
Yeah. Okay, hi everybody. So this is the last presentation of 4. Thanks to everybody for your patience during this long report out. This is our team for AI curated democratic discourse. Everybody put in a fantastic amount of effort doing a startup in 6 weeks. And I also really want to thank the organizers and the sponsors for making it possible for us to do this in such a wonderful environment. So here's our outline. I want to talk first about our goals in this project. So that'll be about 20 minutes, and then we'll spend about 10 minutes on a live demo because we actually built something. And then we will talk about how things work inside for a while. So that's the left column. And then we'll have a 10-minute, that'll be about an hour and 20 minutes. Then we'll have a 10-minute break. And we'll spend about an hour saying how we got human judgments and used them not only to train, but also how to measure performance. This stuff is still in rapid flux, so you should expect future versions to change a lot, and we'll talk about the future. So if you put up your hand for questions, people might stop. Okay, this is why we're doing it. Technology was a hero for a while. If you are a process person, and I am, you figure that to fix anything else in society, you first have to fix campaign finance and the election system and social media. Social media was supposed to be a fix, and it does have power to help people inform themselves and organize themselves, but did I have an HMM on the slide? Oh, yeah. I do like HMMs. Unfortunately, you can't do lowercase on these things. So like in 2011, everybody was like, oh, social media is going to give the people power. We have the Arab Spring. And 5 years later, it's like, well, now everybody's talking and nobody's listening. And maybe the people who are getting the most play are the people who had the biggest megaphones because they already had power. So An important question is, can good ideas rise up from non-powerful people? There's a lot of people talking, and we'd like to do some kind of filtering. This is the information overload problem. And the difficulty is doing it without putting a thumb on the scale. So people are saying interesting stuff, but there's lots of other things out there that's redundant, unproductive, polarizing, misinformed, maybe deliberately misleading. There's a separate problem, which I think is an artifact of the social media interfaces that we've had forever, which started with Facebook, I think, which is that when you post something good, it's kind of trapped in the thread where you posted it. So if I post something that's questionable, sus, you might spend an hour explaining why I'm wrong, but nobody else is going to see it, even if they post the same questionable things. So we'd like to be able to liberate good posts from their threads and show them elsewhere where they might be useful. So even if good ideas can come up from non-powerful people and be shown to other people, can we show them in a way that they'll penetrate the filter bubble? So can we show them to the right people who might not otherwise have seen them? And can we ensure that the people seeing them will take them seriously? Because people have all kinds of defense mechanisms against ideas that challenge them. We have some here in quotes. And the sort of the broader question is, can human societies even sustain serious discussion now? Because there are many voices, there's no accepted authorities. First, there was the 3-channel world, and then the 500-channel world, and then the everything, everywhere, all at once world. And the way most people manage in this information ecosystem is they listen to people they're already familiar with. And that means that people retreat into their tribes. Okay, so we wanted to know, can we re-architect social media? We want to reduce polarization rather than feeding it. There are sites that are manually curated. They're not social. They're basically reference material. So you have people trying to curate all the arguments on both sides. So the people who go to those sites are basically the same kind of people who edit Wikipedia. Why is it that people go to social media? Well, there's all kinds of reasons, which are basically social reasons. Or they might be reasons that contribute to polarization, like they want to own the other side. They want to show the other side how well they can argue. They want to, attract friends, convert people, and so forth. A lot of it is just purely social. But to the extent that people are performing for each other, that performance may exacerbate polarization. So there's this final reason, and I put it at the bottom because it might be rare, that people go on social media because they actually want to educate themselves and have constructive discussion. Even if this is rare, we would like to provide it anyway. So if you're at the Super Bowl party, there's lots of delicious things here, but we would like to put out some vegetables in the hopes that, maybe if they're there, some people will eat them. All right, so, sorry, what is this a picture of? I think this is a picture of people moderating. So they're all in their cubicles at, say, the New York Times, which has a staff of about 40 moderators to moderate all the comments. Manual moderation is expensive. It's also slow, so there's a delay before people's posts appear that they don't like. Users may object to it, so they're like, I was censored. Most media sites, because this is difficult, have turned off moderation. So even the ones that still have it, they may be civil, but they're also kind of disorganized. If you try to read the comments, you are scrolling for a long time, and they're kind of in arbitrary order. Or if you sort them by most liked, that's the things that were posted earliest, and there was kind of a winner-take-all. They tend to be representative of the population on the site. And they tend to confirm the biases of the people on the site. So you've got a lot, on the New York Times, you have a lot of people saying, oh, this news is great or this news is awful, reflecting the views of the kind of people who read the New York Times. And if there's any competing views, you have to scroll for quite a while before you find them. So we'd like to promote and organize the best posts. We'd like to curate a well-structured, thoughtful, balanced discussion that doesn't take forever to read. But at the same time, we want people to be able to still have the traditional experience where they can talk to their friends. And we don't want them to feel like we're putting a thumb on the scale. We're just putting out the vegetables. They can decide whether they want to eat them, and if so, whether they want to eat the tomatoes or the raspberries. Sorry, tomatoes or the blueberries. You know why I said that. Okay, so we'd like to convey to the user a sense of the range of viewpoints that are out there. Not just the range, but also how much support the different viewpoints have. We'd like to surface the most cogent ideas on the topic of discussion. We'd like to help users write more constructively in the first place, instead of waiting until bad stuff is posted and then filter it out. And we'd like to take a light touch in a light font that doesn't drive users away. Okay. We especially want this site to support the functions of political discourse. So there are lots of things that people might talk about, like Barbie or Oppenheimer, which should we go to tonight? And you know, you want to be able to join readers to discussions that they might be interested in, and if they start typing, you want them to realize that there are already existing discussions that they might want to join instead of starting a new one. But political discourse is especially important, and so we focused on that in the data that we collected and worked with in these 6 weeks. So promote broad understanding of issues, which we hope will lead to more civil discussion where people understand one another better, and ultimately better policies in our society. I mentioned the Arab Spring. That was a case of allies finding one another. We'd like to make it easy for people to find, it's not just understanding the other side, it's also getting together with people on your side, so you can work together, and then you're surfacing good ideas within that group. There's also people who look at social media, understand what the world thinks. So there's a number of people who are required, like government agencies, who are required to sort through public comment. And there's journalists and policymakers working informally, and also social scientists. We have one on our team who we'll talk later. So who want to understand what society thinks so they can report it back to the rest of the society. Okay, so our prototype, which is called Stacky, is a new user interface design. So we implemented this from scratch. We started by replicating a traditional social media UI, and then we added curation and feedback using AI. And the AI that you're going to see in all of this is OpenAI embeddings, GPT-4o, and some small models that we built on top of those two things. Okay. So we haven't done a lot of experimentation yet to see like how much it hurts if you go to smaller models. We set up a Mastodon server to host the social media data. Mastodon is a Twitter workalike. And we're not using their front end, but we are using the back end to store our posts, the replies, usernames, likes. People can edit posts, people can follow different posts, different users or different hashtags. So all that infrastructure we just borrowed, it's open source. Mastodon can get its content from other Mastodon servers. So this is what's known as a federated or distributed social media ecosystem. It can also get data from anybody who speaks the same protocol as Mastodon, for example, Meta's Threads service. And we we're particularly interested, as I said, in political discourse. So we added discussions, even though these these sites, New York Times, Fox News, and Reddit, don't speak the Mastodon protocol. We just pretended they did, and we stuck those posts and replies onto the Mastodon server. Okay, so so before we have a look, I'll say organizing threaded conversations is a very general problem. So information overload is the big problem, but threaded conversations is a fairly large part of that. Here are 3 use cases that we should be able to handle. So there's traditional social media, where 90% is people sharing pictures of their kids, and the other 10% is political, and we want to be able to, like when somebody starts getting political, we'd like to be able to point out that there's other perspectives or maybe people aren't engaging well. There are discussion forums, which are maybe more focused, where people are talking about knitting, or people have a project and they're trying to see the posts that are most relevant on Slack or something like that. And then there's reading the news. So all three of these are basically the same problem, where there's too much information, and we should be able to do a better job of organizing them. From our point of view, these are just different content feeds, different ways of subscribing to seeing different content, but technically they're identical. There's a bunch of posts, they have threaded replies. So on Mastodon, the feed that you see depends on, Mastodon is designed to support all of these different use cases.
Where would you put business correspondence in this?
Something like Teams or Slack would be in number 2. So those are discussion forums. Reddit is also like that.
And how about things like email?
So email is not public discussion.
Okay.
So in order to do so,
what I'm thinking is within an enterprise, like let's say all the JH email.
Yeah.
There is a lot of I see the need for this organizing threaded things within that ecosystem.
So we're not trying, I agree with you,
Yeah.
But we're trying to solve a problem of being able to show people other things that they might want to read. So if you're doing your email, we might be able to show in the margins other enterprise-specific content, like things that were sent to mass mailing lists or posted on something like Teams on a channel that you have access to.
Yeah, no, what I'm thinking, for example, is that
Yeah.
parts of the university run into a problem that another part of the university has solved.
Yeah.
And things
So
like
the question is, are you allowed to see that stuff? If it's stuff you're allowed to see, we could pop it up next to your email.
Right.
But we couldn't
No,
pop
all I
up your
wanted
email
to know
next
is
to that.
where it fits in this classification or organization. Would it be, is that also a form of, no, that's not quite.
It's not quite the same,
Yeah,
and so we haven't built the email kind of thing.
Okay.
Some of the general principles we're talking about, like surfacing relevant content from elsewhere in the organization, could apply to those interfaces.
Yeah, yeah. I
So
was
it
just
could
thinking
be
about-
some of the same AI.
Enterprise level stuff, yeah,
Yep.
okay. Yeah.
Good question. Okay, so I do want to emphasize here. Sorry, is this what's going wrong here? Seems like the animation. Okay, there we go. It's back. So these different experiences are all supported by Mastodon because they just depend on what's your data set. So these three cases differ partly just by what the posts actually are. Are they political posts from a publisher with replies, or can anybody talk? And what the subscription mechanism is that says what content you see in your main feed. And we don't currently have an algorithmic feed. In fact, Mastodon, by default, their default user interface doesn't support one. One could add one later, but an algorithmic feed tries to recommend posts to you. We just use the default for that. All of the algorithms we do are when you're already looking at something and replying to it, what's different. Okay, so here's traditional social media where the feed is posts and replies from your friends or people you follow. Facebook, you only see the posts and you have to click to see the replies. In Twitter, the replies are mixed in from the beginning. Discussion forums would be things like Reddit and Stack Exchange, and the feed is all of the posts on channels you subscribe to, so topics that you follow. And in a news aggregator, your feed is articles from publishers you follow, but most of the publishers allow commenting. So news articles with comments are just like social media posts with lots of replies. That's the point I'm making. Okay, so let's look quickly at our prototype. So I'm first going to look at a standard user interface. Yeah. I don't have a mouse here. Oh, look at that. Okay, that's because we're in presentation mode here, and I need to escape out so you can see my other. Okay, good. Okay, so this is what our version of the standard interface looks like, right? You just have a bunch of posts. We could click on one, and this one is quite long because we didn't truncate it. That's the whole article. And you can see that there's a bunch of replies underneath. Okay. So this is kind of what you would expect. All right, so now let's shift over to our interface. Okay. And you'll notice that every post here is actually on top of a stack of related posts. So there are a lot of people who are saying similar things. And an organizing principle of the site is if you have a stack of posts, you can click on this, you know how many posts are in the stack, and the depth of support for this post, or at least this topic, is revealed to you. And you can click on this icon to actually explore and see what other people are saying there. And UK will give a full demo, but we automatically open up these posts as we go down, and you can start seeing some of the related content when you're looking at the post.
Just a question, do you have a mechanism of selecting the representative post, or is it just by...
I'll get to that.
Okay, thanks.
Yeah. Okay, so this is the basic idea. So let me go back to the slideshow here. Okay, so this is what you just saw. Here we have the focused post. Here's replies as usual, shown under the post. The ancestors are shown above the post. And here are related posts suggested by AI. Okay, so let's click on, let's dive into this stack. So we click on this, and we see that it splits into substacks. So these are clusters. And those are exposing diverse posts or diverse views. The depth of each stack suggests the depth of support. So even though we have diversity, if 95% are in favor of a policy and 5% are against, we want to show the against, but we also want to show you that that's a minority view. And each stack is putting its most relevant post on top. In the information retrieval sense of relevant, like whatever it is that we selected these posts in the first place to show you, we're also going to sort them by the same criterion. Okay. And if you click on a stack that has more than one post, you can recursively expand it to see diverse, relevant posts that exemplify that stack. Okay. So there's different views if you want to explore the stack. So Substack's not the only thing. You might not want to do depth first search because that takes a while. If you're really interested in seeing what's in there without doing too much clicking, you can list all the posts in the stack. And again, our sort order is going to balance relevance with diversity, which was like what we were trying to do in the Substack view. And sometimes IR systems try to do diversity in the search results, especially for ambiguous queries. And we have a final view, which is a summary of the posts in the stack produced by AI. We just plugged this in yesterday. This is a really minimal prompt. And it tends to produce very ChatGPT-like dense responses written at too high a level if you're just trying to skim. So we have to do some prompt engineering work. Okay, we have the same features here to explore replies. So sometimes you get too many replies. Facebook has, we can do our recommended replies, or you can group the replies into stacks, or you can get a summary of the replies. We talked to somebody at Facebook who is interested, who has worked on recommending replies. So if there's too many replies, they'll just show you some of them, and there's like it'll say most relevant, and you can switch back to the standard view where they're chronological. But they rank them most relevant by engagement, and we're doing it by content. So again, when you've got these replies that are ordered here, if you're not seeing the stacked view, the stack here is, again, relevant posts from across the site, and you can click here to see other people talking in other threads about the same topic. Okay, so what's going on over here? We have these stacks here that you see initially in the margin are grouped not by topic, but actually by the type of contribution that they make to the discourse. So here are the different types, and if you click on these, you can see different types of contributions. So these are rhetorical value of the post. And then if you want to see different things within that rhetorical value, you can click on the stack. So here we have do I agree with the original post or disagree? Maybe neither, maybe both. Am I making a proposal, or am I making a prediction about what will happen in the future? What should happen in the future, what will happen in the future. So these are things I've concluded about the topic if I wrote that related post. And I might also give reasons. If it's a good post, I'll give reasons for why I drew those conclusions. I might state my values. I might give some evidence, either things you could check or things that happened to me, evidence that you could read somewhere else. Or I might make analogies or connections to other situations. So these are kinds of arguments that I make for these conclusions. And occasionally, I might attend to the fact that I'm in a conversation with a bunch of other people. I might say, I think really the reason you guys are disagreeing is such and such. So frame the issue. I might actually ask some questions, not just rhetorical questions, or I might make a joke to leaven the conversation. So the final thing I mentioned is we want to present some feedback. Here we have a post, and Reva started replying to it, and we get a suggestion about it. There's some praise at the beginning, and then a suggestion, and then some replies that you might expect if you were to hit the submit button. And so these are simulated by AI. Okay. In this case, the post was kind of vague, and maybe because it's not complete yet, and the feedback is picking up on that. In this case, is this not showing up? Sorry, this seemed to try going a little slower. Okay, right. In this case, the response is, somebody got on their high horse and they didn't understand the original poster was joking. So, maybe we should catch that out before they disrupt the conversation. Basically, they'd be feeding the troll. Yeah. Sorry, again, somehow this is, PowerPoint is not keeping up. Okay, in this case, somebody posted some misinformation that 85% of global warming is caused by cows. And very interestingly, the first simulated response down here says actually most scientific studies estimate around 14.5%. These are diverse replies. So this is saying fossil fuels might be important. And this person is saying that basically the same thing, that it's oversimplifying. So you often get different perspectives which are about content and about style. And in this case, there was a misunderstanding. So the idea of the feedback is to head off poor communication. There's a lot of kinds of poor communication. You might be vague or off topic. Maybe somebody is failing to engage with the previous poster's point or even misunderstands it. And people might have various kind of antisocial behavior, misleading or incorrect information deliberately or accidentally, poor writing, or some kind of toxicity. And we can also encourage good communication. We start with praise before making a suggestion. And we think this is better than something other people have tried, which is having the bot wait till after the user posts and then post their own response. That kind of embarrasses the user in public. By intervening earlier, it's private feedback, and there's still time for the user to change the post before they hit submit. So the way we addressed the goals was, I told you how we're conveying a sense of the viewpoints out there, how we're surfacing cogent ideas by basically mixing diversity and quality. We're helping posters write more constructively, and we still preserve the traditional interface in the main column, and we're just giving people some extra stuff. Okay, so our planned deliverables here. So our code is on GitHub. The private parts we'll make public. We think we're going to have some papers about HCI, sociology, systems for building NLP prompt engineering, and we had to do a little machine learning that doesn't seem to have been done before, and we'll be looking for follow-up funding to do this. Okay, so Yuki's turn for the demo.
So hello everyone, I'm a master student in Hopkins, and my name is Yuki. Now I'm going to do a demo for our project.
Sorry for the delay. Let me
continue. So as Jason mentioned before, there will be related stack on the right side. When you scroll down, the tab will automatically expand, and the related stack will show in here. If you want to search something you are curious about, you can also click here to do the search. Let's say you want something to eat, and by click here, you may see some. Ah. R directly. Oh, I see. Sorry. Okay, if you search something. We will see some result post, and it will automatically construct it to a stack, and which you can click the tab here to see the related content. And back to the home page. For this home page, you can see the post that is the people and topic you are followed by. But in here, you can see the related stack. And if you are particularly interested in one post, you can click here to make it focus. And by scrolling up, you can see the ancestor. Let's move to another post. So here is a post with a lot of reply. Sometimes you may find that the reply is too much, and some of them are boring, some of them are bad quality, and it makes you difficult to find new ideas through the replies. So we do almost same thing to make all the replies into 4 substack, which you can see in here. And if you click this button, you can see what replies are in this stack. So here are the substack of this stack. You can click here. You can click the button on the right side to do the recursive reading, to see what is inside this substack. And also, if you want to have a detailed reading, you can click the recommend tab to see the post we rank it by AI. And these are the functions that we offer you for you to have a better experience in reading and finding good quality content. But we also want you to do some replies more constructive and make some contribution to this whole community. So we offer AI feedback. For the AI feedback, let's look at this post. If we want to replace it, it's generally it's an article about explanation of why now teenagers want to wearing second-hand clothes, and we will see something. I already make it So it's a personal experience, and we will see the feedback in here. So the feedback first said it's a good reply, and then it have some advice for me to improve my content quality. And you can also see the similar to the reply in here. And that's all I want to say. So you may interested in what happens behind it. Let's hand over to my teammates.
Hello, everyone. My name is Tsugunobu Miyake. I am a rising senior majoring computer science and engineering at Bucknell University. So at this point, you might be wondering lots of questions, such as how do we find these rated posts? So as you saw, for every current post, there are stacks of rated posts that are somewhat related to this current post, but in several different ways. To find these rated posts, the first thing we do is to use OpenAI embeddings to find similar posts in terms of its content. So we embed the content of a post, and we query the vector database using cosine similarity search. We retrieve up to 50 vectors, and we find the corresponding posts, which becomes a rated post candidates. So we find rated post candidates, but how are they rated? Because as you see, there are some categories, the icons that is under the rated stack view. For example, the one on the top is the predictions, which are the posts that make some kind of predictions in regards to this current post. There are proposals, a post that makes a proposal about the same topic. How do we determine those things? We have to classify properties of each post. So for every rated post candidate out of 50 posts that we find, we use OpenAI GPT to prompt to get these scores for if they make predictions, have to have evidence, humors, if they're trying to be funny, they're making connection to different ideas, if they make a proposal, and so on. We use the result to train a vector classifier so that we can predict these results using the default OpenAI embeddings. And since if we ask GPT over and over, it will be costly in terms of both money and time. So we implement annotation cache, which will be explained later. So this is, and oh yes, last thing is that on the runtime, we only use the vector classifier as a backup. If the annotation is not found, then we use vector classifier. But we also have to assess agreement and disagreement. And this is a property of a pair of a post, since we can, so we have to also assess property for the pair. To do this, we need not only the rated post candidate, but also the current post that we are associated with this rated post. We can do GPT to assess if they agree or disagree. And we use the data to train another vector pair classifier to predict those results. For our demo, since this annotation takes too much time, since we're not only looking at one post, but the pair of posts, and so we are only using those data to train the vector classifier, which we use in the runtime. And using the results that we collected, the annotations, we can now categorize where the rated posts should belong to. For example, if this post has higher scores for agree and connection, they should belong to list of posts rated post that agrees and list of posts that makes a connection to different ideas. Okay, so now we have a list of posts. Well, which posts should be displayed on top? Because as you can see here, we say the total number of posts in that stack. And so that post was selected out of 26 posts, and we selected for a reason. So to determine, to compare between different posts within the stack, we need some kind of a ranking. To achieve this, we evaluate from the annotation data, and we compute numerical value from this annotations generated by GPT. Right now, we are just using the handcrafted linear function, but later we plan to collect more human annotations and tune that to match with the human annotations. And of course, if there is no, if the post has not been annotated by OpenAI, then we use the vector classifier to get the annotations to score. So now we have a score, and we can get the highest score posts. Well, how should we store the remaining posts? Because we want to support two main features for looking inside the stacks. One is we have a stack, and we want to partition the stack into multiple stacks to see content inside. Another thing we want to do is we see a stack, and we want to see a list of posts in some order. So to achieve both features, Python list is not enough. And because at runtime, we need to identify the top post that has the highest scoring for that stack. And we also need to list all posts in the stack where top K posts are not the top K highest scores, because they also should have a diverse, those K posts should be somewhat diverse to each other. And we also want to recursively partition into the stack and divide it into substacks, where each substacks should somehow have a higher scores for the top post. And so the solution we came up is the hierarchical clustering of embedded vectors of the top post and embedded vectors of the post, where we evaluate the similarity with cosine similarity and do average methods to cluster them into groups. And we store clustering in a binary tree structure, which I'm about to describe. So suppose we have 9 posts in a stack, post A through post I. Each post have its own leaf nodes. And suppose in these 9 posts, post A and post B are the two most similar posts in terms of OpenAI embedded vectors. Then those two nodes are clustered into one cluster by having a parent node, which its score inherits the higher score between its two child posts. And so right now, node J inherits post B's data and post B's score, because post B has the higher score than post A. If post E and F are the second closest clusters, then post E and F are clustered with having a common parent node, where it has the, this time it inherits the post F's data, post F's data and the score, since post F has higher score than post E. And so as we continue this process until we form into one tree. And since every parent node takes the higher score of two child nodes, the root node will have the highest score, meaning that this the post that has been represented in the root post represents the stack as being a top post. So to implement the feature of dividing a stack into multiple substacks, what we can do is we'll start from splitting the root nodes. Since the stacks, our structure is recursive, if we remove the root nodes, we will have two separate stack structure with the same property. But in our interface, we want 4 substacks instead of 2. So we need to keep this going. But we have to decide which root nodes to split, since now we have 2 choices instead of 1. So one thing we want to achieve is that we want to see different contents among its after dividing dividing the tree stack into multiple stacks. And so to do this, we assess based on the similarity between two child nodes under the root nodes. And so if we choose the one with the lower similarity, then the resulting cluster will be more diverse. Another thing we want to achieve is that we want to see quote unquote good posts. We don't want to show, we want to show good posts after we split. So to assess this relevance, since this stack structure has the only root nodes are, so the post that has been represented in the root nodes is the only post that you'll be seeing, because everything else under the tree will be hidden. So right now, after the first split, we are seeing post B and post H that has been represented in node O and node P. And if we split node O, we will now be seeing post G, which was hidden under node O, since post G had a lower score than post B, and so their parent node inherits the post B. But if we split, the post G will now be shown. If we split post H, we will now see post I, since post I had a lower score than post H, but by splitting their parent node, we will now be seeing post I that has a lower score. So by comparing, by comparing the, size was laggy. By comparing these scores that will be added after splitting the root node, we can assess how much quality we are adding to the list of posts that we are showing. So to summarize, for every root post we can possibly split, we are computing this metric. It assesses a similarity, which is evaluated with cosine similarity between its two children nodes. And we do a minus C to assess dissimilarity. So we want to maximize that value, while also maximizing the score that will be added by splitting the node. So score of the new post that will be shown after splitting the stacks into 2 stacks. We have this weight parameter to balance between the this relevance and diversity. So we evaluate this metric for every roots we have, and we choose the one with the largest metric value to split. And note that this is not the only solution. This has been studied in information retrieval, and we may try other approach in the future. The final thing that I will explain is the feature that to show stack in the list view. And this is achieved by just continuing splitting the binary tree. So we have this tree, and we know the first content of the list will be the top top post at the, or the post that's getting represented by the root node. By splitting, we will see post B as it's one of the root nodes. By splitting again, we will see post G as its root nodes. And by splitting post node P, we will see post I as represented as in root node. So by continuing this process and keep track of the order in which we reveal posts inside the collection of stacks, we can obtain a list that we prefer to we want to show to the user. And so this finishes my part, and yeah.
Okay, hello, so my name is Reva. I'm a rising senior at George Mason University, and I'm studying computer science. By now, you've probably noticed that we have a lot of posts in our server, but where did these all come from? So the most obvious choice for another source was other Mastodon servers, since Mastodon already supports this functionality. However, we quickly realized that this is a problem because there are very few posts with high quality discussion, and the vast majority of posts only have like one reply at most. So we had to expand our horizons a little bit. We added some Reddit threads to our collection of posts from these following subreddits. We tried to keep a balance between like conservative leaning and liberal leaning subreddits. And then we also pulled some comments from the New York Times. So from the world, about 57 domains total, such as world, US, and business news. And lastly, we also pulled some comments from Fox News from these three domains, the latest world and politics news. So here's a quick overview of how this sort of harvest and injection pipeline works. We looked at the RSS feeds for the New York Times and Fox News, and RSS feed is essentially just like a running collection of the top like trending posts for a given topic or a given domain in our case. And then once we had pulled these articles, we found the comments that go with them, and then we converted that whole thing into sort of Mastodon discussions with a root article post and all the comments keeping their structure underneath it. And the Reddit post harvest essentially worked the same way, except instead of collecting articles and comments, we just collected entire discussions. So the process of injecting these posts is pretty. It's built on the fact that Mastodon allows you to pull in posts from other servers. So we created like three servers, one for each domain, and then included data from those. And then we did also make sure to cut outgoing traffic to the Fediverse, so we don't start flooding other servers with our news content. So basically, long story short, we can see posts from other servers, but they can't see ours. So here is a quick example, I guess, of a sample source New York Times post and some comments from it. So this is an article with a bunch of comments, but I've selected 2 here. And then after injection, we've turned the article into a root post, and then all the comments are keeping their structure in response to that original root post. So besides the obvious technical challenge of wrangling content from these 3 different platforms, it was also a challenge to obtain diverse posts for each topic. So what do I mean by diversity? We try to keep posts diverse across metrics like quality, style, and length. The Reddit posts tended to be more like conversational in nature, whereas the New York Times posts were typically longer and more formal. And then we also try to keep diversity across like the depth of discussions. So the Reddit posts were typically, the Reddit discussions typically had like a large depth, where the New York Times and Fox News posts were broader. So the New York Times comments typically responded to the article, whereas the Reddit comments responded to each other. And lastly, we tried to maintain diversity across political orientation. So Fox News typically, or Fox News generally leans right, whereas the New York Times leans left. So we tried to maintain that balance as well. And notably, it is kind of difficult to assess a political leaning to Reddit, but we included comments from a variety of subreddits just in the hopes that that would sort of add some more diversity into our data set as well. So our Mastodon universe, at least for the purposes of this demo, it consists of 9,000 total posts from July 27th through the 29th, so from a couple days earlier this week. And we did collect more posts, but we wanted to limit our universe so that all the news and everything is like fairly current. The average number of replies per post, as you can see from this first figure on the top left, is that the Fox News articles typically consisted significantly fewer comments than the New York Times and Reddit root posts. And even though we capped the number of responses for a root post at 200, this was still something we had to get around. So we tried to solve this problem by just injecting more Fox News discussions entirely. But as you can see from this pie chart, Reddit and New York Times make up about 45% of our universe, whereas the Fox News make up the remainder. So within each domain, we harvested more domains from New York Times than we did from Fox News, and this distribution is reflected in our data set. So from the New York Times, we have domains such as style, science, New York region, and others. And there is some overlap between the two, such as like world and politics, but notably these domains are provided by the news source, so the mapping isn't exactly one-to-one, but it does help us give us a better idea of the kind of things people are talking about in our server. So future work. The data available in our server directly affects the user experience, and algorithms can only help so much if the posts are just not very interesting or not very fun to look at. And so we should study how well our algorithms are able to restore balance among sources. So as I pointed out earlier, our ratio of data sets is not truly balanced, but then our algorithms should attempt to like mitigate this and make sure these minority viewpoints are still heard. And ultimately, we added more Fox News threads, but still got fewer Fox News posts overall. So this is something we're trying to fix. And in the future, we will definitely continue harvesting more data to allow for better viewpoint balance. And now I think I'm going to pass it on to Jason again.
Thanks, Reva. And since you're our timekeeper, how are we on time?
She's good.
All right. She owns the watch, so she's good. Okay, so Tsugo explained how things worked in terms of the pieces fitting together, and we'll talk about how things work in machine learning at the end. But nowadays we also have to talk about how things work in the text of writing the prompts. And so I'll talk about this, and Cheng-Chang will also talk about it in these two bullets. All right, so these prompts show the values that we were trying to get at, and the LLM to some extent is able to do this. I'm going to lead off with what might be an easier prompting task. It was kind of hard to get it right. This is a feature that we didn't actually point out before. So here's a post. And remember, we want to liberate it from its thread and show it in other contexts. The problem is when we do that, it'll just say, why don't Democrats push a bill to make it illegal? And what is this it? Okay. So when we show it over here, it doesn't say that. It says, why don't Democrats push a bill to try to make it illegal for officials to take gifts for past favors, which was the context back from here. So this did rewriting of that. We do indicate that this was modified by AI. It makes a couple of other little fixes to typos, and we tell the prompt that that's okay. Like it capitalized something here and it fixed the punctuation. It'll fix spellings or dropped words or something like that. But mostly it's just trying to clarify to make sure that things are understandable out of context. So here are a couple other examples. Surprise, Democrats don't also harp on the fact that, oh, yeah, this is lagging again. Don't also harp on the fact he owes about $500 million, from the business fraud judgment? Where do you think he's going to get that from? Now, maybe in context, you could figure out who he is if you've been following the news, but if you haven't, oh, sorry, bad animation, we fill in the fact that it's Trump and a couple of other corrections here. And here, what an ugly war, which war is ugly? So we fill in some context, not at war, but in here in the next sentence, this is talking about two cities in Ukraine, which are the subject of the article. Okay. So there is maybe an error here. This says, surprise Democrats don't also harp on the fact. And when you remove this from its context, there's not also anymore. There we're talking about something else that Democrats harped on. So maybe that word should have been deleted, and we should improve the prompt. Okay, so your mission here in the prompt, we put in a persona. You're a journalist who wants to quote a certain social media post. Of course, you're not really a journalist, you're a user interface, but we tell it it's a journalist. And we say, read the final reply below in the context of its thread. Consider whether a reader would be able to understand the final reply. If it were shown all by itself, then rewrite the final reply so that it can be understood on its own. Can the topic be deduced easily by a newspaper reader? If not, please start your rewrite by directly stating the topic, or else naming the thing that's under discussion, or else quoting a small amount of material from it with appropriate tags. So in general, your rewrite shouldn't assume that the reader has read the previous posts. So specific things to avoid are pronouns, elliptical references. Your rewrite shouldn't sound like a reply. It shouldn't address the previous poster directly, although it's okay if it addresses Joe Biden and tells him to stay in or drop out. Don't remove all pronouns, I and you are fine. You know, you can see the effects of some engineering here trying to correct errors that this thing makes.
Quick question. I mean, yes, it's good to have phrase all this. It might be also good to have a few short examples, right?
Yeah, so we tried a little bit with few shot examples. The older models, like GPT-3, are less instruction tuned. The newer models in instruction tuning have lost some ability to follow few shot examples. So, you know, something like, Llama 70B would still benefit from few shot examples, I think. Yep. Yeah. We didn't play that much with the engineering. Yeah, Paula.
So I have a question. So if there are posts that are not well written, for example, like me, that I usually make a lot of mistakes when writing, especially in English, will they be corrected, or what is going to happen?
Well, let me ask you what you would want. Do you want a heavy hand or a light hand on the rewriting, as a non-native English speaker? But a fluent one.
I don't know. That's
All right,
that's
think
the
about
answer.
it and tell me after. I mean, this is a real decision to make.
Because I was just thinking about your previous example.
Yep.
Where you put the also. For me, it sounds correct. I mean, for me, it sounds
well,
correct.
what we would do if we took it out would be we would put ... there to say that something has been removed. And the reason is the also is referring to the previous discussion. So it wasn't an English error.
Yeah, I understand that. But I also think that depending on the cultural background or, for example, if you're from Mexico or another country, you usually express yourself in different ways, right?
Yep. So our attitude toward this is that for cultural reasons, but also for another reason I'll get to, we wanted to do minimal rewriting. So it's okay to fix obvious typos, and the goal is to decontextualize, but this says, let the author speak to the rest of your audience, not the previous poster, but like the rest of the site, in their own voice. And we'll say more about this. Okay, so the other reason So there could be cultural things that this just doesn't understand, like the LLM is not perfect, so we should be conservative. But the other reason is we don't want to chase people away. I mean, people already say, I'm quitting this site because somebody censored my post. I'm quitting this site because there are too many people here from the other political tribe. So we want to take a light touch. And the idea is we're not telling people what to read or what to think. We are just showing them what other people on the site are saying.
Okay, thank you.
Yep. So make minimal changes, that's the next bit of this, to make the final reply suitable to print in your supposed newspaper as a comment that can be understood by your readers. So this is saying don't over-edit. And it turned out to be hard to get this right. I should show you examples of previous and versions of the prompt, but this is the we mean it, don't over-edit. So here's a few more paragraphs. Shouldn't alternate the substantive argument, alter the substantive arguments. It should produce the color, wording, and style. You are not the author of the post, GPT 4.0, so take a light touch. Here are some things not to do. In short, when the original text is understandable, leave it alone. It's only the things that become worse when you take it out of content that you're supposed to fix. So there were 4 words that actually helped here. These made the difference, and maybe we could take out a bunch of the others. So it kept like rewriting things too much in this ponderous style. Turns out that if you put this in, it helps. So at least it knows the wrap on itself. Yeah.
If I was GPT-4 and I saw this, my response would be, edit your own post.
Sorry, you mean edit the prompt?
No, I'm just joking. I'm saying this is too many instructions. Just do it yourself. Don't ask me.
Oh, I see. Yeah. So I don't think we can ask the user to make 2 versions of every post. But yeah, these instructions are too long.
No, I'm speaking on behalf of GPT-4.
Yeah, well, we can also save money if we make the prompt shorter. We just haven't done the work yet to figure out which parts are essential. So this was the first one that really seemed to work. Okay, so the feedback on draft.
It's interesting that it can take such a long discursive prompt and actually respond differently.
Yeah, no, it is very interesting. So I have a little experience doing this. I used to spend a lot of time editing my co-authors' bib files, which got a lot of little things wrong. So a year ago, I wrote a prompt that GPT 3.5 follows really well, but it's quite a long prompt. It talks about all the things that can go wrong with BibTech. Okay, so again, we start this with a persona for the feedback. That's the part with the black background is always the persona. The overall thing here is the mission. So you're a wise and patient teacher. By the way, you also are a discussion moderator, and you like to see these these constructive high energy discussions where the participants substantively engage one another. And your student happens to be active on social media, and you happen to be a social media moderator, so you're going to gently offer feedback using all your teaching skills. Okay. And this turned out to be really important, this yellow thing. Don't just give generic comments that could apply to other posts. Address this particular post. So this line here is crucial. So your student is adding to the following thread. Here's the original post, reply, final reply, and now your student's draft post. And we omit this part if the student is putting in a top-level post. Animation is bad again. Okay, so we say here, fill out a form, and we found that this kind of prompting works really well. So we say, fill out the following JSON template. Now notice that this is not really JSON, this is some natural language. Just ignore this for the moment. And so we say, fill this out, where replies means this. So we give some documentation of how to fill it out. A little bit of the documentation is in line. We can put additional documentation in line. And then we describe in more detail how to fill things out. This type of prompt worked well. One call is yielding multiple fields. So we don't have to do separate calls for the praise, suggestions, and replies. So this is like chain of thought, but it's saying fill out this field first. That might influence your next field. That might influence your next field. So we have it even though we display the replies at the bottom, we have it come up with possible replies first, asking them to be diverse, that's important, before we ask it to give a summary suggestion that might be helpful. And then we put the praise at the end because we don't want it to be distracted into thinking it was a good post. Okay. GPT-4 follows our instructions well. It reads the whole template, even in placeholders and comments, so we can put a comment next to one of these things like omit the bar field if foo is greater than 0. Okay, so that was the definition of replies. Here's the definition of suggestion and the definition of praise. And this is important. Don't give too much, too long and complicated a suggestion. Don't expect too much don't expect them to write a whole essay. They're just writing a short post. Other people still get to reply and they'll continue the conversation. Okay, so now let's get into sort of the meat of the difficulty of close reading. This is where it's really impressive what large language models are able to do. So here we have a long and complicated post. And when I read this, it's hard to figure out, like I have to read it carefully to figure out what the position is that the person is taking. I'll read a little bit of it aloud. What is so difficult here? Trump is being Trump. Who else did you expect him to be? The question is, why is he there? And Thursday night, meaning a debate, gave you some kind of an answer. It has less to do with Trump and more to do with the competition. Think about it. Does anybody really believe that Biden showed no sign of illness before this debate? Both the DNC and his family cooperated with his illusion. Some might call it a lie. They shut down competition. Okay, this goes on for quite a while. There's a lot of themes here, and it's a little disorganized. So here are the arguments that were extracted by GPT-4o. Donald Trump is consistent in being himself, while Joe Biden pretends to be the savior of democracy. 1 point. Second, the DNC and Biden's family have been dishonest about Biden's health and have manipulated the primary process. And finally, I don't believe in the system. And voting isn't going to help. Okay. So we tell it to come up with at least 3 main arguments. That's a field in the JSON, but we have it fill it in last, after it's talked about all the other elements that I'm not going to give you. One thing that we ask it to bring out also, this is sort of like an argument, but it's a connection. So this is basically a summary of this comparison, but sometimes it might like compare this election to the election where LBJ decided not to run again. Good. So these are 2 fields in the JSON where we ask it to analyze a single post. We ask it to pull out evidence of these 2 kinds, public evidence and personal evidence, and pointers to recommended reading or experiences. And we ask it to pull out phrases for these things. We ask it to pull out phrases for all of these things, sentiment and values. So I talked about this on the slides 45 minutes ago. And in addition to giving the phrases, which we could embed if we wanted, we're not doing that yet, we then ask it to rate each of them. So, to what extent, given that you know that it's making the following connections, are these interesting connections? Should this go, in other words, in the stack with the connections icon? Almost every post, it's going to extract some evidence. It'll say, oh, if there was some evidence, it would be this and that. But is the evidence surprising? Is the evidence a main point of the post, or is it just something like in passing or implicitly there? So we want the things where if they show up in the evidence stack, you'll be like, oh yeah, this has evidence. In fact, in future, what we'd like to do is highlight the evidence in the post that caused it to be put in that post. And these phrases will help us do that highlighting, just using Burton embeddings and aligning it. Good. So what are you expressing positive sentiment toward? What are you expressing negative sentiment toward? So we're getting a distilled version of a post from all of this. What are your values? And then we can embed this distilled version of the post instead of the original. So we've done all this hard work to figure out what the arguments are. Then when we're comparing posts, we can do it based on the distilled version, which lists the arguments. Sorry, I'm going back again here. This is again lagging. Which lists the arguments, the connections, the evidence, the opinions and values, conclusions, which may be predictions and proposals, and any kind of framing questions and so forth. So the post looks like this, the prompt looks like this. We've got a persona again. You're a political science researcher now who knows about social media. And you're again going to fill out the JSON template, and each element that you fill out should be decontextualized in the way that we described before. So the first question that we asked is, how public is this? Is the final post commenting in the first place on matters that are of interest beyond this particular thread? So many posts are just saying "me too," and many posts are just talking about they're responding to the previous argument, but in a way which can't really be divorced from this thread, so we don't want to show it elsewhere. Or it's not on a topic of public interest at all. It's just, here's photos from my picnic last weekend. So if it's not a public post, we don't want to show it in related stacks, and we tell it, don't answer the remaining questions. All right, so we ask what the arguments are. I'm not going to go through these in great detail. This is produced near the end of the LLM output and says, don't restate all the other stuff as arguments. Just what are the main things that the post is trying to convince the reader of? To support its claims, what information does the final post provide that could be verified or falsified by an ordinary internet user, or from their own personal experience, or from other sources? For sentiment, what is it explicitly or implicitly supporting? Who or what is good and should be supported or strengthened? What is bad and should be opposed or reduced? And what values does it explicitly articulate? And similarly for predictions and proposals and framing. And we extract the questions. And as I said, we get numeric ratings as well. And that includes not only the things we extracted, but also stuff like how much is the post trying to be witty, and how much does it succeed? How engaging and well-written is it? Does it seem to be dishonest or toxic? So these will raise and lower the quality, or at least we think we do. We'll tell you later how we start using human supervision to figure out how much to trust the LLM scores and how much weight to give them. So why do we extract all these fields? So does post Q add evidence or claims? Does it agree or disagree? Does it have other features of a good post? The LLM is predicting the answers directly, or maybe it's just providing features for a machine learning predictor. So it gives numerical scores that are interpretable. It gives phrases that can be embedded, and we want to use those predicted things from the LLM to make downstream decisions. Now, we can't run the large language model at runtime. Every time you click, imagine running it on all these posts. But we can run it on every post when it arrives at the server. And we can also use the LLM results to as training data to supervise faster, cheaper distilled models that run just on ordinary embeddings. Okay, so we don't have to run on all the posts. We certainly can't run on all the pairs. We can't run on n-squared pairs ahead of time. That's for things like relevance. Is it in the related stacks at all? And is it specifically in the agree stack or the disagree stack? But we can run on a sample to get training data for a distilled model. So I won't do this in any detail, but in our post that looks at pairs said you're a social media user trying to understand the world, and you appreciate posts that broaden your perspective, particularly if they're accessible and engaging. And you're a good reader, you pay attention to allusions, implications, and Palla's favorite topic, sarcasm. We sometimes pick up on humor and not always. It's reasonably good, but there are cases where I've seen it miss it. Okay, so we say you've just read the thread above, and you happen to see the following comment on another website, and we show the version that the reader will actually see, and we also provide the main arguments as previously extracted. And then we ask it again to fill out a JSON template to help us decide those questions. So is it relevant? What contributions did it make, specifically as phrases? How much added value is it? Are there any pieces of the post that it's supporting? If it's opposing, what kind of thing is it opposing? Evidence, values, sentiment, logic, whether you should be talking about this issue at all, or what you propose. So there are many levels on which you might disagree with another post. And then after talking about the opposition type, what are the elements that you opposed? And then finally, some rating about like how much is this explicitly agreeing or disagreeing with the views of the other post. Okay, so over to Cheng Cheng. How are we? Yeah, right, okay, good. So this follows on the thing next, so this will be a little less than 10 minutes. So we'll get our 10-minute break at 3, and then we continue to 4:35, I guess?
4:30.
Okay, well, we start 5 minutes after.
4:30.
4:30.
Okay, so I will present our annotation framework. The first question is, why do we need this framework? The answer to this question is we'll try a lot of versions of various prompts. And as you have just seen, we have rewrite, we have summary, we have distill to extract arguments, and we need to judge a lot of unary scores, including humor, engagingness, and relevance. So we need to run prompts that assign one post or a pair of posts. And we need some information from this post's metadata, including their ancestors, which are the context of this post, and potentially some other metadata like timestamp. So how do we assemble these prompts at runtime? This is one template of our prompt, Unary 1.0. So we have two positions awaiting interpolation into the prompt, which is post.ancestors and post itself. We can do this really easily with a Mastodon server. We get information from Mastodon and we template our prompt, feed into large language models, and get our results. However, prompts may depend on other prompts. Suppose we have in this kind of scenario, we want to extract the topic of each post and compare any pair of posts with another large language model call. We have S, which is post 0's topic, and T, which is post 1's topic. And we want to know the relationship between T and S. So how should we do this? We can save the results of the topic prompt into a file, and we load from file and insert again. That's not a smart way to handle this. So this is our first bottleneck. We want to handle dependence, and we want to template our prompts appropriately. Here, our solution is using Ginger 2 templating engine. This makes us can do two things. First, interpolate attributes of the given post. Here we listed 4 ways to interpolate our information into the prompt. If you just want the text of the post, we can just write a post inside double curly braces. If you want ancestors, post.ancestors. If you want to insert the unary, the output of the unary prompt into the new prompt, we can call post.unary. And if post.unary returns a JSON output and you want the fields called humor inside the JSON, you can post.unary.humor. So this dotted string syntax makes us really flexible to get our results. And second, you can use Python-like syntax for tests and loops. If you want to organize your proposals, the proposals you get from the unary prompt in a way in the new prompt, you can write a for loop and organize them in the prompt. So what can we do now? This is a prompt from our distill 10 from our our prompts. And here we can specify the model. If you want the annotation to be annotated by GPT-4o, you can specify here. And if the publicness is 0, we don't do anything. And if it's not 0, we get the arguments and we organize them in some way. Okay, so this is how we are handling our templating and dependence. A second problem is we have a large team, and we want to annotate together. We want to use a large language model to generate data to train Stacky, and we have to experiment with prompts to know which prompt is good. And prompts may call other prompts. So here we need somewhere to cache our results. How should we do this? We store our annotations in the graph database. A graph database consists of saves annotations into triples, and each triple have 2 nodes and 1 edge. 2 nodes represent 2 entities, and the edge represents a relationship. So now with the database, we save a lot of money with running the same prompt or even a similar version if the changes are small. The third problem we're handling here is the version management. Suppose any wants to use a prompt like, I want to use your prompt's results in my prompt, and Jason is still editing his prompt. So I will write post.unary2 in his prompt. This will help us to fetch the highest 2-point star version in the cache. If there's no cache hit, it will run the highest version that exists. Let's suppose it's 2.4. And then Jason added that. So we have a 2.5 now. We want this 2.4 to be automatically updated to 2.5. So how can we handle this? We save all our information needed to run the large language model call in a YAML file, including prompt template, control parameters, refers to model, temperature, legal answers, and we named our YAML file in this kind of way. Name followed by major version, followed by minor version. So when we are calling different prompts, we can use post.name for the highest version of the prompt name. And we can use post.name2 for highest 2-point star version. Finally, that's a large language model backend. We have OpenAI models, we have Llama 3AB, and we feed our interpolated prompts into large language models, get responses, filtered by legal data format and legal answers, cache the prompt version, and share into the general database. So to sum up, this is our annotation architecture. We use Jinja 2 for templating. We use Jinja 2 and YAML to resolve dependence and do version management. And we use graph database and JIT to facilitate team collaboration. Here are some of our examples of the YAML. This is the first part of it. You can specify what model you want, what temperature you want, and here the alias refers to how you want to write your prompt inside, how you want your version inside your prompt. Here distill is distill 1-point star, so you can just write distill in the prompt, and we will automatically send you distill 1-point star. And another part of the control parameter is how you want your answer. Here we want our answer to be JSON, and we do not want to filter any answers, and only want one answer from large language models. And you can write your prompts for control. For example, here, this name prompt, we're just looking for the numbers of the ancestor for this post. If it has no ancestors, it is called post. It only has one ancestor, so we call it reply. Else we call it final reply. Here is another example of thread to also for control how you want your prompt to be shown. We get our ancestors and organize them in some way using the for loop. So finally, you can write your prompts. You can be really free here. We organize post thread just like what I just showed, and you organize the post name how you want it to be called, post reply or final reply. Then you feed this whole prompt into large language models and get your results like this. Okay, so this is our large language model annotation framework.
Detailed question, but maybe it's unimportant.
Yeah.
You're interpolating the output of one prompt into another one, right?
Yeah.
So is that recursive? If that one in turn needed something, would you go deeper? And if the answer is yes, then how do you check against circularities?
So we save our annotation into the database. So we first look into the database to see whether
The answer is yes, by the way.
Yeah.
Okay, so we first look in the database to see whether the annotation has already existed. If it already exists, we will get the results from the database and interpolate it into our prompt. If it doesn't exist, we'll call the prompt and call large language models and get results back.
Okay, and how do you check against circularity? I mean, if you keep going, will it come back to this prompt? Or?
I do not think
I
we
don't
will
know. Or
specific.
maybe that doesn't happen. I don't know. Come on up. Come on up. Yeah. No, I mean, this is standard declarative programming, so I'm assuming you guys have figured it out, but yeah.
This is an issue on the GitHub tracker that we're not dealing with for just the demo currently. So it will Stack Overflow if you have a recursive dependency, but we'll fix it by static analysis in the future. Yeah.
Okay, so Sanjay, do you want to give instructions for the break?
All right, break instructions are simple. We take a 10-minute break. The caffeine has been refreshed. There's still a little bit of goodies left from the morning, like whatever. And I'll call you guys back in about 10 to 12 minutes. We'll resume in 15. Yeah.
Do you want us to wrap up?
No, 4:30 for everything. No, that starts at 4:30. Yeah. Basically, you guys should be done by 4:30. And yeah. Exactly. No, what I meant is people have been asking questions in the middle. So if we run out of time and it's already 4:30, that's not bad.
Yeah, we're going to be fine.
No, I didn't mean to be mean.
We should have got the Agora. Well, you should ask Sanjay for this.
conditional on what that is. If it's written, put it there. Like, skip this if food bigger than 0, right? So now, if this is coming from France, then it should be a conditional in your dependency. Then you will start doing the cases as static. You can't even do that. Or you do all cases.
It's a very interesting problem, and I think people. On a good day.
Sometimes you do that. Funny,
Yeah. Sanjeev, the issue that the delays, was it common between...
I don't know where it's coming from. Let me do this. Let me check what all is running.
So
not have an issue because
I closed it. Let me open it again.
no, let's do something very specific. Where is that PowerPoint file that you guys are using? Is it on this desktop?
Oh, I think it's online, so we can download this. I think is that what you're suggesting?
What I'm saying is I'm going to restart PowerPoint.
Oh, okay. Actually, yeah. If you close it.
Actually, let me do this. Let me check if it is in my recent.
Or like OneDrive.
Recent items.
It should be because we opened it. Can we download it?
That's what I'm trying to do. The delay might be coming because it's coming over the network. Okay, let me do this. Let me say file. Wait, save as?
No, let me do this. This
Yeah.
is a different menu.
Okay.
So you need to click on this. Click on. Oh. No, that's wrong. I need to. No, that's the wrong place to click. I need to click on. Why is it not clicking here? That's that's the Apple.
No, hold on.
Or maybe we should disconnect.
No, just a second. We go here. Oh, here we go.
Yes, save a copy.
Save a copy. Let me say on my Mac.
Yes.
Let me go to that folder. I have CLSP stuff, workshop, 24, closing presentations, save. Okay. Let me make sure I have saved it. Yeah. We think the delay is because you're running it online, and we want to make a local copy.
Let's continue.
Okay, we'll continue with the delay because otherwise it'll mess it up. Yeah. Okay. Yeah. Okay, that's that then. So let me put this back on for a couple of minutes so people online know what's going on. Yeah. Okay. 5:30. Yeah.
I don't know.
Sanjeev, we are going to start now.
So let me help you get out of this rack and back to your slides. For the full screen, or is that what you need?
Yes.
Is that the right slide?
The one right before.
Okay.
Great. Hello, everybody. Welcome back. I hope everyone is freshly caffeinated and loosened up. It is the final stretch. My name is Katarina. I'm a rising senior at MIT studying AI and decision making, as well as science, technology, and society. I'm going to be introducing to you the annotation interface that we designed for our human annotation pilot study that we started amongst ourselves and that we plan to expand in the future. Of course, it should explain why the human annotations are necessary in this context. We have plenty of machine learning systems that we are building, and for the purpose of identifying what posts should go at the top of a stack. And we need to know if we're doing a good job. So if we have an understanding of what humans believe are high quality posts that they would like to see, posts that add to the conversation, then when we build our LLM-based models or our vector-based models later, which you'll hear about more in future sections, we can identify the gaps in performance and measure them and improve upon them. So in our mission to build this human annotation interface, we decided we wanted to mimic what an average user would see when they go onto Stacky, which is to say you have a blue focus post on the left side here with the ancestors above showing the context of where that post comes from, as well as a list of posts along the right side showcasing what could be potentially useful or relevant to that context. Now, what the human annotations would help determine is the order of posts to show within each individual stack, which you heard about earlier in Sugu's presentation about how the backend processes these scores, which are what the machine learning models are providing. When we all sat down around a table and annotated, the instructions that we gave to ourselves and we plan to give to future annotators are threefold. We give each other three main tasks. One of them is to divide, given a set of posts, divide them into three absolute tiers. The top tier of posts are a set of posts where reading any one of them would be an excellent contribution to the conversation on the left side with the blue post. Perhaps it is offering more evidence for an argument that the person in the blue post is saying, or perhaps they're disagreeing substantively and are providing a very good reason to perhaps reconsider a decision. The posts in the middle tier are ones which are on topic, perhaps just generally saying, I agree because of XYZ, but maybe they could be counted rather than actually read because they're not quite as substantive. And posts that belong in the bottom tier are posts that are off topic or perhaps just so poor quality that it would be embarrassing for us to show them in a stack in the first place. This is our first task. We want some absolute notion of ranking. But we also want to ask our annotators to, within each tier, rank posts relative to each other. So produce an ordering, in other words. And finally, the final task we ask our annotators to do is to indicate whether any candidate post agrees or disagrees with the given focus post on the left side. Now, notably, a post can both agree and disagree if it's making a nuanced argument and they're talking about the specifics of it, or a post could neither agree or disagree if the post is off topic or is perhaps not making an argument in the first place. This is the end result of all of our deliberation and building of our annotation interface. As you see me scrolling down here, you see this stack of, or this list of posts along the side. You have about 8 of them, as well as 2 dividers indicating the dividers between the top tier, the middle tier, and the bottom tier. And you can drag each of these around as if they're post-it notes on a wall or on a table. And here you can categorize your posts into your 3 tiers, as well as order them relative to each other and indicate whether posts agree or disagree with each other. You'll see up at the top that one of these is called a task, and you can iterate through 6 of these tasks, which we would call a round of annotation. And once you are done, you can submit your annotation. Now, all of these candidate posts for what we want humans to annotate have to come from somewhere. And so, one moment. So we have to decide how we're choosing these candidate posts. In a traditional information retrieval system, we would ask our existing system to retrieve K documents and then have the humans re-rank what gets returned by the system. But at our point of creating our human annotation interface, we didn't have a system, so we needed to think a little bit more creatively. So our thoughts were to imagine a few other possible information retrieval systems that could return different sets of K documents and take the union of sampling from these smaller, perhaps simpler information retrieval systems to build our data set for our humans to annotate. There are a few options for doing this. You can either take posts that are nearby in embedding space, that is the embedding of the document itself, or you could take posts that are nearby in a comment thread. So if you have a root post, which indicates an article with all of its comments underneath in one thread, in one tree, posts that are nearby in the comment tree might be relevant, they might not be relevant. As you could also take posts that are far away from a particular focus post in these distance metrics. So posts that are far away in embedding space could be posts that are not about the same person that the focus post is about, but maybe they make a connection to a different topic. Or a post that is in a different article or a comment thread entirely, where the distance in a graph is infinite because it's not connected at all, but it would be a really useful comment to show in relation to a particular focus post. So if we imagine our universe of Mastodon posts, we have along the top our injected articles as root posts in each of these comment threads. The injected articles are the ones that Reva has described earlier, as well as each of the replies to them. For the purpose of our pilot annotation data set, we sampled from New York Times articles and collected our pool of focused posts, which are, once again, these blue posts on the left side. So what I'm showing here are our imagined 6 miniature information retrieval models that we're sampling from to build our annotation data set. You can imagine one which returns samples from posts from the same thread, which you'll see highlighted in blue at the top of the Mastodon cloud. You could also, what we included in our data set is posts from the same article, from the same root post, the same tree, or we could imagine posts from other articles from this focus post. We can also sample from posts that are in different articles but on the same topic. And the way we indicate whether posts are from the same topic is that New York Times very helpfully applies a consistent set of hashtags to all of its news, and we can use those to identify whether posts are on the same topic. And finally, the last set of posts we included in our annotation data set as candidates for humans to annotate are posts with comparable cosine similarity in embedding space to the posts from the same article, as I've discussed earlier, as well as the top K posts in terms of cosine similarity to the original focused post. Armed with our new data sets, we held an annotation party where 10 of us on the team sat around a table and annotated 6 rounds of about 8 posts and 2 dividers on 20 focused blue posts, around 4 to 5 articles being spanned by these focus posts. The end result of which is we annotated a collection of 239 tasks, or about 1.6 thousand annotated pairs of posts. Some observations we noticed, qualitative ones, as we were annotating, which would be useful for us to know if, as we expand our annotation ambitions, is annotation is subjective by nature, which is perhaps an obvious observation, but notable to keep in mind nonetheless. What I think is the next most important post to read might be very different from what Reva thinks is the next most important post to read. Another problem we noticed is, what if all of the posts, the candidate posts you're looking at, are equally irrelevant? If you're reading about a post on whales, or the focus post on the left is all about whales, and all of your candidate posts are about the Biden and Trump debate, how do you rank between them, decide whether one is better or worse to put into a stack? And so we address this later in our machine learning methods. Another interesting thing to note is, if you have two equally, quote unquote, good posts in a good tier, they are perhaps making substantively different arguments, but they are both good arguments. Maybe they focus on different values. If you have to order them in a particular way, you are sort of applying a certain set of values, or perhaps you just, in that task, decided to order posts by a particular metric and not a different metric. Agreement and disagreement is also pretty difficult to identify even as a human, especially in complex, nuanced arguments where people are making multiple points and maybe they agree on some but disagree on the fine points of others. And especially in sarcastic or ironic jokes. In this day's internet, someone could be making a really, really extreme position, ironically on purpose, to point out that, like, isn't it so crazy that people have this point, but still there are others who genuinely, truly believe that point. And so differentiating between whether a particular post truly agrees with a focus post or is just pointing out the absurdities in it is a non-trivial problem to solve. I'll pass the mic along to Daniel to talk about how we analyze this annotation data once we collected it.
Awesome. Thank you, Kat, for that lovely presentation. Hi, everyone. My name is Daniel, and I'm an assistant professor here at Hopkins, and I'm going to tell you about our metrics and how we went about evaluating the human annotations that Kat just talked about. Okay, just as a recap, this is what we obtained from our human annotations. On the left side, you have a focus post. Our annotators see a bunch of candidate posts, and for each of these candidate posts, they rank them based on their relevance or their usefulness to your focus post. They'll also label each of these posts with a thumbs up or thumbs down, which reflect whether these candidate posts support or oppose your focus post. One quick footnote here that here I'm gonna use the wording of support and oppose. Kat was using the terminology of agree and disagree. I'm changing the terminology because here I'm gonna talk about inter-annotator agreement, and I don't want you to confuse with agree support classification with the notion of agreement between annotators. So just change of terminology a little bit. Okay, so why are we doing evaluation? So at this point, we have collected all of our annotations. We wanna look into our annotations and see how good they are. So there are a couple of things that we can look into. For example, we can look at Andrew's annotation and see how well he matches, how consistent he is with his own annotations. Or we can look at the universe of the union of all the annotations that we have collected from our annotators and see how well the various people, they are consistent with one another. Or we can compare our annotations with our LLMs and see how well they align with each other. So I'm gonna define all sorts of metrics here so that it's gonna allow us to make these kind of comparisons in this section. Okay. So before getting into any results, let me tell you one of the key metrics that we are going to use for the remainder of our presentation. And that metric is a confusion metrics. Many of you might be familiar with it, but I'm just going to give a recap so that everyone is on the same page. Confusion matrix is essentially a matrix. Each dimension contains the set of labels that you're playing with. In this case, let's say our task is annotating a bunch of things into two labels, label 1 and label 2. And we have a bunch of annotations from, let's say, annotator A and annotator B. And we want to see how well these annotations, these group of annotations, they agree with each other. Okay, let's try to interpret this. Each row of this confusion matrix shows a probability distribution. So for example, if I want to interpret the first row, what that means is that if annotator B has chosen, for a particular instance, has chosen label 1 for an instance, what are the chances that annotator A is going to assign label 1 or label 2 on a different occasion? And intuitively, it should be clear that if the diagonal elements of your confusion matrix are close to 1, that shows perfect alignment between two sets of annotations. So that's essentially our simple tool for quantifying agreement between two collections of annotations. And it is a very versatile way of quantifying agreement, because you can imagine that you can, if A and B are annotations from the same person, confusion matrix is going to quantify self-agreement between one person's annotations. If A and B are different individuals, you're quantifying agreement between two different individuals. A and B can also be different groups of annotations. So for example, A can be your LLM, one LLM, and B can be our union of the universe of all of our annotators, and that's going to measure the agreement between LLM and our annotators. So this is going to be one of our key measures of agreement. Okay, now let's evaluate the amount of agreement that we have in our annotations by focusing on the task that involved annotating each candidate post with support labels. So again, the setting is we are given a focus post, we are given a candidate post, and we are going to ask humans to tell us whether this candidate post supports this focus post or not. Okay, so as a warm-up, we have computed the confusion matrices for a few of our annotators. In this case, you see the confusion matrix for Jason. This is a confusion matrix for his own annotations. And you can see that Jason is pretty consistent with his own annotation. So great job, Jason. On the other hand, when we look at Andrew's annotations, well, Andrew has also done a great job. You can see that his diagonal elements are pretty high, but not as high as Jason. So maybe, well, good job, Andrew, but like not as good as Jason. So the thing that I want to quickly point out here is that just because Andrew's diagonals are not close to 1 doesn't mean that his annotations are not good enough. It just means that it might mean that Andrew has taken more subjectivity, more nuance in his annotations. Maybe he hasn't paid much attention to consistency, but maybe he's just more nuanced. After all, he's a political scientist. He actually has a book in democracy, and that's a fact. Okay. We can even create a confusion matrix between Jason and Andrew to see how well computer scientists and political scientists can agree. And as you can see, we see a similar story that the diagonals are somewhat high, which shows that maybe there is a good agreement between different annotators in our pool. So we repeated the same process for the union of all the annotators that we had. And as you can see, the diagonals for all of our annotations that we have collected, the diagonals are pretty high, close to 1. But now the question is this good enough? In other words, can these somewhat of high numbers, can there be due to some sort of skews in the distribution of our labels? And to ensure that that is not an artifact in our evaluation, we are also evaluating a confusion matrix for our random baseline. In other words, evaluating annotations against like random posts. This is more like a lower bound for our confusion matrix. And as you can see there, if you look at the diagonals, there's a big gap across all of these categories between our annotations and the baseline confusion matrix. So seems like we are doing a good job in terms of support annotation task. Okay. Now, moving on from that two-class classification, I want to talk about evaluating the rankings done in our annotations. Again, as a reminder, the setup is our annotators are given a bunch of collections of posts. As Kat mentioned, we cluster, each annotator clusters these posts into 3 tiers, good, meh, and bad. And within each of those tiers, you rank the post based on their relevance or usefulness for the focus post. Now, we can we can do this evaluation both on a coarse level and on a granular level, and I'm going to show you evaluations on both of those levels. So for the granular level, we are going to fall back on the traditional metrics for ranking in the literature, for example, Kendall's tau. Because of our limited time, I'm going to spare you of the details, and I'm just going to show you the results. Oh, the only thing that I'm going to tell you is that Kendall's tau ranges between 0 and 1. So -1 and 1. -1 shows perfect disagreement. 1 shows perfect agreement. 0 is random chance. So in ideal world, we should be much higher than 0, as close as possible to 1. And once we do this evaluation for our annotations, what we see is that our annotations are much higher than 0, which shows a good amount of agreement in our annotations. We did a variant of this evaluation where we also ignored the ranking in the bottom tier of our annotations. As Kat mentioned, when a lot of posts are very irrelevant to your focus post, really their ranking doesn't make sense. So you can actually ignore them when you want to quantify the quality of your rankings. And as you can see that when we account for those bad posts, our Kendall's tau is even higher, which was a really good news for our evaluations. Besides this, so this was more like evaluation on ranking level, like this is fine-grained evaluation. We also did a course level evaluation where we looked at we thought about this ranking as a classification into 3 tiers: good, bad, meh. And again, we can use the confusion matrix that I introduced earlier. Again, we can look at the confusion matrix produced by Jason, confusion matrix produced by Andrew, and we can create a confusion matrix between either of them and kind of examine the diagonals to make sure that there's enough agreement between the 2 of them. And we can repeat the same process for the union of all of our annotations. And again, we see that the diagonals are reasonably high. And just to be sure that this is not a fluke because of the various skews in our distribution, we also compare this against the baseline, random baseline confusion matrix. And as you can see, compared to this random baseline, we are doing a good job. So kudos to all of our annotators. Okay, so that was about just agreement within our data. The next question that is also interesting is, how about humans versus LLMs? And I'm going to just spend on that question for a few seconds. Okay, so
Daniel, question.
Go for it.
Before you go into LLMs and whatever, comparing humans with machines, did you guys look at the underlying causes of agreement, disagreement? What makes things easy or hard? So one of the questions I was thinking about is, this is something that LDC does often when they do annotations. Oftentimes, if you're not getting enough agreement, the first step is to refine your annotation guideline. And you say the way we are asking the question may not be the right way to ask. And sometimes the way is to just change the question. And so have you guys looked into, because these are decent numbers, but I'm not I wouldn't bet money on them. So any thoughts on that?
We had a lot of discussions about the sources of disagreement. We didn't, because we didn't have enough time to recourse and modify our evaluation setting. We didn't take a meaningful stab at doing this in a more systematic manner, but it's certainly something that we are going to tackle in our next steps if we are to repeat this. Thank you for the question. Okay, now let's look into some measures of agreement between our humans and LLMs. So here on the right side, I've maintained my confusion matrix between our humans just for comparison. On the left side, I'm going to show a confusion matrix between our annotators and a language model output that was prompt engineered manually by our wonderful team leader, Jason. The amount of prompt engineering here was somewhat reasonable in the sense that we looked at a bunch of posts, we modified our prompt in several iterations, And as you can see, this is version 04, so there has been several rounds of update. So there's a reasonable amount of prompt engineering, but we have not really done a systematic engineering in terms of prompts. So good enough, but maybe you can engineer better prompts. And when we look at the confusion matrix between the generations of this language models and our evaluation, we see that the numbers are not as good. Except one particular dimension here, you might notice that this particular dimension diagonal here is pretty high. And let me try to interpret this for you for a second. What this means is that among all the annotations that were labeled good by humans, generally those are recalled pretty high by your language model. Basically, your language model is always has a tendency to label things as good, which means that it has a really high recall. We don't see the precision of your language model in this confusion matrix. To see the precision, you got to transpose this confusion matrix and look at a slightly different picture. Let me finish this part. And now you can see the precision of the language model. And let me interpret this again. Among posts that your language model identifies as good, less than 50% of them are labeled good by our annotators, which means that our language model has a low precision. So in summary, the models that we were able to prompt and revise in several iterations of prompt engineering, they tended to have high recall, but they struggled with low precision, which is one of the reasons that we are not going to rely on language models directly. We are going to do some other magic that my colleagues are going to introduce in the next section. And with that, please.
Okay, thank you. I don't really have a question, just a note. When I was playing with the demo, when the model was slightly broken, some of the translations it produced was just good. So I agree that LLMs have a bias to be positive.
Yes, thank you. There might be other bugs too other than this. Okay.
We didn't actually tell you how to play with demos. There was a URL up there, but I mean the signing.
Yeah. No, what you're saying is in a translation setting, the translation often is just.
I didn't see why you were saying translation. Now I understand.
Okay. Yeah, with that, we are going to transition to the next section where we are going to tell you how instead of LLMs directly, what is the alternative that we use in order to build these systems for ranking our posts in terms of relevance and in terms of their good and bad measures. Thank you.
Thank you, Daniel. Hello, I'm back. I'm still Katarina, but this time I'm going to be going over the machine learning powering Stacky, and I will claim this microphone once again. So recall that our system needs to solve several ranking problems. To make this more concrete, once again bring back the concept of our focus post, and we have this set of candidate-related posts. And our system needs to make a decision about what order we should show these to the user. In other words, which post should appear at the top of the stack. You see an example of it in our interface in the bottom right there. So there are several metrics by which we could rank our posts. As Daniel discussed earlier, we can rank posts by usefulness or added value. You can imagine other ways to do it, also by level of support. So whether the candidate post provides support for the focus post or not. But there are also other ways of ranking posts that don't rely on external context. There are some rather self-contained notions of ranking. For example, the engagingness of a post in terms of its style and level of clarity. But let's go back to ranking by usefulness just as a running example for the rest of the talk. Our goal here is to create a system that can take as input 2 posts and output out a value, in our case, a usefulness value for every single pair of posts in our universe. After we have our values, we can then re-rank our posts based on those values. One thing we tried to do was prompt an LLM. Ask the LLM to provide a usefulness value, as Daniel was describing earlier, and use that as our metric for ranking the posts. But as Daniel has described earlier, this doesn't actually do a very good job because the language model has very high recall but low precision. It tends to label everything as positively. So what can we do about this? What we ended up doing is, given these output values, we can massage them a little bit with some learned function and change them into slightly different values that align better with a human preference or a human ranking. Now, we'll remember that we have a whole bunch of different properties that we've asked the LLMs to annotate on these posts. In addition to usefulness and support, we have things like dishonesty or engagingness, as I mentioned earlier. And this learned function doesn't have to just take in one input, it can take in an entire vector. So we can take the output of our LLM, turn it into a vector, and feed it into what our learned function is now a very shallow neural network, and try and transform the original outputs from the LLMs into scores that better align with a human ranking. One thing you'll notice here is the transformed outputs are scores, they're numbers, but our training data, our supervision from the human annotation exercise that we performed is a set of ordered posts. It's a ranking. So I will briefly pass along the mic virtually to one of our virtual team members, Tom, to explain how what objective function we use to go from rankings to scores.
Hi everyone, my name is Tom. I'm a rising sophomore here at Hopkins studying computer science. So thank you so much, Kat, for introducing the overall architecture. I think the main problem that we need to solve now is the relationship between ranking and the scores. So here's our proposal. We model human ranking as a noisy sorting problem. We sort the posts by their latent score. So when a human annotator annotates a task, for example, here you can see that he receives a focus post, several candidate posts, and 2 tier separation markers. What's actually happening is that the human inside his mind has a score for each of the posts and the markers. Ideally, the rank that he gave should be based on those scores, like this. But that is usually not the case. In fact, there's so many things that might affect our decisions, so we would like to add in the noise that models all these other aspects. For the noise, we could use the Gaussian distribution, but here we use the Gumbel distribution. We'll see why soon. It speeds up the computation. So the real ranking score is actually determined by sampling from this distribution of latent score plus the Gumbel noise. One advantage that comes out naturally from this model is independence. The score of a single post does not depend on other posts that it's ranked with. So using this independent characteristic, it allows us to train a model that only fits the latent scores of the post instead of dealing with the rankings. Okay, so what is the objective? We now know that the ranking is determined by sorting this latent score plus Gumbel term. And so our objective should be finding the right parameter theta such that it maximizes the log probability of the ranking given the score. Here, the ranking is observed from human annotation data. The score is what the model predicts. We talked about using this Gumbel distribution as the noise. Here's the reason. If we adopt the Gumbel noise, then this log probability is equivalent to sampling process that samples without replacement under the softmax distribution. Tim proved it in 2014, and using this theorem, it gave us a really nice differentiable formula. In this formula, I stands for the different ranked posts. So I1 is the top ranked post, IN is the bottom one, S is the underlying score over all the candidate posts. So we can write this log likelihood into a sum of terms using autoregressive factorization, and then back it off a bit using sampling without replacement, and then adopt the softmax distribution and some log rules to reach this really simple formula for us to train on. Let's analyze this objective further by looking at one advantage it has. So during annotation phase, human annotation, we found that posts in the last tier, which is the unrelated tier, is often marked more inconsistently among different annotators. This is explainable because when we put things inside that pile of unrelated, or not related things, we don't care too much about their relative positions. So we would think that under this Gumbel objective, this human data would encourage our model to have lower scores spread out less than the higher scores. In that way, that would explain the inconsistency within the data within the lowest tier. Because they're more close together, after the noisy process, their ranking might change more often. Okay, so in conclusion, the gap between the ranking and the score is filled by treating ranking as sorting this score plus noise term. And using the Gumbel objective simplifies our computation even more, turning the log probability into a sampling process that samples without replacement. Also, using this objective, we can explain the human data better by utilizing the data inconsistency as a source of information. So now, back to Brian to talk about what we did afterwards.
Thank you. Hi, I'm Brian. I'm a PhD student here at Hopkins. So we'll pop back out one level and come back to the system we've had before, which is this LLM score that goes from LLM annotations as features to predicted a latent score that matches human rankings. Unfortunately, this is not good enough for us because while the neural net is shallow, obtaining these LLM annotations at runtime is both time-consuming and also very expensive. So what is our solution? We're going to turn this LLM to score system and replace it with a vector to score model. Okay, what does that mean? It means that instead of prompting a text-to-text model like GPT-4 to produce text annotations or numeric annotations, we're going to embed them with a text embedding model, which is typically faster and cheaper. And then we're going to still do the same thing, try to predict a score that we try to use to match the human rankings, but this time the neural network will be slightly larger because the embeddings have more dimensions than the numeric scores we're extracting from the prompt. This also means that while we have collected some human ranking data, it will not be enough to fit the amount of parameters we have. Even though the neural net is not huge, it's still more than before. So the typical thing that people could do in this scenario, which is also what we did, is to try to distill the previous model, the LLM to score system, into our vector model. Okay, so there's also an objective function here that needs to be used to train the vector to score model. So we could fit the rankings of our teacher, and this can use, oops, the order is incorrect. So we can either fit the ranking of the LLM to score teacher model, or we can fit the numeric ratings that it predicted. And for the numeric ratings, this will be a regression loss. And then for if we're fitting the ranking, we can use the same Gumbel loss objective as we did before. Okay, so we're still in the pretty early stages of exploring these machine learning, the different methods, and then also in the middle of collecting a larger data set so we can have a more systematic evaluation. So instead of claiming results, I will describe some signs of life that we've seen in our analysis. Okay, so for fitting the LLM annotations to predict human ranking, which we have data for usefulness ranking, support, and opposition classification, we're going to talk about the number for ranking usefulness. So we measured Kendall's tau. We trained this little neural net to go from LLM score to human score. And then the Kendall's tau for the ranking agreement is about 0.53. And if you had a random baseline in expectation, the performance will have a 0 Kendall's tau. So this is saying we're able to fit the human ranking to some extent. And then in terms of predicting support and opposition, our F1 score is about 0.74 for agreement and 0.42 for disagreement. And if we optimize a classifier that doesn't look at the input, on its F1 score, it would the best classifier would predict everything as true. So everything supports, everything opposes. And that classifier would have a baseline performance of 0.4 and 0.23 F1 respectively. So we're doing better than, again, a very naive baseline. Okay, so for the second step of trying to distill the LLM to score teacher into the vector score model, I'm not going to show specific numbers, but just say that the model is able to do reasonably well by looking at the Dataset performances for both regression and classification. And a final thing that I'll note is that we observed in our initial analysis that opposition turned out to be a much harder concept to model than support. And our conjecture is that the opposition concept is really a more nuanced one than support, because to oppose another post, you would need to be talking about the same topic. Maybe you share many similar stances, but you differ in a few, maybe, but very important ways. And that is difficult to detect by large language models and also to fit a neural net to generalize to. And that is reflected also in the F1 scores and, in the F1 scores. So here's a collage of all the curves that we're doing lots of experiments. But
I should say that originally these were on separate slides and you would have had to enjoy them.
Yeah, and so we took them all out and only showed a few numbers. Okay, so with that, I will now turn the mic over to Andrew.
Thank you. I'm Andy Perrin. I'm a sociology professor here at Johns Hopkins, chair of the department and part of the SNF Agora Institute for the Study of Democracy, and thrilled to be part of this group. I'm also the rather inconsistent annotator that Daniel mentioned before. I'm sure you're shocked to hear that we actually have some concerns about the system that we've developed as well. So I wanted to talk to you a bit about where we are with this. The first set of questions that I wanted to raise are technical questions about the capacity of the system as it's been designed. The first is simply about scalability and the cost of keeping up with the rate of comments to news sites, at least. The cost, of course, in money, in time and latency of the system, as well as the cost in carbon and the ecological cost of running lots of LLM queries. The cost-benefit balance is different for sites where hundreds or thousands of people will read them versus those where just the reach is much less. And so questions about the kinds of sites we've been using, like the New York Times and Fox News that have many comments, are different from the much higher rate of comments and probably much more noise on purely social media sites like the site formerly known as Twitter, et cetera. So in those sorts of situations, we need to be able to look at more posts while quickly eliminating lower quality comments and trying to preserve counts and balance across this highly noisy comment space. We think the prototype we've developed is able to do a credible job of some of these key annotations, but the subtleties of online debate may never be possible for LLMs to recognize, particularly when we're interested in doing so at least partly out of context, the point Jason made at the beginning. We want to find posts that weren't intended to talk to a particular debate and bring them in. We haven't yet evaluated that we're scoring all of these things well with our current models, let alone on deliberately hard data sets. So the next step really is to try to engineer that and to try to understand what kind of evaluations we can do, and then trying to correct weaknesses that we discover. So we're really interested in questions about LLMs in particular. New events in the world make training on old data sets difficult. When new things happen, it's hard to use training to recognize them. My favorite four-way list of goals for civil discourse is that it be civil yet frank and accurate yet thorough. And how well can we recognize these in the context both of threads, but then eventually of externalized threads? We talked already about sarcastic, humorous, and more or less responsive comments. These are all contextual, so how do we understand the context in which these were posted? And then what is the rate and character of the errors that we generate in recognizing these dimensions? Yes, okay. So we're trying to figure out questions about how do we know what makes a quote higher, what makes a post higher quality? Who sets the standards for these, right? These are sort of questions not about the technical organization of the process, but rhetorical questions about the fact that these are all political debates in the field of rhetoric. So how do we know what actually makes a post higher quality? Who gets to set those standards? What are our own values, and what should values be set for users? And trying to maintain political balance across viewpoints or sites, because different sites, as Reva mentioned before, have more and fewer comments per item, so numeric balance itself is hard to achieve. And the goal of political balance may actually be at odds with the goal of showing higher quality posts. That is, if one side of a debate is just better than another side of a debate, we actually still want to show the sides that are arguing more poorly in order to present the best possible range of views to users. We might therefore consider balancing quality with ideological diversity, and even potentially selecting for quality within distinguishable ideological buckets if we are able to reliably do that. So we talked before about quality. What are we trying to do with quality? We wanted to talk about we talked about quality itself, that is the quality of argumentation, whether a post is factual, well-written, fair-minded, timely, and effective. But we're also interested in the coverage of the debate, presenting diverse viewpoints and groups, novel topics and proposals. So one of the, I think, arguments in political rhetoric at the moment is about the value of creativity or novelty within political debates, and making sure that we present the key rebuttals to any important point that's been made. We're also trying, though, to find goals of enjoyability. That is, we want people to actually be on this site, and relevance to the current context, and also to maintain the social piece of social media. That is, you're working with people that you either know or follow, or in other ways interact with in general. All right, so then the final set of concerns to raise are what can we do to understand the actual implementation of this and the reactions to it in the world? So one set of the kind of big premise question of the whole system is, does seeing better arguments and related but disagreeing ideas make people better at arguing? That is, does it make them better at understanding the arguments of others, and how will users understand that experience? So that's the, I don't know what we spent, $1 million question, is if we design a better social media environment that is emotionally and aesthetically appealing like social media is, but also raises these
Andy,
diverse
if the cost
questions.
was $1 million, I'm sure many people would pay it right now.
If we build this thing and people use it, does it work, right? The next set of questions is around what we would call maybe audience development. That is, if we build it, will they come? And this is a central problem with some of the sort of more boring debate sites Jason mentioned at the beginning. That is, they attract users who want to see all the sides of arguments, and they're excited by the idea of civil discourse, which means they're not actually the people that we need to reach. And so the question is, can we build that balance in to try to attract participants who might not otherwise be looking for this kind of an engine? There's other ways you could think about doing this. We've emphasized the data we've used come from commenting engines on news sites. Could they be built into the commenting engines under news sites so that you have to be part of this engine in order to comment? Those are possibilities. And then there's a whole bunch of reasons why users might simply reject the system. It could backfire. That is, exposure to competing views may actually make users dig in their heels and hold their existing opinions more strongly. I would argue rhetorically that's not a failure, that's okay, but it may nevertheless cause some problems. Iterative argumentation there may help, but shoring up commitment, I would say, as I said, is rhetorically valuable as well. Respondents may reject the interface. We've essentially deliberately increased the friction. We've made it harder to read social media because it is more difficult to engage with multiple different viewpoints and ideas, but that could also make users feel irritated, make it seem not worth the trouble to persist. LLMs make mistakes. And if users find it silly or riddled with errors, they're just not going to keep using it, right? If the error rate is too high, which may well be the case. And then finally, we've put a lot of weight on the idea of trying to provide an ideological balance. But we also have to make sure that users feel that the ideology is balanced, and that's actually very difficult because most people think that their own point of view is correct. And so they therefore consider the existence of alternative points of view to be a lack of balance. And so we have to find ways, I think, to convince people not just that the balance is there, but that the balance is appropriate. So we'll talk a bit more in the next section about future work we'll be doing to try to address some of these questions. But yes.
One question, very nice set of concerns. One more concern that comes to mind with any AI system is how much can the AI involvement be increased or delayed adaptively? Meaning, let's say there's a discourse and you show AI, but you can next day you might want to dial it down, right, or increase it. I don't know how that can be done, but
to dial it down or increase the use of the AI system in particular.
The suggestions that the AI system shows what bubbles up and what you're showing as the AI generated response, right? So, and that might be good, right, in a way, because if you think that the users are unhappy with, this is bothering me too much, next day maybe they won't be so much, right? Maybe there is some, you can adaptively dial it
figure
down.
out how much or how little to help our users.
Yeah, just enough to nudge, but not, not be in their face. Maybe.
Yeah. Terrific. Thanks much.
Okay, let's talk about next steps. So my name is Zhang Xiao. I'm an assistant professor in computer science department, and my concentration is in human-computer interaction. So that means that we, as a team, that we are not only just consider how we build a technology, but we are also interested in is how the technology build us. So as part of future work, I want to introduce 2 study plans that we are planned afterward, like after this workshop. And as Sanjeev said earlier, that this workshop is really the starting point of a grand picture. So the first kind of study that we want to run is really a usability study. So we're trying to understand all the features that we designed, all this website that we built really delivers the goal and whether people can really use it effectively and properly. So I want to introduce this kind of process that we use when we are designing our system. So we're starting with the design, and we put it to development. And this is basically what we did so far. We are trying to iterate and we are trying to make this system better. But one thing is missing here that we really don't know how the user like our system or not. So the idea of using this usability study is not just trying to get a one-step results on how good our design is, but really we want to close the loop and we want to go back to the design so we can do the better development. And ideally, we want the designer happy, we want the developer happy, and we also want our user happy. So this is the iterative design process, and this is exactly what we want to do after this workshop. So the goal for this usability study is we want to identify issues by examining how Stacky supports users in completing tasks that are related to the finding, reading, and replying to news posts. So the method we're going to use is the idea of a cognitive walkthrough, which is a study that in human-computer interaction that we often use to understand how each feature was designed and how users like the features that we're designing. So it is a task-based study where that we introduce a set of tasks and we give this task to the user and ask user to complete this task on our website. So we're starting with a scenario, and this scenario is more like a user persona and in what kind of goal that a user may have. And then we let the user to complete a task. Let's say the task could be reply to a reply of a post. And we're looking at how the user is using our website to achieve that goal. So there may include multiple steps. And one key of this kind of cognitive walkthrough is we are not only just look at how fast the user complete the task, but we let user to think aloud and to tell us what they think they should do when they're using our website. So this is more like a qualitative method, and we sit next to our user and to study how they use our website. So we're starting from the login, read a post, read a reply, write a reply, read feedback until they trying to construct their reply to feedback. And after they complete a set of tasks, that we're also interested in general, what are the difficulties they encounter, and what are the actions are kind of confusing, could we make our design better? And we use this set of like cognitive walkthrough to understand what are the challenges that we have on the existing design of the Stacky website. So we are preparing a set of scenarios and tasks that are including like we are letting user trying to explore the related stacks, and we let user to identify some disagree posts, reply stacks. So there could be a very long list, and we are trying to do it after this workshop to improve the design of the Stacky. So we want to make the designer happy, we want the developer happy, and at the end, we want our user happy. So this is the part that we designed to make this Stacky as a better website to achieve the goal that we are trying to design. But the most important thing is we have been putting a lot of thought into how do we make this better discussion, better reading, better finding, but how do we really empirically examine them? So we propose a controlled experiment. So we use this idea of like random control experiment to understand how does Stacky influence the users. So there are K2 research questions that we're trying to answer. First one is how does Stacky affect people's information-seeking behavior on controversial topics? And also we are interested in how does Stacky affect people's discussion on those controversial topics, since those are the K goal that we are trying to achieve in the Stacky design, and those two are also the two key features that Stacky is offered. So the experiment design, we are trying to use this 2x2 factorial design, where we create 4 conditions, and the user will be randomly assigned into each of the conditions to have a full experience and to participate in the discussion and read different like news posts, and we are trying to use this kind of experiment setting to isolate each of the features that we are trying to design and see how this might affect people's reading behavior and information-seeking behavior. So we will have a Stacky, which have the full feature that including the stack and the feedback. And also we will have a feedback-only Stacky that there is no stack, but we do offer people a set of features to help them to write a better feedback and replies. And we do have another Stacky version that have no feedback, but we also provide all the stacks. So we are looking at how the stack feature help people to, in terms of like diverse information seeking and participate in the discussion online. And as a baseline, so we have a traditional like newsfeed design on the Mastodon. So like the question that you may ask is, when people are going to a social media, it's a very complex interaction that how do we like tease out on all the confounding factors about this content on the social media website. So the idea that we have right now is just to build a closed word Stacky. In the case that all these 4 conditions will be initialized with the same set of posts and articles that are on controversial topics that represents a diverse view and different viewpoints. So you can consider this as a game, that everyone's starting at the same point, and we have the exact same set of articles, exact same of discussions, and we ask people to start a intense discussion on this social media. So this will be a brief introduction of our experiment procedure. We have participants, and we are trying to understand participants' social media usage habit, and also their opinion stance on several controversial topics. And then we random assign participant into one of these conditions. So currently, we are kind of designing this kind of study that not only just asks people to go to the website once, but we are more interested in how they change of their behavior and how they learn different features on our Stacky website. So we designed this kind of 14-day study, which means that we instruct our participant to spend 14 days on our website and discuss with others, read the news articles, and to participate in this kind of democratic discourse. And after these 14 days, we are interested in how this different version of Stacky would have an impact on people's behavior and also their opinions. So after these 14 days, we're gonna try to understand their opinion polarizations on these controversial issues that we present in the initial seeding of the articles and the discussions that we put on the Stacky, post on the Stacky website. So there are like a few key measures that are very interesting because of the design of the Stacky that we are looking at how people read and how people write. So the key measures of the reading, we are planning to analyze the user logs on the Stacky website. We are looking at what are the focus posts that they have been read so far. So we are looking specifically at the diversity, like whether people are exposed to a diversity perspectives, and we are also looking at whether there is a selective exposure happening, whether people are specifically just only look at the news articles that agree with their pre-existing opinions, which is kind of undesirable. And Stacky is trying to expose people with diverse opinions, and we're trying to break the bubble. And also we are looking at this kind of discovery rate. Remember, at the very beginning of the Stacky, we have a seed set of news articles, and at the end, we want to see how many articles that people really read and engaged. And also there about the quality of the posts, so we want people to read high quality posts. So there are also key measures regarding the writing. So the writing is about like how people participate in the discussion with other participants in the same condition. So we are looking at this kind of post quality, including the measures on the relevance, specificity, clarity, which are the three key measures that we use in the communication theory. And also we look at the argument quality in terms of how people construct their replies to others and their viewpoints when there's issue starting a discussion with other participants in the same universe. So, but we also want people to be engaged into this discussion. So we are looking at their frequency of posting and reaction to others. So those are the key measures that we plan to understand how people read and how people write on Stacky. And at the very last, that we are also looking at this kind of information consumption, since this is really the impact that we have on our users. So the major measures we are looking at are the opinion polarization. So we want to see whether there is a change of people's stance in terms of on these controversial topics after they use Stacky after 14 days. Although that we expect there's a very small effect, but it's also interesting to look at how this may shift people's opinion on these controversial issues. So I think there's another key measures we're interested in is after they use Stacky, whether people have become more open-minded in terms of when they are discussing these these controversial issues, their polarizing opinions could be mitigated by exposing different set of opinions and engaging the discussion with people holding different opinions. So we are looking at whether people's perception on some opinion articles and to see how people perceive those articles that agree or disagree with their pre-existing stance. So through this set of measures, we are trying to understand how Stacky have an impact on people's opinion and stance after they engage in with the Stacky features that we designed. So to iterate up the planned deliverables, the goals that we need to release all the posts, and also we want to see how people use our website. So we have a few ideas for the papers. The HCI contribution, we are looking at the result of a usability study, the social contribution, the result of our controlled experiments, and we also have a system contribution, like all the very specific engineering system that we designed and represented earlier today. And also we will have this machine learning contribution, and we're to understand how we can better annotate and ranking different posts on the stacking. So definitely we're gonna get some money to do this. So we're gonna apply different grants.
Anybody in the audience who has money, come talk to us.
I have $2.
Wait a minute, this is not the final version? This is not the version on my machine. Did you, well, autosave is off here. Yeah, so that's a problem. Can we get back to your link?
I didn't do anything, so whatever it is where it was.
Yeah, well, I'd like to close this and reopen it from your.
Yeah, let's do that.
We just need to do this.
Jason, are you sure this is safe here?
Sorry?
Are you sure that your version is safe?
Yeah, the autosave was off on this version, so I think it switched to local.
Autosave should be on. I mean, this is the new change. There you're just loading.
I'm saying he had disconnected for the one.
Oh, I thought it was.
If I turn it on, will it turn on or will it break?
Well,
No,
that's a different presentation. Yeah, just go back to your SharePoint. Okay, we only have 5 more minutes, folks.
Okay, no worries, no worries. I lost my phone. Where is it?
You need Chrome.
Wait,
Chrome is here.
All right, guys, hold on. We'll get this in a minute.
I emailed the link to you as well. But if you just go to your OneDrive, it'll be in OneDrive.
I'll get it through Paula. Is that where it is from?
That should be fine. Yep, that's good.
Come on.
Yeah. Yeah.
This one or this one?
Eisner URL. Okay, very good. I'll find it. Yes, thank you. Okay, thanks everybody. 5 more minutes. Sorry for the disruption. Okay, so in addition to user studies, yeah. All right. In addition to user studies, I have like three or four slides on other next steps. So end to end, we want to know, are the posts and feedback we provided actually worth reading? And so Zhang just talked about the user experience and measurable effect on users. We can also maybe measure some things like political balance in the posts that we show to users. So this is like fairness testing of AI when you're doing responsible AI. Also, we should be evaluating individual decisions in the interface, so fine-grained stuff. We're making a lot of decisions. Are 2 posts similar for clustering? Are they relevant and adding value when we show them in the margins? Are we classifying it into the appropriate posts? Are we showing the more helpful posts on top? Are we giving useful feedback to the user? And we need more human data systematically collected for both tuning and evaluation. And we should be testing not only with our current data set, but also with versions of that data set which have been manipulated in different ways. For example, making them more or less balanced, considering adversarial settings, and also considering other topics other than politics and other styles of post other than the kind on these sites. to make sure that this stuff is robust. Second point is improved prediction. So 6 weeks, at the beginning of this, my hair was short. Now you can see it got longer and significantly grayer. No, this is actually a super time. I would do again. The terrific team. Recommend. But now there's engineering to be done. So we have systematic prompt engineering and cost reductions associated with the use of LLMs. We should be engineering the neural architectures, and it's not clear everything should be totally neural, especially because the large language models still think Biden is the nominee. We should be doing better feature extraction. Right now, the large language model gives a number like 2. Well, actually, it has a distribution over those numbers. So in other work, I've found it useful to look at the whole distribution. It's a little softer. We should be using embeddings also of the strings that we extract. So instead of having, like a dozen features going into our language models, we could have thousands by concatenating many embeddings. And we should be getting, that's on the input side, and on the output side, we should have better supervision. We have only very, we had an annotation party one time with very unclear instructions to the annotators. We should be doing systematic training of annotators, collection of annotations, and also making use of user feedback that we can collect through the actual user interface. And then 3 quick notes on possible user interface enhancements. So these related posts, we have some proposals, some questions, we should highlight the question, some framing, we should highlight the framing. So like, what were the phrases that led to these things going into that stack? We should ensure diversity not only within the view of a stack, but also across stacks. This is a bad example where our prediction, our connection, and our values all came from the same post. And it was a highly ranked post, a high scoring post. So it went on top of all of those stacks, but that's clearly a waste of screen real estate. So we want to make sure that those are diverse. And indeed, not just across a particular view, but across your whole experience with the site. So if you just saw some posts that tended to have left-leaning stuff on, some stacks that tended to have left-leaning stuff on top, we should have a Lagrange multiplier that's pulling up the right-leaning stuff in order to restore balance. And finally, the way we do feedback now is every time it gives you feedback, it's looking at a fresh version of what you typed in. So you should really think about this as a dialogue. It makes a suggestion, you revise, it sees the history, it says, great job, how about this other thing? You make another one and it says, okay, good to go. Instead of giving you suggestions ad infinitum, it's never happy, which is the current situation. A couple other things we could do in feedback. So final comment is we'd like to get some uptake. Should we try to get real users? Could we get larger players to try to incorporate these design elements into their own user interfaces? This is a user interface project. And my prediction is that as LLMs get cheaper, a lot of user interfaces will evolve to include AI. And we're thinking specifically about how to do this for social media. But we are going to see this for other kinds of applications as well. Okay, so this was a slide at the beginning. This is our current situation. Thank you for your attention. Human curated discussion commences now.
I do have a couple of questions, but I'm going to defer to the rest of the audience first. I've been asking lots of them already. So someone else.
Chris.
So I think you mentioned it a little bit at the end, which was adversarial settings.
Yeah.
So is there currently kind of an implicit assumption of good faith among the users?
Well, there has to be because we're only working on the in-domain distribution. So we don't have any posts that would test people trying to fool the system into recommending their posts.
And even not individuals, I can imagine things like organizations or
trolls, bot farms, disinformation campaigns.
Trying to make a view that's not supported by the real world appear like it is.
Yeah, so this kind of thing is an arms race. So there's a problem that we might be opening Pandora's box by saying, if you do it just right, we'll show your post to lots more people.
Yeah, so you may need to, you said that you would like to maintain a light touch But for certain categories of behaviors, you might not.
Well, this is a different notion of light touch. So we're not, but you're right, that for things like misinformation, we may actually have to put a thumb on the scale.
Yeah.
Yep. Thomas.
That's really impressive, especially the prompt engineering. I have a question for that. So you had a lot of different roles for your agent. How did you come up with them? Did you try different ones? Are they necessary?
Oh, you mean personas?
Personas, yeah.
Yeah. No, that, we never changed those, actually.
Okay, it was just...
It was just a guess.
should it
Let's see
be,
if
but
this works.
Would you think that it makes a big difference if you would change it and say, oh, you're an English teacher, do this?
I think this kind of thing sometimes matters. I think the teacher one was the one that was probably most important because the tone of that feedback, being patient, helpful, knowing when to pull back, you have to find a way to say that concisely. And other people have found, I can find you citations if you want, the personas can actually be very helpful in getting the system to behave in a particular way.
Okay, so without personas, you would say it would behave very different.
I mean, feedback, what's feedback?
Yeah. Okay, well, the question, of course, were how would you evaluate the value of the personas, right? So in that...
We don't have a way to evaluate feedback at all yet, but what we need is metrics first, and then we can try different versions of the prompt.
And related to this, how many prompts did you...
You asked me this privately,
exactly,
and I said repeat the question publicly. So I think we had 5 main prompts.
Okay.
And then 5 prompts that call the LLM. So there's one that looks at every post to extract a whole bunch of different fields. So that prompt is doing a lot of work. It's got a long input and a long output, so it's not cheap, but at least you only have to call once. A prompt that looks at a pair of posts, a prompt that rewrites things to be decontextualized, a prompt that gives feedback, and a prompt that summarizes, and then there's a few other prompts that are basically just doing string processing. They're like remixing the results from other prompts or doing arithmetic. They don't have to call LLMs.
Yeah, how long did it take you to come up with those?
I mean, this is, it takes some experimentation, but the total amount of work on those would be on the order of 1 to 2 days, I think.
Okay. Yeah. And then related to user studies, actually, I think getting users means to get the users where they are. Right now, I have the impression that...
So maybe Andy Arizon can talk about prolific or...
that the user interface needs a lot of space, especially when people are mainly using mobile devices.
This is a problem the social scientists know how to solve.
Okay, good.
So I think this is a great question about the where we got the users. So currently, the design that we have right now that we allow online participants. So the current participant pool that we're looking at is a representative sample of the United States.
But is it representative with regard to using mobile devices or more web browsers?
So that's a big challenge we're facing right now is how do we fit this design into a mobile interface? But when we are doing this experiment, we want to make it consistent on the desktop interface. So we can constrain the users to only use the desktop at this moment.
Okay, that would limit maybe some people, right? So maybe the younger people.
Yeah.
Okay.
Younger people don't have laptops. Yeah. Sorry, I forgot to put that on the. I forgot to put that on the user interface extension slide. But this is a significant problem that we decided to ignore. That we have a 2-column interface, and unless you have one of those folding phones, which most people don't, you don't have 2 columns.
Just curious about what might be the path to get it quickly to an audience that's not, let's say, not as friendly, or I wouldn't say hostile, but because that might expose some of your.
Yeah, I mean, after we do usability testing, and there's lots of little things that we want to fix, but we could try some kind of viral convenient sample of users to get people to stress test it. Yeah, we could also just unleash the JHU undergrads.
I have another comment on prompts. I remember how happy you were when adding the "Don't talk like ChatGPT" seemed to work for you. Are you worried at all that someone at OpenAI will change the way they've been RLHFing it and that it'll stop working? Or is that do you think that the need for prompts like that is actually going to go down? if you change models to more like
So,
better
so I don't
support.
have that particular worry that they're going to be adversarial toward our system. And I think talking like ChatGPT, even if ChatGPT changes, now means a particular thing. And maybe that won't evolve. Like if ChatGPT starts talking like humans, there will still be this notion. But the point that you're making, Christian, is a very general point. Which is there's technical debt that you incur when you use LLMs, which is that you have to maintain the prompts as the LLMs update. And they don't always even tell you when they're updating. Like when we say GPT 4.0, that's not always the same model.
Yeah. I guess any ideas on how you're going to address it, or is it just like checking the performance?
Well, if we had players that had significant users and skin in the game, they would have a team to do prompt engineering. So, anybody who has a deployed system, a chatbot or something like that, is constantly running regression tests of various kinds and making adjustments in order to deal with changes, not only in the model, not only drift in the model, but also drift in the distribution of inputs.
Thank you.
Yep.
One last question.
You're over to, oh, one last question from somebody else. I thought it was you.
Yes, okay.
Paula. And thanks for your question, Checker, before.
It is not, well, I have a question about the metrics for the human-computer interaction. Yeah, I don't know what kind of metrics you are planning to use for this study.
So for the first usability study, so that is more like a qualitative study. So we ask people to interact with the system and we sit next to them. So it's more like an observational study. When user encounters some issues, then we can quickly identify the issues and we do the analysis of the entire, think aloud transcript. So that give us some idea what are the good part of the, okay.
We will fix it, sorry. Okay.
Yeah, and for the later control experiment, so I think there will be several evaluation metrics we can consider. It's more like we're gonna analyze the user logs. So the user click on the different posts, then give us a good idea of what posts they're engaged with. And there are some attributes that connect to each of the posts in terms of their quality, their stance, and in relation to the participants, their own quality. And in terms of the way that they're writing the post, so I mentioned this kind of communication theory. So that is more like a metrics that relied on human coders to assign rating on each of the replies that people are writing. And also there are some other metrics we can look at is what kind of conversation they are engaging, whether they're engaging with the people who are agree with them versus the people who are disagree with them. So that's gonna give us an idea of how diverse their discussion is.
Yeah, it's gonna be a lot of work.
Yeah.
I think. Yeah, and one last comment. I love your icons. I really love them.
Where's Reva? There's Reva. Yeah. Reva has a side hobby as a graphic designer.
Yeah.
So I want to ask the whole Stacky team to stand up and get a round of applause here. You did an amazing thing. And in addition to this group of 10, there's also 4 people who have been working remotely to various degrees, including Tom, who spoke, who's been working 40-hour weeks from his family home in China.
Thanks to the whole team again, and Paula, you're up next.
So guess what, guys? We are about to close this workshop. But first, I think I might need Sanjeev here. Oh no! Yeah, because I need to open the drive. Probably I can tell you a joke or something. Yeah, I was looking. Oh, okay. Oh no, it's not here. I don't know where he put it.
This one, right?
No, I was looking for my drive.
Oh, maybe it's in the recent.
Oh, okay, here. Oh, thank you. No. Let me see. I don't know what to do. If I should switch the presentations. No, it's just that it's on our drive. It's on my drive, but it's on his computer. So I don't know what to do. Yeah.
Is there any of these? No,
Oh,
that's
yeah.
here.
It's here. Okay, cool. We're good. We're good. So we don't have to wait for him. We're good. Thank you. So we are about to close the workshop. Oh, and now Sanjeev is here. You see? Good timing.
Chose the wrong moment to go out.
Yeah, exactly. So it has been our pleasure to have all of you here. But now we are going to talk a little bit about the next steps, right? What is going to be next for JSALT? We have two very nice surprises, and we will start with next step number 1, and I will invite Ahmed to come here.
Thanks, Paula. I think this couple of days was excited. I learned a lot about interesting projects. It's quite clear that there are a lot of work to be done, and there is an opportunity. We have been considering it for a while. So my name is Ahmed Ali. I'm a principal scientist at Sedaya in Riyadh. So basically, we are planning this year to have a 2 weeks winter school. And with a bit of luck, it can be opportunity to get the unfinished work, and all the 4 projects have an open invitation to join us for these 2 weeks. I'll tell you a little bit about the place and where is it physically and why you should consider coming beside doing great work. Riyadh is in Saudi Arabia, as you may know, which is somewhere central, so flying there will be easy. We are putting the timing after SLT, mainly for the speech community. That will happen in Macau in China, so that will be between SLT and Christmas break. So we are allocating these 2 weeks. The weather will be very nice. It will be colder than here now. So what we have in our mind right now is 2 weeks. It's a shorter version of the summer school here. We plan on December 8th and finish on December 21st before Christmas. So potentially we could have 2 tracks happening. The first track is for the 4 teams, the work that has not been finished, what you want to do, the audio LLM, the sign LLM, the social project, the LLM for science. You are all welcome, and let's talk. How can we enable and support, maybe not everybody, smaller group, we are open for discussion, and that will be happening during the 2 weeks. On a side, we plan to do a mini course like what's happening here. The first week will be teaching, so senior scientists and lecturer, you are welcome to share some thoughts of what you are considering to teach, and the following week will be for a project related to this. So with this, I would like to propose next steps. So I would like to know how many of you would like to come, because we are allocating budget and resources, and getting some indication will definitely help us. I would like to see if somebody wants to propose a small project to do during this time, propose the lectures and what data we can be studying and working forward in this. We are in the middle of finalizing some help in terms of visa, travel budget and allocation. So if we get an indication of how many of you would be willing to come, that will help us to make this estimate. And with this, I would like to ask a quick question. Suppose we will have these 2 weeks. Can I get just a quick feedback? How many of you would consider coming for 2 weeks in Riyadh with the winter school? I want to get some numbers. Nope. Okay, so 20% of people here. So perhaps this is what we can imagine, Sanjeev. And we can talk. So I'm here, my colleague Huda and Pedro will be here as well. Feel free to grab any of us after this or during the dinner and can answer any question. Thank you so much.
Okay, let me just make a comment to add to Ahmed's offer. Looking back at the past workshops, some of the most successful teams self-organized, meeting again in the December-January timeframe or next summer for a couple of weeks. The whole team couldn't make it because some people just went away to do other things after that. Some people couldn't travel, and others who were not in the summer joined them later because they figured out this is the right team to work with. And oftentimes it takes 2 or 3 of these iterations of small meetings again to really bring the thing to surface fully. So this is actually when Ahmed was talking about this 2 months ago, I was like, let's do it. And we still haven't figured out any of the detailed logistics, but we'll try to do it. So you can continue to use JSALT 2024 as your anchor for communication, and we'll loop Ahmed in and go from there.
Okay, and we also have another surprise. Honsa from BUT is here.
Okay, thank you, Paolo. Thank you, Sanjeev. This will be short, but it's about 2025. So basically, just to begin, there is quite a bit of Czech trace in the speech and language processing, like Fred Jelinek was Czech and Hinek Hermanský, the long years chair of CLSP was Czech, etc. There is, I think, the highest density of quality R&D in speech and NLP in Czechia worldwide. There are some companies, and we have done actually quite some events. Also, there was quite some track in the workshops. So it's not only here where you can. Is Czechs and Slovaks the second like nation at this workshop? If counted together, I guess it. No. Not the Slovaks from Brno, and nor from Plzeň. Okay, and there were also some outputs. So basically, the Czech guys were behind Moses, iVector, Scaldi. So the decision is to have the JSALT 2025 in Brno, Czech Republic, at BUT, Faculty of Information Technology. So whoever is there will have a taste of some really old buildings, like not US old, but Europe old buildings. This monastery started in 13th century with some Cartesian monks, and there are some nice stories about this. And we have also some modern buildings. So Brno is quite easily accessible from several places. The most convenient is surprisingly not Prague, but Vienna. Vienna is just 150 kilometers south. And well, we have the stuff that is necessary, like the labs and the lecture rooms, and there are also some places to sleep at the BUT dorms. And the more important even are the people. So basically, for the scientific program and for the proposal selection, we will have the backing of Sanjeev and Paola, and that will be myself, Lukáš, and Hinek, who is now with us in Brno, that will do most of the stuff. And we also have quite some people to help us. So we have seen Radim and Renata that showed up here. We have Silva for finances, Tomáš for the system administration, and others that are necessary to run this show properly. So for the support, well, obviously that's Hopkins, that's BUT, that's the European project Esperanto we have last year to go in 25. And Phonexia, that are the main hosts. We have secured support from the city of Brno, from the region, from South Moravia, lots of white wine, by the way. Not red, don't dare to try South Moravian red wine, not good. White is super. Brno AI, but actually there is this box where I would like to see your company and your organization logo, because this is a costly endeavor. So we will need sponsors, basically. Research is important, but there are some good things in Brno, so it's surrounded by woods. And if you just hop on a tramway or on a bus, you are in the forest and you can bike, run, hike, whatever you want. There is good food, Czech, of course, but also lots of international one, and beer. That is no more €1 per half a liter. I'm sorry, but €2 usually would do, and it's much better than the US one. And so the tentative schedule is the following. It's pretty standard. We will solicit proposals with the deadline at the beginning of October. Then the screening, and etc. The important dates are that we will be running from June 9, the summer school, and from June 23rd, the workshop, and we should finish August 1st, so it will be shifted by, I think, 2 or 3 days compared to this year. So, to-dos, potential time leaders. This is the most important. Please think about good proposals, good topics, good people for 2025 talk to Sanjeev, talk to me. There will be official call for papers with some email address, so please react. And sponsors, please continue your support to JSALT. Again, talk to Sanjeev or talk to Honza. We have lots of options going through Johns Hopkins, going through BUT, different ways. So please keep us in mind.
We also accept small bills in brown paper bags.
Oh, yeah. Thank you, Paula.
So right now it's almost time to say goodbye. It has been our pleasure to have you here. You know that you will be missed, of course. The ones that that were here for almost all your life, right? Yeah, it seems that it's like forever. But yeah, we have accomplished different things during this short period. Remember that when we started the summer school, so most of our undergrads, I think all of our undergrads were here, most of our grad students were here, and we had a very lovely time learning about different topics from speech, LLMs, and we have a special session on computer vision, among others. And then the hard work started. Really, really hard work. And today, August the 2nd, we are about to close this hard work period. And you have accomplished lots of things, lots of results. I have seen all the presentations one by one, and we have them already recorded. So yeah, if you have doubts or any comments or any suggestions, you can go back there and see and take a look at the presentations, and you can also give us feedback. And right now, I want to thank all of you for being here, for your patience, and for being so an awesome, awesome team. So my clap for all of you guys. From me to you. The women in JSALT, okay. Where are the women? Thanks a lot, thanks a lot. We had an amazing time and we are always empowering each other, okay? Remember that we have each other all the time, okay? Woo, yeah, one more clap for us. Oh, the plenary lectures. So we had 7 plenary lectures. Thank you to Lale, Megan, Gordon, Hansok, Deborah, Alberto, and Dan for all their lectures and their wisdom in different topics. So they are not here, so we already clapped them, okay? So that's fine. And our staff, all of them, I don't know if any of them is here. Probably no. Oh, they disappeared already. Oh. They're probably arranging dinner. Yeah, they are already there. Yeah, I'm sure. Yeah, so we have Karen, we have Julia, we have Ruth. Yeah, Ruth is Ruth, yeah. It's just amazing. Maya and Dan and Dino, they are part of our staff and they deserve a good clap, please. Even though they are not here. Yeah. And if you see them around, thank them, please. They have been also amazing. And our JSALT volunteers. So Brian and Dominic, where are you? And Ron is not here. But, thanks a lot, guys, for being so patient with me, organizing the videos and the recordings and everything for during the first weeks. You deserve my admiration. Yeah. Thank you. Thanks a lot. And our CLDT staff over there at the very end. So, Brandy, the mastermind behind all of these recordings and everything, making all my dreams come true in terms of the recordings. And Marshall as well. I know that Pete started like our conversations, and I don't have your picture here, Pete, but yeah, I know that you're there. And also Brad, that was here sometimes. Okay, thank you so much, guys, for everything. And of course, Rockfish, CLSP Grid, and others. We have to thank all these people, right? Yeah, we don't have to clap to them for the clusters. And of course, we have to thank the mastermind behind all of this. Thank you. Yeah. Stand up, please, Sanjeev. You not always receive. Thank you for giving us the opportunity to come together, do research, and be passionate about it. And yeah, thank you, all of you, and see you at dinner, okay? Okay? No.
Wrap up here. One thing of note for all the workshop participants, the labs will be cleaned out over the weekend. So if you have any personal stuff over there, take it out tonight and leave it as close to as how you found it. If there are little things left over, don't worry about it, we'll clean up. And Ruth has sent instructions. Where is Jiri? Jiri, you asked about clearing out for tomorrow. There was a long email, everything is good. So everybody knows about checking out. If there are any issues, text me. I think all of you have my number, and we'll take care of things. But today, yes, Debbie.
There were 2 different times posted for dinner. One of these slides said 6 and something said 5:30.
Okay, so what we're going to do is at 5:30, we're going to get together and take team pictures. And with so many people who are all independent thinking people, it's hard to get them to actually stand next to each other and face one way. So that'll take us about half an hour. And once we're done with that, we'll already start some cocktails and things at about 5:45, but then we'll sit down at around 6:30-ish. I mean, the thing is, it's not very regimented. This is our party. We can decide we're hungry enough and we can just start eating. So it's just that somebody will have to tell the caterers, hey, we're sitting down now. And by the way, this is something I'm a little sad about. This is not little, I'm very sad about. I won't show much of it. This is most likely Ruth's last JSALT. She's been wanting to retire for more than a year and a half. I wouldn't let her go. She finally said, no, I'm leaving. And I was like, okay, all right, fine. So, so I wanted to give her a special thanks. She wasn't feeling well this morning. That's why she's not here. So we'll do something for her offline or whatever. It's something that she can hear about from us later. But she's been terrific. She's been with us since 2012, I think. Yeah, so this is 12, 13 years, and she knows how to run this thing, and we couldn't have done almost anything without her. So we'll thank Ruth in absentia. We'll do it at the party, so that way she'll know that we all thanked her. And between now and 5:30, wrap up your things, come on over, put on your best smile, we take pictures, then we party. All right, thank you, everyone.